Right. So guys, what shape is that? Fast, fast, fast. Tell me, guys. What shape?
Circle.
A
That's circle,
Circle.
circle.
right? That's circle. All right. Just get rid of this. All right. This is our circle. What would I call this point here in? I don't want to say. If I say where it is, I'll tell you what it is. What is that? That
The
point is called
center.
what? Right.
Is after.
The center, right? The center, because it's in the center of the circle. What would I what would I call this red line that goes from the center to a point on the circumference? And by the way, guys, if you don't know what the circumference is, can we see the outer perimeter over here? I don't know if you're seeing that. The outer
Yes, sir.
perimeter, the blue, that's called the circumference. In case you didn't know, right? So if you go from the center to a point on the circumference, that is called the what?
Radius.
Radius.
Right. That is called the radius. What about this purple line here? What would that purple line be?
That would also be a radius, sir.
Yes, that would also be a radius. And for a circle, right? For a circle to be a circle, all the radii need to be the
Same, sir.
same. So guys, Faith, I think you have a lot of noise in the background. You know, a lot of noise, right? So, question: if I told you that
It
this was
says that it's off.
wait, okay, I'm not hearing any noise anymore. Right, guys, if I told you that this was 5 centimeters, what do you think this would be? Tell me, guys, what do you think that would be?
That would also have to be
5
5 centimeters,
centimeters.
sir.
Exactly, this would also be 5 centimeters. And random question: if I were to connect these points over here, what kind of triangle would I make?
An isosceles triangle, sir.
Yeah, you need to know that. By the way, if you're confused, an isosceles triangle has two equal sides, right? And for a circle, the radius is the same everywhere. So that would be 5. That would be 5. It would form an isosceles, right? Okay, next thing. Is everybody okay with the circumference, the center, the radius?
Mm-hmm.
Yes,
All
sir.
right. What would I call this green line over there?
The diameter.
Okay, do you all agree? Diameter.
Yeah.
Yeah, I would agree.
Mhm.
And why is it the diameter? What's the properties for the diameter?
It's um
Like, okay, guys, would I call this the diameter? Let me hear. Would I call this the diameter?
no.
No. Why wouldn't I call that the diameter?
Okay, basically the diameter is the circumference.
You said it's the circumference?
The circumference, like center.
Right. So the diameter needs to go from one end to the other end, passing through the center. Yeah? All right. So these are the most basic definitions you need to know for a circle, right? All right, let's move on. Okay. So guys, again, the diameter needs to pass through the what? Tell me, the diameter needs to pass through the
Center.
The center.
center. The center, right? So I have a question. Does that line pass through the center?
No.
No, sir.
No. So is it a diameter?
No.
No, sir.
No, that's not diameter. We call that a chord, right? And in real life, you can think of it like this. A chord connects 2 points, right? It connects two things together. So you know what? We have our point here and we have our point over here. So the chord, it's connecting them, right? The chord does not pass through the center. It does not pass through the center, right? I have a question. What would I call this purple line over here?
That's another chord, sir.
Yes, that's another chord. Is there anybody that's confused? Tell me, no. Tell me one time. Tell me one time.
No, sir.
I'm not hearing anybody, right? Again, I have big teeth about who bites. Or just tell me if you're confused, please, right? Okay, so that's the code. Now, guys, imagine you have a pizza, right? Imagine you have a pizza. I'm making some people hungry now. Imagine you have a pizza, right? Your mother will beat you for this. But let me just say you have a pizza. and you cut it like this. How much pieces are you going to end up with?
2.
2 pieces. Which piece is bigger? Piece 1 or piece 2?
Piece
Piece
2,
two.
sir.
Which one you gonna need? Piece 1 or piece 2?
Piece 1.
How about the rest of you all? Are you gonna need piece 1 or piece 2?
1.
Piece
Well,
2.
I eating piece 2. I eating the whole pizza if I help it. No matter what. Right? No. I'm going to shade it. I'm going to shade this region over here so that you know that is this entire thing I'm talking about. Now, anytime you have piece of a circle, we call that a segment of a circle, right? And if I'm talking smaller, right, the word for smaller here is minor. And if I'm talking bigger, what is the word for bigger? Does anybody know?
major.
Major. Right? So, guys, how much segments are you seeing over here?
2.
2 segments. Or what I call the purple segments.
The minor segment.
The minor segment.
Right? This is the minor segment. Right? Minor segment. And what would I call the red segment?
The major
The
segment.
major segment.
And let me just put on some letters here. I'll call this A and I'll call this B. What would I call line AB?
The chord, sir.
Okay, do you all agree?
Yeah.
It's saying that AB is a chord. Do you all agree?
Mm-hmm.
Okay,
Yes,
good.
sir.
Yes.
Guys, if you do interact, you're not gonna benefit from this. I'm telling you, right? If you do interact and answer questions, you're not gonna benefit from this at all. So answer, right? Talk to me, vibe, right? That's the only way you're going to learn. All right. So by now we should understand what a center is, a circumference, a radius, a diameter, a chord, and segments. Right? Now, guys, onto a tangent. Does anybody know what a tangent is? A tangent touches a circle at what? At how much points?
So it's the line that usually appears outside of the circumference. That
Okay, but if you say that, right, I could draw that. That
no,
would
I
be a
was
tangent.
I was
would-
going to say that it like it's close, like it touches the circumference but it's outside the circle.
Yeah.
Yes. So the proper thing I want you all to remember is it touches the circle at how much points? At how much points?
1 point.
Exactly, 1 point. If it's 2 points, that's a secant. Right? Right, so that's a tangent. This is a tangent. That's a tangent. Okay, guys, tell me. So I'm gonna draw a line here. Is that a tangent? Tell me, guys, is that a tangent?
No.
No, sir.
No, why is that not a tangent?
Because it doesn't
I
touch
touch-
the
It
circumference.
doesn't touch at
No.
1 point.
It doesn't touch
It
the
doesn't
circum-
touch a circle.
Exactly. What about that now? What about that though? That be a tangent.
No,
Nah.
sir.
No.
Like a kind of succinct. Why is
Yeah.
that wrong? Why is that wrong?
Because it
Because
doesn't touch the
going inside of
circumference.
the
Touches the circle twice.
Exactly. Right? Is that a tangent?
Yes.
Yes, sir.
That is a tangent.
Yes.
Right? In the exam, CXC will try to play with your head. You need to be able to know exactly what the tangent is. Right? All right, cool. Okay. Would you call that a tangent?
No, sir.
No, sir.
No.
No.
Darius, as you are hearing?
Of course, of
Ah,
course.
boy, Darius. Ah, boy, big up you. All right. So, guys, that would not be a tangent. Could somebody tell me why that's not going to be a tangent?
Because it doesn't touch
Because
the
it passes through the circle twice.
Exactly. Anytime you have a line passing through a circle twice and it's extending outwards, they call that the what?
The secant.
Right. This is the secant. Let me know, guys, before I move on, is there any one of these that you don't understand? Let me know.
I think I'm good, sir.
All right, what about the rest of you all? What about the rest of you guys? Selma,
Light work, light work.
light work? Okay, nice. On to some more properties of the circle, right? Somebody fast. What do I call that point again? Remind me.
Center,
Center, right?
Center.
Center.
What would I call that blue line over there? Not the
radius,
point.
Radius.
Right, this is our radius, right? And in a circle, all the radii are the
same,
exactly. That other blue line. What's the name of that other blue line?
radius,
The radius as well, right? Imagine this is a pizza, right? You would say that this is
a slice,
a slice. Now in maths, we don't call it a slice, eh? We call it a sector. Do you all know that?
Yes, sir.
yes, sir.
Okay, good. So a slice, right? A slice, you can think of a slice as a sector, right? And again, guys, what do I call the smaller slice? Like smaller. Anytime you see the word smaller,
Minor.
Minor sector.
right? Minor. And what do I call bigger?
Major.
Right, bigger
Major
is major.
sector.
Right. So, guys, the main property you're looking for to make a sector is that it's bounded, right, by two radii. That's the main thing. So, guys, by definition, I could say that this is a sector. Tell me if you're lost. Tell me if you're lost, guys.
No, I think I understand.
No, sir, I think I understand.
Let me explain something, right? Let me explain something.
Yeah.
Most, if you're not greedy, right? And you would typically cut the pizza and take out this slice. Yeah.
Yeah.
Yes, sir.
What if you was cutting the pizza because this is how much you wanted to leave for people and you wanted this big slice, right? This would also be a slice, just a very greedy slice. Would you do this?
No, sir.
I feel like I'm looking at. I feel like I'm looking at.
Depends.
I feel like I'm looking at me, you know, like so go do that. Maybe, maybe if it's Pizza Hut. All right. Yeah. So once the area is bounded by two radii, you call it a sector, right? So this whole thing over here is going to be a sector. This whole thing over here is going to be a sector, right? And this entire thing over here is going to also be
Another sector. Yeah.
that's going to be a sector as well. So what's in blue there, I'm going to call that the minor sector. Why? Because it's a smaller slice, right? Minor sector. And this green area over here, what would I call that?
That would be
Major sector.
Sir.
Right, that would be the major sector. Right, nice. Now, guys, does everybody know what the circumference is? Yeah, no, maybe. Can you go it
Yes,
over?
sir.
Someone. Okay, so this black line that's around the perimeter of the circle, we call that the circumference. If we are talking about piece of the circumference, specifically the outer perimeter of a sector, we call that the what? Does anybody know?
No, sir. I can't remember.
Okay, you call that the arc length. So piece of the circumference is the arc, right? So we have an arc over here, and this is an arc. And is it that we only have one arc or we have two arcs? Somebody tell me.
We have two arcs, sir.
Yeah, we have two arcs. Watch. Remember, guys, if you take this slice out of a pizza, right? Yeah. If you take this slice out of a pizza, you take that slice out. Wait, give me a second, guys.
The minor arc.
Wait, give me a second. Ariana, are you here? Ariana, let me know if you're there. I'm not hearing from Ariana, boy. Guys, I can't see the chat right now. Is Ariana in class?
It has someone called Ariana.
Yes,
The class is
here.
different.
Ariana Bihari?
Yeah.
Okay, nice. All right, let me continue, right? Okay. So, guys, if this is a pizza and you remove this slice and take out that slice, and you would also have this outer perimeter, yes or no?
Yes.
Yeah, right? And so this would also be an arc. Which arc is bigger, the one in purple or the one in red?
The
You-
one in red.
I'm
So
more
what would I
for
call the
red, so-
what would I call that small arc
Oh.
in purple?
The
a minor arc, sir?
minor arc.
Right? I'd call this the minor arc. And what would I call that red arc over there? That's really, really big.
The
Major.
Major arc.
Arc.
Right. That's the major arc. Right? Cool. That's the major arc. Right. So these are all the definitions you need to know for a circle. Right? Yeah. Do you all understand every one of them? Because you will need to. You will
Yeah.
need.
Yes, sir.
Right. Soak it in, look at it, absorb it. Right? Everybody. Because when we start the circle theorems, if you don't understand these definitions, you're going to have a really tough time. So I need to know you understand it now before I move on.
I understand, sir.
Okay. So now I'm going to pick you all up because I have trust issues. I have some trust issues, right? Right? So I want a little tell me the thing fast, right? What is that blue? What is the outer perimeter called? That blue thing called?
The
The
circumference.
circumference.
Right? Is the circumference. Okay, what is this red dot called here?
The
The
center.
point center. So center.
Center.
So I'm just gonna be drawing and I want to tell me what I'm seeing, right? What about
Okay.
this?
The radius.
Yes.
The radius.
Okay, radius.
Diameter.
chord.
No chord.
Forward. As you saw I switch up on the last minute. I saw I switch up on it. And it was like, that man gonna draw diameter. He just draw radius. It's a chord. It's a chord, guys. Right? Okay. What would I call this?
A segment.
Secant.
Nah, a segment is the area of a circle, like the area of the pieces. Now, if I cut a circle, right? Like I'm gonna explain. If I cut a circle, right, I'll have this piece and I'll have
Yeah.
this piece. Those pieces are called segments. Understand?
Yeah,
Yeah.
sir.
So a segment is just piece of a whole pizza. You can think about it like that. Right? So this line over here is called the secant. What about this? What would I call this?
That's the diameter, sir.
Okay, do you all agree?
Oh yeah. Yeah.
All right. What would I call, and I want you all to be very specific, right?
Mm-hmm.
What would I call this entire area over here in green? Be very specific when you call the name of it. You will say that it's a what?
The major
I made that
segment.
sector. Oh.
All right. No, somebody said major sector, and somebody said major segment. Right? The other way the options there. Let me ask a question, right? What is this? If you're looking at this blue line over here, what is that blue line called?
That's the diameter, sir.
Radius.
Oh,
No.
sorry, the radius.
Radius. We hear what I'm saying, right? Like, okay, forget about the whole blue line, right? From the center to the circumference, radius, right? And over here is
Yeah.
a radius. Anytime you bound a segment, right, by two radii, what is that specific segment called? Starts with S. What's S as well? It's called a what?
A sector.
A sector. Anytime you have two radii on either side, it's a sector, right? So this is the minor sector. And what I just drew was the what?
Major sector.
Yes, not segment. You'll lose a mark if you say segment. It's sector, right? Very, very sneaky. Okay, so let me just do that same example over here. Right. Yeah, so I have two radii. Yeah, so I'm gonna call this segment over here, the specific application, right, of segment. This is a sector, right? So I'm gonna call this the minor sector, and the other thing would be the what? What I call the other
Major
thing,
sector.
right? Major
Major
sector.
sector.
Cool. Right? What would I call this?
An arc. An arc?
Okay, yeah, you're correct, right? But what kind of arc?
Oh, a minor arc.
Minor arc, right? Minor arc. Right? And what would I call this arc over here?
Major arc.
Right, that is the major arc. Cool. And now again, guys, I will not be rushing anything. You're in a crash course. I presume things tough, things rough, right? The last thing I will probably want us to do is like just rush on and shove things down the thread, right? I'm gonna take my time and build a foundation. What about that pink line over there? What I call that pink line over there?
A segment.
Nah,
What?
a segment is piece of a circle. Like, okay, if I
Okay,
asked
so
you,
it has
if I asked you what this was, yeah, then you would have said a segment.
A chord.
This is a chord. This is a chord. A
okay.
line, chord is a line, not a piece of a circle, right? So this pink line over here is a chord, right? What would I call this section over here in red?
That would be the segment.
The what type of segment?
The major segment.
All right, guys, which one looks bigger? Which one looks bigger? One or two?
2.
Two. So that's the major segment, right? And what I call this?
Minor segment.
Now I just give a little prelude, right, into the theorems. And I want you to take a guess. Maybe you never do circle theorems before, that's fine. Right? But I want you to take an intuitive guess. First things first, right? What is a red line I just drew called?
The radius.
It's a radius, right?
Radius.
That's a radius. And what is this purple line called? Wait, give me a second. What is that purple line called?
Tangent.
The tangent.
And what makes it a tangent?
It's
It
touching
touches
the
at one
outside of the
point.
circumference.
It touches
the
the circle
outside
at
of
one
the
point.
circle at one point.
Exactly. It's outside the circle. Well, I mean, if it's inside the circle, right? Obviously, you'll be touching it at 2 points, right? Watch. If you're confused, anywhere I move that inside, you're going to touch the circle at 2 points. So it's a given that it's outside. So I want you to say at 1 point. That's the main thing, at 1 point. What do you think? Okay, look at this logically, right? What angle do you think is going to be between the radius and the tangent? What does it look like?
90.
A 90-degree
Oh,
angle.
yeah, that's 90 degrees, yeah.
We could see that. Anytime you could draw a square, right? That means 90. Yeah?
Yeah.
You're seeing that, right? Cool.
Hmm?
So we just covered the whole foundation of circles. This is you need to know all of these names, right? Maybe you might want to take a screenshot because now we're going to move on to the actual circle theorems. Yeah.
Uh-huh.
Right. So when you all are ready, let me know. I'm gonna move on. We're gonna look at the circle theorems. Students, you guys ready? Tell me, right? We're gonna move on. Tell me.
Yes, sir. Ready.
I think I'm ready,
I'm
sir.
ready.
All right, we ready? We ready? Ready?
Yeah.
Right.
Yeah, I'm
So
ready.
we actually just covered one of the theorems, you know. This is one of the theorems. It says the angle between the radius and tangent is 90. Was that really hard? Was that hard? I
No.
want you to tell me. No, like if you're given a diagram, do you think this would be easy to see?
Yes.
Okay, cool. So we're gonna start off with this theorem. So I want somebody to give that a read for me. Somebody give that a read for me. Need a volunteer.
Angles in the same segments and standing on the same chord are always equal.
So let me ask that question. Do we know what a segment is?
Um,
Remind me.
I know what it is. I don't know how to explain it.
All right. You know what it is.
A segment is a part of the circle, a small piece.
All piece, right? Do we know what a chord is?
A chord connects two parts of the circle.
It connects 2
A
points.
chord
It connects
connects 2
2 points.
points in a circle, not necessarily going through the center.
Yes. So guys, which one? Okay, so we have a light green, we have like an aquamarine, blue green, and then we have a dark green. Which one do you think is the chord?
Well, they both have chords.
Well, when I say the green line, that's an angle, right? I don't mean it. I don't mean like from here to here. That would be a chord, right? I'm talking about like the whole lines. So which one of these specifically is a chord? I'm saying that these two are
The
angles.
bottom green,
Yes,
the
dark green.
green.
Guys, I want you to understand what the theorem is saying, right? So they're saying angles in the same segment. First thing, we need to look for where the chord is. So guys, can we see that this is a chord? Yes or no? Yes or no?
Yes.
Right. What would I call this? So we know that this is a segment. Wait, we know that this is a chord, and as a result, it would make a what? What is
A
that chord?
segment.
Right.
Major segment.
Tell me
Just like-
something. Both of the angles are in the
Wait, can you
The
repeat that?
major segments, sir.
both of the angles are in the
The
Major
major
segments, sir.
segment.
right. So watch. Angles in the same segment. We already understand what that means. This is a chord. A chord divides a circle into uneven pieces, right? Can we all see that the angles are in the same segment? Yes or no?
Yes, sir.
Okay. And I want you to imagine these things as legs over here, right? Legs. Let me just give this a letter. Let me call this AD, right? Everybody, can we agree that AD is a chord? Yes or no? AD is a chord.
Yes.
Okay. So tell me, what is the angle I'm referring to they're standing up on? What is it standing up on?
A right angle.
No, it's standing up on AD. Watch. I want you to imagine this being a leg, right? And this is our other leg. Can you see that it's standing up on AD? Yes or no?
Yes.
Yes. Does everybody agree with that? If I say that, does that confuse you?
No.
Tell me now, you know. So we've seen that we have a chord over here, right? We have a chord. And can you all see the angle? Can you all see the angle? This is the
Yeah.
angle. All right. So you would say it's standing up on AD. All right. Somebody else, tell me, what is the other angle standing up on as well?
AD.
AD.
Right. Are both of them standing on the same chord?
Yes, sir.
Yes. Yes, it is.
Right. So let me put everything together, right? Angles in the same segment. You could see that they are in the same segment, right? And standing on the same chord. Can we see that both of them standing up on the same chord?
Yes.
Right. Darius, I see you on the camera. Big up you, boy. Let's go. Although look, Tevon over here. Tevon finally wake up from sleep. Right? So yeah, guys, anytime this is the case, the angles at the circumference are the same. So let's run through a couple hypotheticals, shall we?
Mhm.
First things first, guys. What is that red line called that I just drew?
A chord.
I'm waiting for everybody else to answer. What is that red line I just drew? What's the name of it?
A chord,
Chord. Right? And in CXC and in maths in general, we like to label things. So maybe it might have AD. So you'll say chord AD. Right? Okay. I'm going to draw an angle here. I'm going to draw an angle over here, right? What? And I'll call this O. What is that angle standing up on? So again, guys, I want you to imagine that these two things are legs. What is it standing up on?
On the chord.
On
use
what
the
chord?
chord to stand
On
up,
what
sir.
chord? On what chord?
AD.
Yeah, it's standing up on AD, right?
Yeah,
I'm going to put on another angle now. Another angle. That other angle is standing up on what?
AD.
AD.
Okay. Are both of them standing up on the same chord?
Yes.
Yes, sir.
Are both of them in the same segment?
Yes.
Yes, sir.
So, okay, if this is 30 degrees, what do you think this is going to be?
30
30
degrees.
degrees.
30 degrees.
Great, 30 degrees. Now let me run through some couple things. Let's run through some couple cases, right, where I show you what mistakes students would make. And if you're one of those, don't be scared, tell me, right? Tell me if you would make this mistake. First things first, remind me, guys, what is that? That line in red
Chord.
there, what's that?
A
Chord.
chord.
Right, we know it's a chord. We know it's a chord. That angle over there in pink, what is it standing up on?
BC.
Okay, BC. Let me ask you a question, right?
DC.
This other angle here, what is it standing up on?
DC.
DC, sir.
Can we all see that? Like,
Yes.
okay, are both of them standing up on the same chord?
No.
No, sir.
No, sir.
So can I use the theorem here?
No.
No, sir.
No,
No, sir.
students would see things like this and automatically they would just say that this is equal to this. No, 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 no. That is, no, guys. Don't do that. Don't do that. Don't do that. What you doing? If you do that, don't do that. Hear my voice in the exam telling you, don't do that. That's illegal. Hear it's one voice saying that's illegal, right? If you do this, something wrong. Nah. So guys, they must be standing on the
On the same chord.
exactly in the same
Chord.
Chord.
segments. The same segments, right? So they
Oh.
must be standing up on the same chord in the same
30
segment.
degrees.
And let me show you what I'm talking about. You're probably wondering, well, let the man give my example now. I want to see what you're talking about. But sure. I'll do your example. That red line there, what's the name of that red line?
Chord.
Chord.
AB.
Chord AB, right? Okay. This angle here in purple, right? What is it standing up on?
AB.
AB.
Everybody agree with that? It's standing up on AB.
Mm-hmm.
Okay. All right. And would you say it's in the major segment or the minor segment?
Minor.
Major segment.
Major.
I would say major. Watch. This piece over here looks slightly bigger than this piece. Can we see that?
Yeah.
Yes, that's a major
Yes, sir.
segment. Okay. What's that green angle over there? What is it standing up on?
Minor.
Minor segment.
No,
Minor
I didn't
segment.
ask what
AB.
segment.
Sorry.
Oh, sir.
On AB chord.
It's standing up on AB, right? So guys, can we agree that both of them standing up on the same chord?
Yes.
Yes, sir.
But before we get ahead of ourselves, is it in the same segment?
No,
No.
sir.
Sir.
No. But you know what this is though? I cannot give you a prelude into all the theorem. This is a cyclic quadrilateral. Do you all know what a cyclic quadrilateral is?
Oof.
No, sir.
Okay, that's okay. That's good. We'll learn it. We'll learn it, right? But guys, can I use the theorem over here?
No, sir, because they aren't in the same segment.
Exactly. Guys. Can we all agree, right, that you can't use the theorem over here?
Yes, we can't.
Right. And the reason we can't is because the green angle and the purple angle, they are in different what?
Segments.
Exactly. They're in different segments. So are we okay with the first theorem?
Yes.
All right. So guys, just to summarize that, I'm going to write the theorem here, right? So, and another mistake students make. Let me show you. Let's fast before I move on. It has so much mistakes it could possibly make, right? It has so much mistakes. All right, check this, right? By now we know that there's a chord. I'm gonna call that BE, right? That purple angle is standing up on what?
On D chord.
Chord DE, right? That pink angle is standing up on what?
DE chord.
Okay, so guys, are we going to say that this and this are equal?
No.
No, sir.
No. Can somebody tell me why?
Because the angle not touching
The circumference.
is
Exactly, it's not touching the circumference. It's not touching the circumference, right? This is an imposter, right? This is an imposter, right? Imposter. So you cannot apply the theorem here. Students make this mistake. They must be at the circumference. So I'm just gonna summarize this theorem in its entirety. So the angles at the circumference, so they must be at the circumference. And they also must stand on the what? They must stand on the
Chord, the same chord?
Chord.
right. So the angles at the circumference standing. Somebody try to finish my sentence. Standing on the
Same chord.
standing on the same chord and the same segment.
right. Standing on the same chord in the
Same.
same segment are what?
Equal.
Are equal, yes. Right? So one more example before we move on, right? Just to lock in this theorem. By now, you're not gonna ever forget it, right? And guys, an easy way to remember this one. Doesn't it look like cat ears?
Yeah.
Yeah, just look for cat ears, right? It kind of looking like a browser, like the logo for a browser, like forget the name of the browser though. It kind of looks like it. Again, Firefox, but that's not Firefox. Right? But yeah, anytime you see cat ears or like a fox, yeah, cat ears touching the circumference, you could apply this theorem, right? So one more example. As I was drawing there, boy. I was drawing an egg there. What did you? Right? Potato. Right. Guys, what does this angle look like? Just give me like an estimate. What angle does that look like?
Isosceles.
Nah, that's not isosceles, eh? I want to
Oh.
say angle. I'm talking about the angle. You give me a triangle. I just want an angle. For those of you that don't know what angle is, I don't mean it in a bad way. We learning. It's fine if you don't know what angle is, right? But after today, you should know what it is. Right? Guys, can you see that I have a pencil here? A pen and a marker, right? If I connect
Yeah.
these two at a point, right? Can you see that there's like a space between them? It's like there's a
Yes.
space between them. That space between them is as an angle, right? And if I bring it closer, the angle is going to decrease. So the angle, right? When I say angle, it's just a way to measure the distance between two connected points. So if I connect these two together, right, the space in the middle is the angle. If I bring it closer, the angle gets smaller, right? So I hope you understand that. So guys, this is our chord, right? We have an angle here. This is the angle. How much degrees are looking like? Just give my estimate.
Um,
Well, if you ask me, looking less than 90, yeah, because 90 would look like that. So it had to be less than 90, but what do you think it looking like?
40 something.
Here, what? Let me just say 50 degrees. 50 degrees, right? Let me just say 50 degrees for now. Right? What would this be?
50.
50
the
degrees.
same.
All right. What would this be?
The same.
Exactly. What would this be?
The same. It'll be
The
50
same
degrees
thing.
also.
Okay. Guys. Are we okay with this theorem? This
Yes.
specific one?
Yes, sir.
Like
Yes.
100%, right? Like after
Yes,
this.
100%.
Yes, sir. Yeah, we
Yes.
have it.
Yeah,
Okay.
I think I'm
Okay. Next one. This one will really come, right? Right? But we should know it, right? So they're saying a line drawn from the center of a circle to the midpoint of a chord is perpendicular to the chord at 90 degrees. Now, guys, do you all understand what perpendicular means? If you don't tell me, it's fine. It's fine. It's really fine. Does anybody not know what perpendicular means? Okay, anytime you hear the word perpendicular, just think 90 degrees, right? 90 degrees. That's what perpendicular means, 90 degrees too. Perpendicular means 90 degrees too, right? So guys, again, this theorem doesn't come, so I'll just gloss over it. But you should understand how it works. First things first, guys. What is that pink line there called?
Chord.
Wait, can you repeat that?
What is this pink line called?
A chord?
Right? And that is the what? What do you call that point there?
The center.
Center.
Right. So they're saying if you draw a line from the center, right, to the chord, the angle that it creates is 90 degrees. Can we see that?
Yes.
Yes,
Right.
sir.
As the whole thing behind this theorem. And I'm gonna ask a question. Will any of us say that this is the radius?
No.
No. The radius must touch the what?
The circumference.
Exactly. The radius must touch the circumference. Otherwise, it's not the radius. I'll be honest, I don't even know what you call this. I don't know. Piece of the radius. I don't know. I'll be honest. So, question, guys. What would I call this purple line over here?
A chord?
Chord, right? Let's just say I draw a line from the center. Like, okay, you have to be specific on what you're saying, right? Like, imagine this was our radius, right? Imagine that was our radius. What you're drawing there is just piece of the radius, right? So piece of the radius. So if that's the case, what do you think the angle in the middle would be?
90 degrees.
90.
Can we all agree that it's 90 degrees? Yes or no?
Yes.
Okay.
I don't
Right, so
know.
I am saying that this is going to be 90 degrees here. If that is confusing you, tell me no. I don't mind going it over. I don't mind.
Yes.
So it's just how it's structured, you know.
Yeah.
Some people might get confused.
All right, so I'll say it one more time, right? A line drawn from the center of a circle to the midpoint, the middle of a chord is perpendicular to the chord, right? So let me run through this one more time. So somebody that is confused, let me start off from scratch, right? Tell me, what would I call this green line over there? That green line, what is the name of that?
That is a chord.
as a chord, right? And they are saying that you're going to draw a line from the center to the middle of this green line. Can we all agree that the midpoint might be somewhere over here? Yes or no?
Yes.
All right. What does the angle in the middle look like?
Oh, it looks like an angle.
90 degrees.
90 degrees. Anytime you can draw a square like that, is a right angle. Tell me if you understand that.
Yes.
Let's do another
Yeah.
example. So, what would I call this line here in red?
A chord.
Chord.
Wouldn't the midpoint be somewhere over here,
Yes.
right? What does this angle look like?
90.
90. 90. All right, guys. So is there anybody that does not understand this theorem at all? Tell me now.
No, sir.
Okay, we good with this theorem? Let me know if you're ready to move on. This one doesn't come much, so I'm not focused on it too much. But if it does come, do we understand how it is work?
Yes.
Okay. Right. This one, they love to bring this one. You see this one here? They don't play with this one. They love this one. All right, so I want somebody to give this a read for me. Somebody give this a read for me.
The angle
Angle.
at the center of a circle is twice the angle at the circumference.
Right. Let me give you a practical explanation. Let me see, Baba. All right, I have a rubber band. Nice. So, guys, I'm going to ask that question, right? As the rubber band is right now, what is the angle? Right now is a line. So, what is the angle?
190 degrees.
Right. For those of you that don't know, a line is 180 degrees. Yeah. A line is 180 degrees.
Yes.
I'm going to take it and I'm going to stretch it. Is it 100? Okay. Did the angle increase or decrease?
Decrease.
What?
Increase.
No. Watch. Tell me, I'm asking something, right? What is this angle over here? This angle over here.
180.
180, right? 180. Do you think this is more than 180 or less than 180? The angle in the middle.
This time.
It's less than 180. It sounds like
Is it going away? Because it's moving away from.
exactly it's moving away. Let me clear up that confusion one time. I want to go over the concept of an angle for you. Right? Let me ask that question, right? If you had to tell me what angle do you think would be bigger? By the way, angle, you can think of an angle as the space between two lines joined at a common point. So, can you see that this over here will be the space between those lines? Yes or no?
Yes.
Yes, sir.
Okay. Just by looking at this, right? Which angle is bigger? Is it this one or this one? One or two? What space is bigger?
2.
Two. So that angle is bigger. Remember, angle come like a fancy way of saying the space between between two lines at a connected point. That's all it is. So can we all agree that this angle here, angle 1, is more than angle 2? Yes or no?
Yes.
Okay. Okay, I draw a line now. Let's just say that this was the point here. Right? Okay, 1, 2, or 3. Which one is the biggest angle over here?
3.
3.
3.
And if anybody is confused, right? If you are confused,
Because 3 is 180. A straight line is 180.
exactly what. But
So
imagine this, right? Imagine this. If you wanted to increase this distance, wouldn't you push this here and you would push this here?
Yes.
Yeah, and eventually, if you keep pushing it, what is bend? Okay, what would that turn to?
180.
It would turn to a line. Think about it, guys. If you push here and you push here, right? It's going to come in this position and it's going to come in this position. Can we clearly see that 3 is the biggest? Yes or no?
Yes.
All right. So again, angle. An angle is just a space between two lines connected at a point. So let me get back to the analogy, right? I have a rubber band here. How much degrees is this?
180.
All right. I'm going to start to pull it, right? The angle in the middle. Less than it decreasing, right? The more I pull this away, I think the angle getting bigger or smaller?
Smaller.
Smaller.
Right. And hence we could see that the space between the two rubber bands, again, is smaller. Watch.
Yes, sir.
We're seeing that. So let me explain how that comes into the theorem we're dealing with now. You'll see what I mean. Guys, what has a greater length? The radius or the diameter? Which one is longer? The radius or the diameter?
The diameter, sir. The diameter.
Right. Guys, unstretched, I want you to imagine a rubber band, right? Unstretched, any rubber band would be 180 degrees.
Yes.
Yeah. Over here, we are stretching it to the what point?
The center.
Right. And the more you stretch the rubber band, what's going to happen to the angle in the middle?
It will decrease.
No, it
Increase, sorry.
it wouldn't increase. Watch. This is 180. More I pull it, the more I pull it, the angle decreasing. So logically speaking, where do you think the angle is going to be bigger? At the center, right? Where it's stretched not as much as over here. Where do you think the angle is going to be bigger? At the center or at the circumference? Think
At the
about it.
center, sir. Center.
Right, because guys, the more you stretch a rubber band, what happens to the two rubber bands? Like watch, what is happening over here? The angle is getting
Larger.
no, not larger.
It decreasing.
It decreases. Watch. The more I pull this, right? The more I pull this, the space between these two rubber bands are getting smaller. It's decreasing. Watch.
Oh, because it's moving apart. Okay.
Right. So guys, imagine you have a rubber band. You stretch it to this, you stretch it to the center, and then you stretch it to the circumference. Remember, the more you stretch your rubber band, the smaller the space between your rubber bands is going to get. So that's why they say, the angle in the center is 2 times the angle at the circumference. And a logical way to think about it, what is that? That's the what? Like if I draw a line from the circumference to the center, what would I call that? Circumference to the center. What line is that?
A chord.
No.
Radius.
A sec. Oh, okay.
A radius. Right? And what will be the line from the circumference to the circumference? Passing through the center, of course.
Diameter.
Diameter. The diameter is 2 times what?
2 times larger than the radius.
Exactly. And the more you stretch your rubber band, the smaller the angle gonna get. So you know what? Over here we're stretching it. Let me just say 5 centimeters. We're stretching it 5 centimeters. Over here we're stretching it 10 centimeters. So in other words, right, this angle is going to be half of the angle in the center, right? Because the distance we are stretching it is 2 times the distance. So I hope that makes intuitive sense. The more you stretch something, the smaller the angle going to get.
Yeah.
Right? So with this
Say
theorem,
again.
talk to me.
You can repeat that.
Yeah, he was asking a question. Talk to me. Somebody was saying something.
I think the question is them asking for you to repeat.
Okay. Long story short, the angle at the center is 2 times the angle at the circumference. So if this was say 50 degrees, what do you think this would be?
100.
This would be
100.
100 degrees, right? I was just trying to give all you an intuitive approach as to how it works, right? The more you stretch a rubber band, the smaller the angle is going to get. So I think everybody could see, right, that this distance here is the radius, and this distance here, right, this distance here is the diameter, right? The diameter is bigger than the radius, so it comes like you're stretching it more, 2 times more actually. So that's why it's half. So yeah, guys, the angle at the center of a circle is twice the angle at the circumference. So let's run through some examples for this. And I'll show you some common mistakes students will make. All right. Now, I don't really like that that definition of this theorem, so I'll make a better one. All right. Remind me, guys, what is the name of that red line over there? This red line over here. That red line over there.
The chord, sir?
As a chord, right? As a chord. Okay. And what's the name of the black point over here?
The center.
Center.
Center. All right. E, C. Okay, guys. Let's just say the angle over here is 35 degrees, right? Now, before we do anything, let's just check to see if everything is in working order. Question, guys. Are both of the angles standing up on the same chord? Yes or no?
Yeah. Yeah.
Yes, sir.
And if you're confused, watch. Imagine his legs. Imagine his legs, right? This angle and this angle, both of them are standing up on BC. Sometimes instead of chord, you will see an arc. It's the same concept, right? Forget about the chord, guys. What would I call this? Remind me, what would I call that?
An arc?
An arc. So another way to think about it is, aren't both of the angles standing up on arc BC?
Yes.
Yeah. So guys, sometimes you'll see arc / chord. It's fine, right? It's fine. So guys, we could clearly see that both of them are standing up on the same chord, exact same chord. One is going to the where? Where is one going to? One is going to the where? Where is this one going to? What is that black point called?
That's the center.
Center.
Right? And another one is going to the
Circumference.
circumference. So we could actually use the theorem, right? So the angle at the center would have to be what? The angle at the circumference?
Equal.
Nah, not equal. Not equal. The angle at the center is going to be 2 times the angle at the...
Yeah, okay. Yeah.
Right, so if this is 35 degrees, what do you suppose this would be?
70.
70.
Right. Let's look at another instance, right? And now I'm going to remove the chord. So I'm going to make things look a little bit tricky because I will see X is going to do. All right, guys. So I remove the chord. Can we see that there's 2 angles over here? Yes or no?
Yes, sir.
Okay, so I'm making it look a little tricky, right? But it's the exact same procedure. The black angle is standing up on what? You're not seeing a chord, right? So don't say chord.
It's
Okay.
on from BC.
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 And what would you call BC? It's the outer perimeter. And it's bounded by the radii. What do you call that?
Arc.
Arc. Right? So that angle is standing up on what arc?
Arc BC.
Right. The blue angle is standing up on what?
Arc
BC.
BC.
Right. Are both of them standing up on the same arc or chord?
Yes, sir.
All right. If this is the case, the angle at the center is going to be how much times the angle at the circumference?
2 times, yeah, man.
Twice.
Exactly. So let's just say that over here is 55 degrees, right? What do you think this is going to be?
100 and
110.
110.
Mhm.
If there's anybody that needs me to go over this theorem, I need you to tell me now. I have trust issues, so we're going to do one more example, right? One more example. Because I'm just staying quiet. I don't like that. That's illegal, right? Don't be staying quiet, right? Talk. I want to talk, right? Right. And I'm going to make this one look real crazy. Just to see if I understand this. Right, so I just drew an angle, and this angle is at the what? Where is this angle? It's at the
minor. Okay.
wait, nah, this angle is at the center.
The center.
That angle is at the center. Can everybody see that? I just drew an angle, it's at the center.
Yes, sir.
Okay, cool. All right. And I just drew an angle at the
Circumference.
do you all agree? Let me know, guys. Do you all agree?
Yes, sir. Yes, sir.
Right. So I drew an angle at the center and I drew one at the circumference. The theorem says that the angle at the center is how much times the angle at the circumference?
2 times.
Do you all know that? So I'm saying the angle at the center is 2 times the angle at the circumference. Please remember this. Let's bring this all the time. Okay, guys. So according to that information, right? According to the information there, if I tell you that this is 108 degrees, would you be able to figure out for that red angle over there? Yes or no?
Yes, sir.
Yes, sir.
Right, Darius knows. What about the rest of you guys? Would you be able to figure out for that red angle over there?
Yes, sir.
Yes, sir.
What would that red angle be?
54.
54.
Excellent. Big up for yourself, Timon. Big them up, big them up, big them up. Now we talking. Mash up something there, Timon. Right, 54 degrees, right? 54 degrees. And why? The reason why I'm saying that is because both of the angles are standing on the same arc or chord, right? One is going to the circumference, one is going to the center. The angle at the center is going to be how much times the angle at the circumference? Tell me.
2 times.
2 times. So this is 108. This angle here has to be half 108. Is there anybody that still does not understand this? Tell me, guys. Look at all of the examples and tell me if you don't understand it.
I still understand. And it's how they structure it too. There were people getting real confused because like how you like now it's right there, right? I was watching it, so like when he said 54, I was like, wait, no. But then now I read back the question, and the top had to be 54, so it could be the 2 times for the underneath. So I get it now.
You see how confusing they're gonna make it, right? You see,
Yeah.
right? You see it, right? The point is, and they could move this anywhere along the circumference.
Yes, sir.
Yeah, that is what is going to confuse students, right? Because, okay, the one at the center is fixed, right? But they could move, like realistically speaking, they could move this wherever the heck they want. And the point is, you need to be able to realize Okay, one is at the center and there's one is at the circumference. So maybe one more, right? One more, right? Because we want to go through all, we want to touch all the bases, right? When I see the questions, it's not going to look pretty. It's really not going to look pretty. So we need to look at all the ugly examples. First things first, guys. I just drew an angle at the angle is at the, where's the angle?
It's at the center, sir.
It's at the center. Could everybody agree with that? We need to understand that the angle is at the center. Okay. Give me an angle.
Uh,
120.
It look like 90. Call it 90. Why not? 90 degrees. Okay. And the theorem says that the angle at the center is 2 times the angle at the 2 times the angle at the what? Somebody tell me.
the
At the what?
Circumference.
Guys, and we understand that this entire thing here is the circumference,
Yes.
and they could put it anywhere along the circumference.
Yes.
Yes, sir.
Yeah.
2
So,
times.
so watch this, eh?
Oh.
Tell me, guys.
180.
I have an angle at the center here, and this angle is at the
Circumference. Then go bring something like this?
yeah, they
They're
could,
wicked.
right? But it's not that hard. Once you see it, you can't unsee it, and it makes sense, right? I'm gonna fully understand that,
Yes, sir.
right? Okay, so they could put it anywhere along the circumference, anywhere along the circumference. And let me see if I could find a question that they specifically did that. Right? Okay, well, this is our example, right? This is how the questions will typically look. This angle here is at the what? Where's our angle?
It's at the center, sir. At the
Right.
center.
And that angle is at the,
Circumference.
so if this is 62, this could just be 2 times 62, 124. You see? I'm gonna follow you understand that.
Yes, sir.
Okay, so we good with this? We good with this theorem?
Yes, sir.
Yes.
Okay. Okay, cool. Right? Let me show you a mistake students would typically make. So, like, I could do this. All right. And like, okay, what about, guys, are we going to use the theorem here? Tell me, yes or no?
No, sir.
No.
Could somebody tell me why the theorem would not be applicable here?
Is it not on the same chord?
No,
It also
sir.
isn't touching the center.
Nah, watch. For the theorem to work, both of the angles must be standing on the same arc or chord. Let me
Okay.
explain, right? So watch. Let me just call this E. We'll call that A. I will call this B. And we'll call this C. What arc is this angle standing upon?
AB.
Somebody tell me. So we have this angle over here, right? What arc is it standing upon?
AB.
Does everybody see that in class?
Yes, sir.
Okay, cool. Next question. This red angle over here, what is that standing upon?
AC.
Are they standing up on the same arc or chord?
No.
No,
No, so you
sir.
can't use the theorem. So let me just make a little more specific version of the theorem, right? The angle. So try to finish what I'm going to say, right? The angle at the center is
Is 2 times the angle at the circumference on the same chord.
yeah, close. right? If you put any exam, you get full marks, right? But I want to be a little more specific. So the angle at the center is 2 times the angle at the circumference standing on the
Same chord. Or arc.
right, standing on the same arc / chord. Guys, let me know if we're okay with this theorem. Are we okay with this theorem?
Yes.
Are you sure?
Yes.
Yes, sir.
Okay, I wanted to unmute and say vibes, man. Say one or something. Say yes, this thing makes sense. Energy,
Yes.
energy, energy, boy. Wait. Are they really food for boxing day? But all was like this. Oh, God. Boxing day, mash all up, boy. Wait. Right. So we understand 1, 2, and 3. Let's look at this one. They love to bring this one. So who wants to read this with me? Prosea, say that. Prosea, someone if you're there.
Yes, sir.
Right.
Yes.
So Prosea, I want you to read 4 for me.
The angle between the tangent and the side of the triangle is equal to the interior opposite angle.
All right. So Prosea, let me try to understand what it's saying, right? So first things first, do you know what a tangent is?
Yes, sir.
Can we both agree that this is a tangent?
Yes, sir.
Can we both agree that this is a triangle?
Yes, sir.
Right. And what you notice about this triangle, all of its vertices are touching the what?
The circumference and the
Right.
tangent.
Right? So let me ask you a question. Between the tangent and the triangle, are you seeing an angle?
Yes, sir.
Right. So they're saying that the angle between would be equal to the interior opposite angle. That's what they're saying. So I tell my students, just draw X, and you can see exactly what to do. All you understand this theorem? I'm going to look at a couple of examples, right? But let me know if all you understand it just by looking at it here. Yes or
sir.
no?
Yes, sir.
Yes, sir.
Okay, cool. Let's apply it now. Let's apply it. Right? So, let me take up an example, right? First things first, guys. What would I call this pink line over here? Waiter? What would I call that pink line over there?
You'd call that a
Tangent.
tangent.
A tangent, right?
That's
What would I
right.
call this line over here?
That's
Secant.
tangent. What?
Secant, right?
Oh,
Okay, that's too long. I was gonna say the diameter, but no, that wouldn't be the diameter, right? This would also
yeah.
be a secant, right? Okay, cool. Now I'm going to draw a triangle inside here. And guys, the triangle, for you to use this theorem, the triangle, all points, right, of the triangle, the vertices, supposed to be touching the circumference. If it's not, you can't use this theorem. Eh? Okay, guys. So far, does it look like we could use the theorem?
Yes.
Yes. To use this theorem, you must have a tangent. Make a checklist. Do we have a tangent?
Yes, we do.
Second checklist. Do we have a triangle whose vertices touch the circumference?
Yes,
Yes,
sir.
Yes, sir.
Right, then we can use the theorem. There's nothing wrong. We could use the theorem. So, okay, I'm going to call this, I'm going to just draw a blue angle over here, right? And I'm going to draw a red angle over here. Everybody with me? Yes, sir.
Mhm.
So they're saying the angle between the tangent and the triangle is equal to the interior. When I hear interior, what do you all think of? Interior.
Inside.
Inside, right? Interior opposite. When you think of opposite, what do you think about?
On the other side.
Right? Are equal. So just draw X, right? So as you can see, we're going on the inside of the triangle, right? But opposite sides. So that would be equal there, right? And this angle here would be equal as well. Do we understand this theorem?
Yes, sir.
We sure?
Mm-hmm.
Well, here what? Let me just go through some possible ways students would make mistakes, right? But that's how the theorem does work. Yeah? Okay. All right, guys. So I'm going to draw another triangle now. Okay. Just by looking at that, does that look okay? Or it look a little sus?
No, that's us.
Does.
Because all the vertices not touching the circumference.
Yeah, what is this
Yeah.
about? Guys, if I get a question like this, just know you can't use the theorem. Please, can't use the theorem. Yeah, I think of something else, right? Imposters. All right, so you can't use the theorem over here. Is everybody okay with this one? Let me know.
Yes, sir.
Yeah.
Yes, sir.
Okay. Right? I'm gonna move on, all right? But before I do, I have some trust issues, so let's do one example. One example. To find out real trust issues, have we? Who here think they have more trust issues on me? Anybody think they have more trust issues on me? I hear somebody laugh. I don't want to ask you why you have more trust issues on me, right? But for me, it's strictly maths. It's maths. My trust issues come from maths. Yeah. But anyways, let me continue, right? So I have a circle there, and I have a what is that pink line called?
Tangent.
The tangent.
A tangent, right? There's a tangent. Okay. The first thing I want you to tell me, give me like a thumbs up. Okay, I can't see that. Give me a yeah. If we could continue.
Yeah.
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 Yeah, okay. Right. How much angles do we have between the radius and the tangent? What's the radius and tangent? I mean the triangle and the tangent. How much angles do we have?
3.
3?
Yes, you do.
Nah, not 3. Watch. We have one here. We have one here. 2. Yeah.
Oh,
I see why. Yeah.
Yeah.
Are they thinking about this?
No get
yeah.
it. No get it.
Nah,
Yes, sir.
it's 2. It's 2. Watch. I'm strictly talking about between triangle, right, and the tangent. So
Okay.
1, 2. Yeah.
1, 2, 3.
Yeah. If you go inside there, you know that's not between the tangent and the triangle. That's between the tangent and a side inside the triangle. So you gotta read between the lines. If I told you that this angle here, what angle is that looking like? Tell one, give me an angle. What angle that look?
7.
All right, we'll call it 76. Say this backwards. Don't say this backwards. Yeah, I'll cremate all at one time. Those that wasn't live. I'll get the joke. But that's 76. So I want to find for a couple of things, right? I'm gonna make this like a full question. I'm gonna call this theta. All right. 6. Okay, somebody give me an angle for this. Give me an angle.
That'll be less than 1. Please.
How much?
I said it would be less than 90, I think so. It would be
Yeah, a little looking like more than a half a 90. So probably 65 or 60.
yeah.
Well, the 60. All right. So my question. Okay, I'm just adding one more thing. 1 second. Question will be like, all right. So the question might be like, find for x, find for theta, and find for y. And if you feel like you can't do this, trust me, we have everything we need Everything we're supposed to know to be able to answer this question. Everything is there. I promise. So first things first, guys. We have a tangent and we have a triangle. The theorem says the angle in between is equal to the interior opposite angle. So somebody volunteer. What do you think angle Y is?
76.
Okay, do you all agree with Darius? He's saying 76.
Yes, sir.
Yes.
Right. And if you're having trouble with this, just draw X, right? Are you okay with that?
Yes.
Right. So angle Y is equal to 76 degrees. And you'll have to, in the exam, you'll have to state a reason for that. So Darius, could you defend your answer?
Because
So you had to tell me the angle between
the angle between the tangent and the
right and triangle, give a triangle, is equal to the what?
interior opposite.
Right? Because we're going inside and opposite of the triangle, right? So you're going inside of the triangle, but you're taking the angle opposite to 76. Right, nice. Is there anybody that does not understand how Darius said 76 degrees? Someone know?
No, sir.
Right. All right. Next one. What do you all think angle X is going to be? Somebody other than Darius. What do you all think X is going to be now?
60
60
degrees.
degrees.
60.
Right. And if you are confused, just draw the X. Can we see that the 60 degrees is the interior opposite angle for X? Yeah or no?
Yes.
Right.
Yeah.
So the reason for 60 and 76 is the same reason. And the reason is the angle between the tangent and triangle is equal to the interior opposite angle. Right? So what I'm curious now, I want to know how they're going to find for theta. It's really not that hard.
76 plus 60 minus 180, because the tangent is a straight line, so it would be a 90 degree there, and
Right.
the entire thing far line would be 180 degrees. So yeah, add them and minus it.
Yes. Did you all understand what Darius just told me? Or nah?
He said
Yes,
76
sir.
plus 60 minus 180.
Yeah, he
So
said
yeah,
that.
50.
Wait, that for anybody that still doesn't understand what he's talking about, a tangent is a what? That's what L.
It's a straight line
Right.
that
What is
touches one point at a circumference.
right? If it's a straight line, what is the sum of angles about a line? Matter of fact, what is the
Repeat
angle
that.
of a line? What is the
180,
angle for a line?
180 degrees.
Right. So my question is, if we know that this is 60 and we know that this
Yeah.
is 76, all we need to know is figure out the missing angle. How are we going to do that?
By adding 60 and 76 and minusing by 180.
That is
Yeah.
it. That is it. You find that was hard?
Nope.
No,
Nope.
sir.
That was easy. Math's easy. Math's actually very easy. Right? So that's going to be 180, right? Minus 60 plus 76. 60 plus 76 is 136, so the answer will be 44.
44.
I just be teaching maths with no calculator. Eh? I don't have a calculator in sight. I will pull up my virtual Casio just now, but this is like a very non-maths heavy topic. You don't really need to know any fancy maths for this one. That's why I start off with it. And it is like playing peekaboo or like hide and seek or like I Spy. It's real fun. Okay, so guys, if this was a CSEC question, you feel like getting your full marks?
Yeah.
Yes, sir.
Yeah.
Yes, sir.
Okay, cool. Let's move on now. So we understand theorems 1 to 4, right? 1 to 4, we good with that. Nice. Okay, this one now, it's another easy one. So somebody read this one for me.
The angle in a semicircle is always 90 degrees.
Right. Now, guys, the diameter cuts the circle in
Half.
half. A semicircle is just what of a circle?
Half of a circle.
Half of a circle. Right? So this one really easy, right? Let me just run through all of the possible mistakes students make. Right? A lot of students mix up diameter and chord, right? So let me just give you a correct example first. This black line, it goes from one end of the circumference to another, and it passes through
The
Center.
center.
so that makes it a,
Diameter.
and the diameter cuts the circle in,
Half.
right? And if you cut a circle in half, it creates a
Segment. Oh,
semicircle, right? Yeah, technically it would create a segment, but the segments would be the same.
yeah.
Right? So you say equivalent segments. Now, if I make an angle, right, in the semicircle, what is the angle at the circumference?
90 degrees.
Yeah, 90 degrees. I don't understand what I'm saying, but that confusing all the big time.
No, I think I get it.
All right. What about if I do this?
90.
How
Same
about the
thing.
rest? How about the rest of you guys?
Yes,
Anybody?
sir.
90, right? 90. Okay. What about that?
90.
Maybe the
And
same.
I think I'll see any point, right? The
Yes.
angle in a semicircle is always 90 degrees. You create an angle in a semicircle at the angle of the circumference is always going to be 90 degrees, right? But for you to be able to do this, you must have a diameter. Yeah? It must have a diameter. If it's a chord, no. No. Wait. Right? No. If you have a chord, no. It must have a diameter. So let me just show you the number one mistake students make. Right? Now, guys, doesn't that look like a diameter?
Kind of fit off-centered.
Who here tempted to say it looking like a diameter? I tempted, right? But I know better. But how much people think it looking like a diameter?
I am one. It really looks similar.
It really looks similar, right? But the
Yeah.
diameter has to pass through the what? What is the diameter to pass through?
Center.
The center.
Right? Diameter has to pass through. Are you seeing any center in this diagram?
No, sir.
No, sir.
Guys, tell me, are you seeing a center here in this diagram? I only hearing a few people. Are you all seeing a center in this?
No, sir.
No.
No, and in maths, can we assume? Could we ever assume? The answer is no. I mean,
Nah.
sometimes. But no. You're not seeing a center. So by definition, that line is actually a what?
A chord?
Yeah. This is actually a chord. So you know what? You can't actually say that is 90. You can't actually say that is 90. Maybe it might be 89 degrees. Who knows? But you can't say it's 90. If you have a chord, you're not going to use its theorem. You must have a diameter. Are you okay with that?
Yes, sir.
So like they will be real sneaky, yeah. Maybe they might bring this. If you don't see a center, you can assume that they could use this theorem, right? So guys, this is not 90 degrees. This is not 90 degrees. It might be 89, it might be 91. It's not 90. I don't understand what I'm saying, right? Or no?
Yes, I understand.
Right? So no center. This is very, very illegal. Right? I'm quote one. All right. Does everybody feel like they're okay with this theorem? Like 100%.
Yes, sir.
Yeah,
Okay.
so
Right? Anytime you see a diameter, just know you could use this theorem, right? Chances are most likely, if you have a diameter, you could use that theorem. All right. Let's move on to theorem 6 now. Theorem 6 is less frequent, but it does come. It does come. Ever so rarely, like it does come. Right? And we have, well, we already do this. And you all okay with this theorem? The angle between the radius and the tangent is 90. Yes or no?
Yes.
Are you still need me to go over this theorem or no?
Yes, sir.
Don't be scared, you know. If everybody's saying yeah, you say no, you know. If you don't understand, tell me. Okay, based on the overwhelming silence, I'm gonna take it that we okay with the last one. So truth be told, we really just have to do the other theorem, which is also very easy, right? And then we'll start some past paper questions. Yeah. How much past paper questions are they want to do on this? Give me a number.
A lot.
6.
6. I will take a little long, but you know what? I don't mind. 6. So guys, for those that don't know me, as a crazy man walking, I literally did 24 hours on maths for fun. So here they say once I have a little energy, I will go indefinitely. So like I'll give a little break at some point for sure. But like once we finish with circle theorem, we're gonna meet back and we're going to continue till we finish trigonometry. Yeah, just saying that, right? Just saying that. Right?
So I gotta be honest, I've been dreaming about trigonometry for the past few nights. I just seen all the equations. You're making me like maths, so it's a crime.
That's good. I like that crime. I'm committing good crimes. As Robin Hood at this point. That was a good one. That was a good one. Call me Robin Hood because I doing good crimes. Anyways. Let me talk about this theorem, right? So somebody, I want you to read this for me. Maybe I'll read for me. Theorem 6. Somebody give that a read for me.
Theorem 6. Tangents from a common point A to a circle are always equal in length. AB equals AC.
All right, let's try to understand this theorem, right? Guys, at this point, do we know what a tangent is? Yes or no?
Yes, sir.
Yes.
Okay. Can we say that this is a tangent? Yes or no?
Yes, sir.
Yeah.
Okay, can we
Yes.
see that this is a tangent?
Yeah.
Both of them meeting at both of them starting from at what point? The what point? The same point. Yeah, are you seeing that? Watch.
Yes,
Someone-
so A.
Oh, yeah.
Point
Yeah.
A.
Yes.
Exactly. So I think all of
Okay.
us could see, that both of those tangents are from a common point. That's why they're saying from a common point. Both of them starting from the same point. To a circle are always equal in length. Guys, the entire tangent touches the circle at one point. We know that, and
Yes, sir.
Yes, sir.
okay, cool. So, and isn't that circle isn't that
Yes.
circle perfectly round?
Yes, sir.
Yes, sir.
So for a circle, the radius is the same everywhere, right? Like, let me explain. If you were to take a ruler and measure this length, it would be equal to this length. It would be equal to this length. It would be equal to this length, and all of them will be radii. So remember that, right? Remember that. Just keep that in memory. So what this theorem is saying, if you have two tangents stemming from a common point, right, where they touch the circle, the lengths are going to be the same. So I would say that AB and AC are equal. Does that confuse you? Like real bad? Tell me.
So you could just repeat back.
Okay, here what? I will do back on a fresh new diagram, right? I will just go through it from scratch. So let me run through this thing together.
No, sir.
Right, so I draw a circle here, right? I'm gonna put a point over here. So tell me if you're with me so far. Yeah, you okay?
Yes,
I
sir.
have a circle and I have a point. I'm going to draw a tangent to the circle starting from point B. You understand what I do there?
Yes, sir.
Okay. And I'm going to draw another tangent to the circle starting from point B. Okay,
Yeah, I'm understand that.
did I confuse you?
No, no, sir.
And the first tangent would have cut the circle over here, yeah?
Yeah.
Okay, and the other tangent would have cut the circle over here, yeah?
Correct.
If you have some trust issues, let me take a measurement.
Right.
They're looking like 3.4, yeah?
Yeah.
Okay. What's that?
3.4. Yeah.
I can't say I dropped the mic, I dropped my Apple Pencil. Right? Yeah. So if I call in this point D and I call in this point E, I would say that BD is equal to
E.
yeah, BD is equal to BE.
Yeah.
Is there anybody that does not understand this theorem? Although don't be scared, you know. Tell me. I'll be happy if you tell me you don't want. No, I
No,
won't.
sir. I'm not
Let
getting
me,
it. I'm not getting it.
let me think about what I'm saying. I was going to say I'll be happy for the time I don't understand. But wait, just tell me if you don't understand. Just tell me if you don't understand. I'm not taking no horrors. If you don't understand, that's fine. I'll go over.
I understand.
So it don't have to be a 90 degrees
It don't
or
have to
just
be a...
once the two. Oh, okay.
So wait, the person I was talking to, you stay unmuted, right? You stay unmuted.
Okay.
Let me go through an example from scratch, right? From scratch. That's the best way for me to explain it to you. Starting from 0. Okay, I'm gonna put a point outside the circle, right? Over here. What do you want to call that point?
Point A.
All right. What I'm going to do is I'm going to draw two tangents, right? But the tangents must be starting from point A, right? So if at any point are confusing, you just tell me, right?
Okay.
Yeah, you understand that?
Yeah.
Okay. It's tell me if I confuse you at any point.
Nah. Nah.
Nah. And a tangent is touch a circle at?
The same point?
Nah, at one point. Remember, a tangent is touch a
Oh.
circle at one point. So if you look at this tangent over here, can we see that it's touching a circle over here?
Yeah.
Okay. If you look at this, the other tangent, touching a circle over here, and
Yeah.
do you have trust issues?
Kinda.
You think it works on me?
Probably.
Wow. Well, let me see if I could rectify the trust issues. Take that measurement from me. What are looking like?
3.1.
I draw it kind of bad, eh? But like, what are looking like?
Yeah, 3.1.
It makes sense, right? You understand what the
Yeah.
theorem is saying?
Yeah. Yeah.
So tangents from a common point, right? Wherever they touch the circle, the lengths are going to be equal. So if I call this B and I call this D, I could see that length AB is equal to what?
And AD?
AD.
Yeah.
But because let me just measure it and we see it for ourselves, right? So AB is going to be equal to AD. Does it make perfect sense? Like it makes sense in your head?
Yeah.
Okay, that's good. That's good. If you said no, like yeah, $1. Because you know it makes sense. I'll stop with my jokes. My jokes kind of bad. Anyways. How did us bring this question, right? They go tie in an isosceles triangle, isn't it? So let me just take a little side quest. Boop, boop, boop. Side quest. Side quest. Right? And we're going to look at an isosceles triangle. Do you all know what an isosceles triangle is? Yes or no?
Yes, sir.
Okay. In an isosceles triangle, two angles and two sides are
Equal.
right. So watch this, right? I'll just call this A. Let's just call this B. Let's just call this C. What two sides are looking equal over here?
A, B, and B. AC.
B and C, sir?
No, you can't just tell me B and C, right?
AB and AC, sir.
Here how we're gonna say this, right? B to A, that's our length over there. And then A to C, that's another length. So B to A, that's one length, and that'll be equal to. So the person that said B to C, correct yourself. It's B to A is equal to. So B to A is equal to.
C to
A
A.
to oh,
If you say C to A,
C.
A to C.
if you say CA
AC.
and AC is the same thing, correct? Right? But we typically, it typically doesn't, the proper thing to do is to write it in alphabetical order. So like, I mean, if you write BA is fine, but you should write AB. So you'll say AB is equal to AC. But if you wrote BA is equal to CA, they can't give it a wrong, right? They can't. This is just the better way to write it. But BA is equal to CA is also correct. Right, guys, are we okay with this?
Yes, sir.
Yeah, sir.
Right. So these are the equal sides, right? So the remaining side is called the base, right? The remaining side is called the base. Right, so AB and AC, those are the equal sides. Was it one remaining side?
BC.
Right. So you would say BC is the base. Now, why did I say this? I'm saying this because for an isosceles triangle, the base angles are. Does anybody know?
Equal.
Yeah. And just somebody, just remind me, what is the sum of angles in a triangle? The sum of angles in a triangle.
180.
180 degrees.
Right. So let's just put all of the pieces of the puzzle together, right? Let's just say I told you that this was that looking like probably it's just a 40, right? Why not? Okay. Then my question is, right? If I were to add up this angle, and this angle, what is it supposed to be equal to? When I add up all,
180.
180 degrees.
now I just said that for an isosceles triangle, the base angles are equal. What do I mean by base angles? Well, first we need to know where the base is. Where's the base here? Which side is the base?
BC.
Right.
BC.
BC is the base, right? Okay, you need to establish that this is the base. So if that's the case, right, whatever these two angles are, they're going to be the what?
Same. The same.
So guys, what are we gonna do this, right? If it have 40 degrees over here, what would the sum of the remaining angles have to be to give you 180?
minus it from the 180 and divide the answer by 2.
Right. But guys, here what I'm saying, right? If this is 40 degrees, what the remaining angles have to add up to? What plus 40 is 180? We had to add to 40 to get 180.
140.
So do you understand that the remaining sum is 140, yeah or no?
Yes, sir.
Yes,
And
sir.
these angles are the same, yeah?
Yes, sir. So I had to divide 140 by 2.
Which will be 70 on each.
Exactly. Here what I'm saying, Here what I'm saying. Remember, these angles are the same. So whatever the remainder is, those two angles are going to split them evenly. If you're splitting something evenly, you're dividing it by
2.
exactly. So to figure out base angles for an isosceles triangle, you're gonna find the difference. You're gonna find the remaining angles, right? So if we know that the top angle is 40, then the remaining angle, the sum of the remaining angles will have to be 140. So 180 degrees minus 40 degrees, right? And that would give me 140. Now, if I want to find for one of the base angles one time, I'm going to divide this by 2. Why am I saying that? I'm saying that because the remaining would be some of the remaining angles will be 140, right? So 140 plus 40 is 180, right? And these angles are the same. They're the same. So I'm going to split that 140 in half. To do that, I'll divide by 2, right? So that's how I got this. 180 minus 140, that gives us the 140. And to split it in half, I divide by 2. So is there anybody that does not understand why I'm subtracting and dividing by 2? Someone, is there anybody that doesn't understand why I'm minusing and dividing by 2? Maybe you don't understand where the 180 come from. Tell me. Talk to me.
So,
So do we understand how to find the base angles for an isosceles triangle? Yes or no?
yeah.
Yes, sir.
Okay. Time to give you all a
Yes.
question then. Time to give you all a question.
All right, so take your time. Take your time.
Hey, CX, not gonna be nice now. CX, gonna be evil, right? But I gave you all the hacks, right? I said the equal sides. I told you all to look out for the equal sides, and I said the last side is the what? What do you call the last side? The remaining side? Someone, remind
The
me.
base, sir.
The base. So guys, I'm going to do something here, right? And I want to see if I'm gonna trick you all or if you're gonna figure this thing. So guys, first things first. Which sides look like they are equal?
AB. Oh, wait,
AB.
no.
Which ones? Which
AC
sides?
and BC.
Yes, AC and BC. Guys, doesn't it look like this side and this side equal? Yes or no?
Yes.
Is that confusing you all? Let me know. Let me know.
No.
No, sir.
Okay. So AC and BC are equal, right?
Mm.
Okay.
Yeah.
If AC and BC are equal, I'm gonna put a little line here and here. So tell me, guys, which side is the base?
AB, sir.
Right. AB is the base. And for an isosceles triangle, what do we know about the base angles?
They are equal.
Right. So if this is 46 degrees, what do you think I'm going to call this?
46
46 degrees.
Right. So they're going to take the triangle and twist it up all kind of way. You need to be able to figure out which sides are equal. The last remaining side, that will be the base. And we know that the base angles are equal. So they can't trick us because we know better than that. Right? So we know that AB is the base. We know that AB is the base. So if AB is the base, and we know that this is 46, this had to be 46 as well. Because again, base angles are equal. Is anybody confused?
No.
No, sir.
All right. And guys, if this is 46 and this is 46, how would I figure out angle C?
Times it by 2.
By
You're
adding
gonna add the
46.
two 46 together and minus the total away from 180 degrees.
Mhm.
Right. So yeah, but somebody said times it by 2. Somebody, the person that said that, let me try to rectify that, right? Don't feel shame. You're learning. It's fine. Why did you say multiply by 2?
No, I made a mistake. It's supposed to add it, not multiply it. I meant it as, yeah.
So you tell me, how would I find the missing angle? You tell me you working.
46 plus 46, and you get the answer, which is 92, and you're taking it away from 180.
Ah, okay. I think you
Yeah.
meant to say 46 by 2.
Yeah, 46 by
Maybe.
2, I said. Yeah.
Okay, yeah. So 46 by 2, 46 plus 46 is the same thing, right? So 46 plus 46, that should be 8, right? You all are getting, what you all getting for that? 92. Again, 92?
Yes, sir.
And 92, so that will be
Yeah.
92, so it'll be 88. The answer is 88 or 90, 98.
I get 88.
88? Okay, cool. Are you all getting 88 as well?
Yeah.
Yes, sir.
So guys, if you could handle this, right? If you could handle the heat here, you easily could handle an application type question for this theorem. I'm sure. So here what? Let's apply it to this theorem now. So guys, I just connected B to D. What kind of triangle is ABD?
Isosceles.
Yes, it's an isosceles. How do we know it's an isosceles?
Because two sides
sides.
equal
What two sides are equal?
AB and AD.
Exactly. So you know what I'm going to do? I'm going to put a line here and I'm going to put a line here. So if I told you, by the way, wait. Tell me, which one is the base here? What side here is the
BD?
base? BD, right? Because it's the only side that is not equal, right? So this is the base. Is anybody confused? Is anybody confused?
No, sir.
No, sir.
Oh, okay. Remember, guys, if you have a tangent from a common point, wherever it touches the circle, right? Those lengths are going to be the same, right? And I connected B to D. Remember, if you have two equal sides, it forms an isosceles triangle, right? And the remaining side that's not equal, we call that the base. And we know that the base angles are, what are the base angles are? They are what to each other?
Equal.
They're equal. So if I told you that over here was 54 degrees, how would you figure out for the base angles? Does anybody know?
180 minus 54, and then the answer you get you divided by 2.
Yes. Is there anybody that just does not understand that at all? Tell me.
No, sir.
Okay. And that should be 126. That looking like 126. 126. 7, 6. 63?
Yes,
Oh,
sir.
yeah.
Yes, sir.
Okay, cool. All right. So are we okay with this question?
Yes, sir.
This is how they bring it in the exam, eh? This is literally how they're going to bring it. All right, so how are we feeling about circle theorem so far? Is it that hard or like kind of easy?
Kinda easy.
Yeah, kind of easy.
It's kind of easy. Don't worry. Before we move on to our past paper question, we're going to run through all of them again to make sure it's locked in your brain. And then we're going to do some past paper questions to make sure you fully understand the thing. Right? Okay. So we understand theorem 6. Again, theorem 6 says tangents from a common point to a circle are always equal in length. Remember that. It comes rarely, but it does come. Right. So I remember earlier today I was saying something about a cyclic quadrilateral. Yes or no?
Yes.
Yes, sir.
Yes, sir.
All right. So I want somebody to read this for me first. Somebody read that for me. Give that a read for me.
ABCD is a cyclic quadrilateral. All vertices lie on the circumference of the circle. Opposite angles add up to 180 degrees. A plus C equals 180 degrees and B plus D equals 180 degrees.
All right. So the first thing you must understand is what exactly is a quadrilateral. What is a quadrilateral? It's a shape with how much sides? When you hear the word
Four
chord,
sides.
Four sides.
right? When you hear the word chord, what comes to mind?
Four.
Four, right?
4.
Right? So let's take this in parts, right? So cyclic. Cyclic means that all vertices touch the circumference. Right? And we know what quadrilateral means, right? So quad means 4. So it's a shape with how much sides? It's a shape with how much sides?
Four
Quad,
sides.
right? Shape with 4 sides. Like, you tell me some shape with 4 sides?
Square.
Where
A rectangle. A kite.
All right. So a rectangle, a square,
diamond.
right? Kite. Right? What other shapes is a quadrilateral? That's what T. T,
So trapezium.
Trapezium.
trapezium, right? I could think of another one. So that's what R.
Rhombus.
A rhombus, yeah. And a rhombus is like a square, right? It's just a bit sad. It's just a little bit sad, right? And parallelogram. Oh, you know it's a parallelogram?
Yes, sir.
Wait, no. A parallelogram is like a rectangle, just a little bit sad, right? So these are some common quadrilaterals. Now, for you to be able to use this theorem, the shape must be inscribed in the circle. And that's a fancy way for saying all of the vertices must touch the circumference. So let's run through a couple of hypotheticals. I have a circle here, right? Right. Is that a quadrilateral? First things first, is that a quadrilateral?
Yes, sir.
Yes, sir.
Does all of its vertices touch the circumference?
Yes, sir.
Yes, sir.
Yes, sir.
So this is our cyclic quadrilateral. Cool. Okay. What about this? Is this a cyclic quadrilateral?
Nope.
No.
Yes, sir.
Yeah. That's no, no, no. Right? This is it. So guys, once you have a cyclic quadrilateral, we are saying that the opposite angles have to add up to 180 degrees. Does anybody know the fancy math term for that? If you're adding up to 180? Does anybody know the proper word for that? Add up to 180. Come on. Does anybody know?
No, sir.
Okay, do you all know about supplementary and complementary angles?
I heard the name before, sir, but I can't remember about it.
All right. So if the angles are up to 180, you'll see that the angles are supplementary. If the angles are up to 90, you'll see that the angles are complementary. Right? But I presume let's just go and put adds up to 180. If you're gonna put that, tell me. How much are you guys gonna put that adds up to 180?
I would just put, well, equals 180, the equal sign on 180, sir.
You're not gonna do all of that. You're not gonna say supplementary angles and all that. It's fine, it's fine. I understand. So guys, I'm gonna call this A, I'm going to call this B, I'm gonna call this C, and I'm going to call this D. Now, this theorem says that if you have a cyclic quadrilateral, the opposite angles add up to 180. All right, it's over here. Right? For a cyclic quadrilateral, opposite angles add up to 180 degrees. And if you're real fancy, you can say supplementary. Right. So my question is, guys, if I put on an angle here, let me just say that as like I'll just say 89 degrees. What angle is opposite A? Somebody tell me, what angle is opposite A?
B.
Somebody said B or D?
No, sir, I said D.
D for dog?
Yeah.
Okay, yeah, that would be correct. So guys, the angle opposite A is D, right? Now, I just said the opposite angles have to add up to. They must add up to
89 degrees.
180.
180 degrees, right? 180 degrees. So if that's 89, what do you think this angle would have to be? How do you think I'll figure out the angle?
180 minus 89.
Exactly. 180 minus 89. I think that should be 91.
Yeah.
Just verify that.
Yes, sir. Yes,
Right?
sir.
91. And how did I do that? Well, I said 180 minus 89, and that gave me 91. Let me know if you guys understand this. Do you all understand this?
Yes, sir.
Yes, sir.
Okay. All right. Somebody tell me what angle is opposite B? What is opposite to B?
C.
C. What if I told you that angle C was 82? How would I figure out angle B? Somebody,
180 minus 82.
does everybody here understand why she's saying 180 minus 82?
Yes, sir, because it's supposed to make up 180, sir.
Exactly. And
So when it is your minus, you will get the answer for the opposite angle.
exactly. And I think the answer is supposed to be 98. Let's verify.
Yes, sir.
Guys, how are we feeling about cyclic quadrilaterals? You okay with this?
Yes, sir.
Somebody tell me. I need to know what's going on. I need to know what is going on. Hit my vibes. Or like I want to.
Nice.
Nice.
Vibes.
Okay. So I have trust issues, eh? So let me do one more example. I really leaving no leaf unturned here. Right? After today, all you had to be circle theorem legends. See a circle theorem question, gain 8 marks one time. One time, right? Okay. The first thing I want to let you do, right? I want to let you tell me if I see a cyclic quadrilateral in sight. Tell me if I see one.
No.
Oh, we're not seeing one yet, right? Okay, are we seeing one there?
Yes, sir.
Okay,
Yes, sir.
I'll call this. Actually, let me make it a little ugly. Let me make it extremely weird. Okay, is that still a cyclic quadrilateral?
Yes, sir.
Yes.
Or
Yes,
the
sir.
point. Yes, sir.
Right. It's not gonna look nice in the exam, eh? It's not. You need to be able to remember the properties and be able to apply it anytime you see them. So, okay, this is a cyclic quadrilateral. Nice. So if I told you that this was, let me just say I told you, oh, wait, I'll just label it. I'll call this L, M, N, O. Guys, I know my alphabets. It would be a shame if I label the one that was wrong. It's L, M, N, O, P. Oh, yeah, I think that's correct. I don't teach English, but I think that's correct. Okay, so what angle is looking like? Angle L. What angle is that looking like? How much degrees? Somebody tell me.
45.
45. Sure. Oh,
Uh,
wait, and by the way, we had to do this anyways, right? Do you all know how to measure angles with your protractor? What I'm saying? Yeah, this is your protractor. I always mix them up. Yeah, this is your protractor. I just always get confused because this is like a compass, but it's actually a protractor. Yeah. So guys, do you all know how you would measure the angle with your protractor? Yes or no? If you are one of those that have hard time with using your protractor, tell me. I'll show you now.
It's time a bit.
Okay, here we're gonna do, right? So let me ask you a question. We want to measure this angle here in the middle, right?
Yes, sir.
So what we are going to do is we are going to align that, like the flat part, over here. That's what we're gonna do. So if at any point I confuse you, you're gonna let me know, right?
We put another flat part to line up on the between L and the other point.
Yes, right here. Tell me if that confuse you.
I see it to understand what you do.
Now that wouldn't be 45, eh? The actual
Mhm.
thing would be what? Read that off for me. Take a read off. That looking like,
33.
It will be like
2.4.
30, 34, 35.
I would say 34. I would say 34. Right? Somebody tell me, what is the side that's directly opposite L? What is opposite L?
Answer.
And
N.
Yeah, N. N is opposite. So that's 34 degrees here. How would I figure out what N is? How would I figure out N?
180 minus 34.
180 take away 34.
Right, 180 take away 34. And you should get 146. Verify that.
Yes, sir.
Okay. All right. Which one do I want to be the next victim? M or O?
Oh,
Oh, okay. What do they want to call? Actually, let me measure the angle, right? Given all your practice for construction and thing one thing. All right. So what we're going to do, right? We are trying to measure this angle. So I'm going to take my protractor and I'm going to line up the straight part with this. There's also another way you can measure it. I suppose I could show you all that as well. So you see, I'm going to line it up, right? It's I also want you to read that off for me. What does that look like? That looking like what? What does that look like, guys? Somebody. So
128.
watch. We're starting from 0 over here. What does that look like?
128.
You're saying what?
One, one, 125.
Nah. What,
127.
Or like
guys,
129.
128 is looking like to me.
I find it looking like 129. Why am I saying that? Somebody said 125. No. If it was 125, then it
No,
would
I
have been
said
over here. If it was 125, it would have been over here, right? Right? This is the 5 mark over here. So what? 5, 6, 7, 8. Okay, 128. Can like 128, 129. Right? Are you all okay with how I measure the angle? Yes or no?
Yes,
So,
sir.
so like I'll just
So
call it
I,
128. I call it
so I
120.
think I think my problem is that you see these like lines that you used to put the angles in because of how like small they were. I used to think that the angle that goes in has to be smaller. So I would get confused if I got a bigger angle.
Or like an angle past 180.
Yeah, yeah,
Oh, well, I guess I could show you how to draw that one time, I suppose. Let's just say I wanted you to draw 370 degrees, right? Yeah.
yes,
First thing I want you to do is I want you to put on a 180 degrees. Yeah.
mm-hmm.
All right. So here it is, right? If we know that this is 180 degrees, how much more you would have to turn, right, to make 370? How much more degrees would I have to turn to make 370?
190.
190, right? Okay. If I ask you to do 370, you're gonna end up over here, right? Because 370 is just 10 degrees. Let me give you like a more practical example, like what CXC would bring you. Okay, and if you're confused, right, let me just explain something. 360 degrees is how much revolutions? If I say 360 degrees, doesn't that mean I moved in a full circle? Yeah or no?
Yeah, yeah, I moved in a full circle.
So if I start off over here and I move 360 degrees, wouldn't I end up here?
Yeah,
And if I move 10 degrees again, see what I'm talking about?
yes,
mhm.
sir.
Yeah, so 370 degrees is really 10 degrees. That's what it would look like. That's what the drawing would look like. It would look like that, 10 degrees. Right? Let me give you a more sensical one. Right? Let me just say 340, right? And let me just say the starting point is over here. So I have a question, right? How much degrees is that already? That's 180,
That's
right?
yeah,
How much more would I have to travel to make 340?
160.
So what we're gonna do is I'm going to take my protractor and I'm going to line it up with the line I just drew. And how much more I had to measure?
160, sir.
Exactly what? 0, 10, 20, 30, 40, 50. Right here. So this will be the angle. Let me know if that confuses you.
No, so I get it now.
And then another way you can think about it, right? Another way you can think about it. 340 is how much short of 360?
20, sir.
What? So watch this, right? Let me know if you see what I do there. Okay, I don't think you understand what I did there, right? So a full circle is 360, yeah? Yeah?
Yeah, sir.
And 340 is 20 degrees short of 360, yeah?
Yeah.
So watch this, right? I measure 20 degrees here.
Oh,
So my angle had to be this angle over here because it's how much degrees short of 360?
20.
Right. And that would have been 20. So our angle is just everything but 20. That makes sense?
Yeah.
Yeah. Nice. Cool. Right? So yeah, guys. This was 128. We call it that, right? 128. So what's the angle opposite O over here? What's the angle opposite O?
M.
M, right? So how would I find for M? How would I find for M? Somebody tell me, how would I find for M? Does anybody know at all?
It'll be 180 minus 128, which is 52.
Exactly. 180 minus 128. Because all the opposite angles add up to 180, yeah? So 180 minus 128, and you get 42. No, I mean 52. 52. Because 5 plus 6 is 7. 7 plus the 10 is 80. Yeah. Are they getting 52? Just verify that. Guys, everybody just went quiet all of a sudden. Is it that you all don't understand why I'm
Yes,
calling
sir.
this opposite? Oh, like, is there some confusion with this? Let me know.
Yes, I get 52 too.
You understand how we did it?
Yeah.
All right. So is there anybody that does not understand why is there anybody that doesn't understand how to use this theorem?
No, sir, I get it.
All right. So guys, once you have a cyclic quadrilateral where all of the vertices, the four vertices, touch the circumference, the sum of the opposite angles supposed to be what? Tell me, what is the sum of the opposite angles supposed to be? When you add the opposite angles?
360.
No.
Oh, wait, no, 180.
180. If you add up all the angles, though, you get 360, right? But the opposite angles add up to 180, right? Cool. So guys, we just covered all the theorems. Are you all okay with all the theorems? And we did cover this one already. The angle between the radius and the tangent is 90. Can you all understand all the different theorems?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So if I blindly draw some theorems, you think you could tell me what theorem it is?
Yes, sir.
All right. Let me see how good it is. So, and I'm picking up, I'm testing all on everything, eh? That black outer, what does that represent? What is that called? The black line.
Circumference.
Circumference.
What is this center point called?
The center.
The center.
Right? What is this red line called?
Tangent.
Tangent.
Okay, where's the angle between the radius and the tangent?
90.
Radius.
The radius.
Oh,
Oh,
90
it's
degrees?
90 degrees.
90
90
degrees, right?
degrees.
All right. What is this line called in green?
The diameter.
Diameter.
Okay. What would this angle be? This angle.
90.
Right. Guys, what theorem is that?
What theorem?
The
The
last
one
one.
that states
Wait, that guys, remind me. What is this green line called again? That
the
green line is,
diameter.
what
One
is the
that states
diameter?
that
Wait, what is the diameter do to a circle? Think about it. Diameter. What is diameter do to a circle?
it splits this in half.
Exactly. And the angle. Okay, okay. What do you call half of a circle? What's the name for that?
A semicircle.
And the angle in a semicircle is always
Half. 90 degrees, sorry.
90 degrees. Yes. And just by looking at this, can you see it's 90 degrees?
Yes.
Yeah, cool. Cool. Guys, we okay with everything so far? Or like, nah. Or like things bad. Let me
Yes.
know.
I think I'm
okay
okay,
with
sir.
this one.
All right. Okay. What is the name of this line I just draw?
That is
Chord.
that's a
Chord.
chord. Yeah, a chord.
Right? It's a chord. I tell you what, I already tested on it here, right? If you could survive this, you'll be good for the exam. Right. Which theorem is this? What theorem do you think I'll ask you to apply here?
Angles is that
Angles of the same
stand
segment,
on the
sine of the
same
same
chord.
chord are equal.
Okay,
Yeah.
okay. Way, boy. Got a bad boy. Big up on itself, boy. Okay. Yes, sir. Watch. You have a chord here, right? And both of them in the same segment. And both of them, right? If you think of those things as legs, right? Both of them standing up on the same chord. So whatever this
Yeah.
angle is, this angle would also be equal to that. Yeah or no?
Yes.
Yes, sir.
Right.
Yes, sir.
So let me just say that let me just say that this was 6. Darius attempted to say 6. But
No, sir, don't do it.
I will
Don't
not
do
say
it,
it. I will
sir.
not say it. Jessica Hunting, my boy. Shamila, Jessica, and them real hunting, my boy. Wait, I hear them whispering in my ears, you know. Boy, I call this 68 degrees. If that is 68 degrees, waiting this could be.
That will also
68
be on
degrees.
68 degrees, sir.
68 degrees.
Let me see if I could trick all there, right? Let me see how bad it is. What would I call that? What would the pink angle be?
Oh,
It
that
will be
68
would be
double the
degrees.
68 degrees,
68.
sir.
No, it will
No,
be
it would be
double.
68 divided by 2.
No.
Yeah.
It will be double.
68 multiplied by 2.
Okay,
Yes.
yes. Okay, yes.
Guys, remind me, what theorem is that?
136.
What theorem is that?
Wait, what?
Okay. Somebody hit me
The
with
angle
a
by
Because
the
they're
whiteboard.
not
angle by
touching the
center will
same
be twice the
points.
amount.
Right. Let me understand what happened in there, right, guys? First things first. The pink angle, let me just give this thing a name. Let me just call this AD. Guys, what chord is the pink angle standing up on?
AD?
Right?
AD.
And it's at the what? That angle is at the what?
At the center.
Center.
Right. Do we have any angles standing up on the same chord that go into the circumference?
Yes, sir.
If you're not seeing it, watch. So we have one at the center here, right? And you have one at the circumference there. Oh, let's see now, right?
Yes, sir.
Yes, sir.
Another way to see it would watch. This will be correct as well.
Oh.
And remember, the angle at the center is how much times the angle at the circumference?
It's twice the angle of the
Twice the
circumference.
Right. So what would this angle be here?
One 36.
I'm waiting to hear some other people answer. So this would be 68 by what? I'll multiply 68 by what?
It will be
Okay.
136,
Two.
sir.
By 2.
136.
Right? And that will be what? One what?
136.
36.
36.
Right. Guys,
Yeah.
I'll finally understand the circle theorem.
Uh-huh.
Yes, sir.
Let me know. Nice. So like let me hit a little with one more twist. Hmm. Okay. Oh, this will be diabolical. I make it things look real hard, but I counting on it to be able to see it. Because truth be told, it's really not that hard. Right. I want you all to tell me what this angle in red is.
Sir, that this is
48 degrees.
Yeah, it's
yeah,
48.
and it got added with 90 degrees, sir. And then and then take it away by 180, so to find out the missing angle.
Okay, wait. I'm a bad boy. Let them cook. Okay. Wait, boy. Wait, boy. Are they ready for the exam questions? For sure. Are they really ready for them exam questions? And if you figure out the missing angle over there, that will be what? Well, again for that. 42,
Yes, sir. 42.
right? That'll be 42. And guys, how do you know this is 48? Remind me of the theorem. Remind
Because
me of the theorem there.
it's interior opposite.
Right. The angle between the tangent and the triangle is equal to the interior opposite angle. So watch. Are you seeing what I'm talking about? Yes or no?
Yes,
Yes, sir.
sir.
Yes,
Yeah.
sir.
Guys, be ready, ready. So here what? I'm coming back, right? Just look at all the theorems, soak it in, absorb it, feel it on a spiritual level or something, and I'll be back. Then we're gonna start past paper questions. Right? I'll say 6, say no more. After that, I'll give like a 10 minutes break. When we come back, we're gonna start trigonometry. That easy. It'll be fine. Trust me. I surely think circle theorems was hard, but that's all I can see it not hard. Right? I'll be back shortly. Give me a second. Yeah, guys, I am back. Are we feeling hyped to start these past papers? Let me know. Everybody real silent.
Sir, slightly flow state right now, sir. In the flow state right now.
In flow state, that's good. What about the rest of you all? What about the rest of you all? Are you ready to start the past paper questions, circles?
Yes, sir.
Okay. Come on here, guys. Okay, yeah.
Yeah.
Pick a year. Okay, yeah. Pick a year. I have all the years, so
January 2025.
sure, no problem. Just erase my solution. Right. So who wants to help me with this question? I promise it's not hard. And just by looking at this, right? Just by looking at this, I surely see in all the theorems you have to use. I'm sure. So who wants to do this question with me? Why are they giving me this silent treatment, boy? Wait, boy.
Well, I would start with the, wait, I can't see on the screen. So already seen we have 63 degrees here.
Yeah.
And once it on the, mommy, once it on the line, once it on the line, we know it's 180 degrees. So I'm minusing 63 degrees from 180 degrees to get the missing angle.
I mean, yeah, that's correct, but I'm not sure that's gonna help us. But yeah, you're correct. Yeah, if they ask you for this angle, yeah, could use that.
I won't finish it. I have too much noise around.
All
So
right.
63 will be equal to
No,
Q? Oh,
I hear what you're saying, but I'm not gonna. Yeah, it's information we could find, but it's not gonna help us in the grand scheme of things for this question. So let me ask you a question, right? Are we seeing tangents? Are we seeing a tangent?
No.
Sir.
yeah.
Yes,
In a
sir.
tangent.
Where?
Oh,
Yeah, we see a tangent over here, right? Are we seeing triangles?
Yes, yeah.
Yeah.
Okay. Is there any theorem that talks about angle between a tangent and a triangle?
Yes, sir.
Okay, so what is x?
Z-
The
I
angle
can't remember.
between
I
the
just know it's
tangent.
entire opposite.
Right. So if
The
you
angle
draw a arrow over here, what is x?
63.
63.
63.
Guys, that we could figure that out, right? And if we know this is 63, what other theorem we could use?
Then Q would be 63 degrees.
Are they understand what I did so far? Like we right now we just playing with the food, right? Because this is food. Darius, you understand what I did so far?
Yes, sir.
And another thing, guys, if I ask you guys what this angle would be, what would you tell me?
90.
90
Oh, what?
degrees.
But I give you later. And you see how I draw that? I draw it like that. Oh, should I draw it like this? That would confuse the masses. And are you seeing any special things about the triangle here? Like, are you all seeing any isosceles triangles?
Yes,
Yes,
sir.
sir.
Yes, sir.
Which triangle is the isosceles triangle here?
Um,
You're looking for
L and Q.
you're looking for two lines, yeah? Like in an isosceles triangle, typically you see like two lines like that. Are you seeing now over here?
Yes, sir.
Yes,
L,
sir.
L, and Q.
NLQ.
So tell me, what
Yeah.
sides are equal for the isosceles triangle there? What sides are equal?
NQ and NL.
Do you all agree? NQ is equal to NL.
Yes, sir.
Watch, because you see in the
Yes,
line,
sir.
you see in the line, watch, bam, bam. So what will be the base for that triangle then?
QL.
yes, would be
LQ.
N.
Now, remember, guys, remember
And
the base is the remaining side. So, guys, we said, so we know that these two sides equal, yeah? If we know that, those two sides equal.
Mm-hmm.
So the
L
base
and
is just the remaining side. So this would have to be the base.
L and Q, yeah.
Tell me if you understand that.
Yes.
So if I figure out what y is, would it be hard for me to figure out what these two angles are?
No.
no, sir.
Nah. So going into this, we can figure out all of that information already. Right? Nice. So explain why angle X and angle NQL are equal. So before we move on, I just want to explain this three-letter notation to you guys. So when you see something like NQL, a lot of people remember it like just remember the angle in the middle, right? But that doesn't help all the time. I want you to think of it like this: N to Q to L, and the angle will be in the middle. So watch this, right, guys? N to Q to L. N to Q to L. What angle are they talking about? Remember, the angle is the space between two lines. So are you all seeing an angle somewhere over there?
Yes, sir. We're talking about
Yeah.
angle Q.
I see the angle over there by Q. So in the first question, they actually want us to figure out for this. All right. So they want me to explain why angle X and angle NQL are equal. And this is angle X here. You guys with me?
Yes,
Yes,
sir.
sir.
So if you're confused, again, let me read it back one more time. They want us to explain why this angle and this angle are equal. Why are they equal? What is the theorem?
Because
Because
angles standing on
angle
the same
X
chord over
and
R.
angle Q both stand on NL.
Yeah, to be a little more specific. Be a little more specific.
Because angles standing on the same chord in the same segment are equal.
Yes, but it could be a little more specific on that. So let me write the answer, right? Now, guys, if it was like that, it could not use the theorem, eh? And the reason why is because the angle must be at the what? The angles must be at the what?
Circumference.
Right. So you would say the angle at so, right? So the angle at the circumference standing on the same angle chord. Same. Now, CXC wouldn't be so strict, but I want to teach you all the 100% correct thing, not a shortcut thing. So the angle at the circumference standing on the same arc or chord, right, in the same segment are equal. This is the most specific you can get. Same segment. You understand this? I wonder if you're all confused. Is
Yes,
anybody?
I get.
So if you are confused, remind me, what do I call this? This is the what? Starts with C. What's this?
Circumference.
Right. Can we see that? Can we see that both of the angles are at the what? Where both of the angles at?
On the circumference.
Right. And both of them standing upon?
The same arc or chord.
Right. And both of them in the?
Same segment.
Right. So is there anybody that feels like they would not have gotten the first question correct? Tell me now.
Sir, I think I left out this question when I did it earlier.
How are you feeling about it now?
Now I'm feeling much better. I think I could have done it if I remembered when I did it initially.
Because and just seeing the carters,
Yeah.
yeah. So if they had to be the same because angles at the circumference, standing on the same arc or chord in the same segment are equal. Feeling okay with that?
Yeah, sir.
Nice. Right. Help me with part 2 one time. So in part 2, they want us to figure out what angle X is. Angle X. So let me ask that question, right? Are you seeing a tangent in this diagram?
No, sir.
You sure? I see that tangent.
Yeah.
I see that tangent.
MR.
Yeah, MR. So the person that told me you're not seeing that tangent, check this out. What is that?
Yes, I see it.
That's a tangent, right? It's seen it as a tangent. And additionally, you're seeing that there's an angle between the tangent and a. So you have an angle between tangent and a.
Interior angle, sir.
Yeah, you had to use that rule, but like, what would I call this shape over here? NPL.
The right angle triangle, sir.
Yeah, you're not wrong.
That's a triangle.
Yeah, it's a triangle, right? And remind me, guys, what does the theorem say about the angle between the tangent and the triangle?
And they will be equal to the opposite.
Right, right. So, guys,
Yeah.
if this is 63 degrees, what do you think X could be?
63, sir.
63.
63.
You understand?
Yeah, sir.
Okay, good. Don't worry, I'll make like a separate diagram. So like when you're revising, you could like see exactly what I'm talking about. So this is the triangle I'm talking about in question, right? That triangle. And this tangent over here. Seeing that, right? Come on, you with me up to this point.
Yes, sir.
All right. And we have an angle here. This theorem says that if you have an angle between a tangent and a triangle, it will always be equal to the interior opposite angle. So the inside that's opposite to it, inside the triangle. Is there any confusion in your head?
No, sir.
Nah? Okay. Yeah, sure.
Yeah, sir.
Okay. So X would be equal to 63 degrees. Let me just take a screenshot of this. So the answer is 63 degrees. And can you tell me a reason for that? So I wanted the person that was confused who left out the question to do the question one more, right? Tell me your name while you're at it, because I can't really see anybody right now. Tell me your name.
Aaron, sir.
Oh, Aaron. Okay, okay. So Aaron. Try not to get confused. So like math is very literal. So you could actually come up with a theorem in the exam. So let me show you what I mean. So what's this, Aaron? What do I call this?
That's a tangent, sir.
That tangent. And what is this? What's this shape?
That's a triangle, sir.
And this angle is in between them, yeah?
Yeah.
Right, so let me start that off. So you're going to start off by saying the angle between the what? Trying to finish my sentence. The angle between
the tangent.
Yeah.
And the side of the triangle.
Yeah. Right, is equal to the
interior opposite angle.
Yes, man. Now we're talking about. Right. Big up, big up, big up. It's equal. Okay, you understand this?
Yes, I understand it better now.
How about the rest of you guys? Will you understand this?
Yes, sir.
Okay, cool. Let's move on. Angle Y now. So here is it. In a circle theorem question, if you figure out something, guys, put on your answer one time, right? So like, we know that this is 63, so I'm gonna just replace, I just go and say that this is 63. Right? And guys, if I know that this is 63, well, we know this gonna be one time as well.
63.
Did I confuse anybody with that reasoning?
No, sir.
No, sir.
Remember, if you have angles at the circumference standing on the same arc or chord standing in the same segment are equal. That's exactly where it could be. That's exactly what you could see over here, right? They're standing on the same chord, right? Both of them at the circumference and they're in the same segment, so they're equal. Right. So now we want to figure out for angle Y. Who wants to help me find for angle Y? Is there anybody that would like to help me with angle Y?
Okay.
All right, so let me go, right? First things first, I'll ask you, what kind of triangle is this?
Isosceles.
Okay, and where's the base? Which side is the base?
L and Q, sir.
I wouldn't say L and Q, you say L to Q. L to Q.
L to Q.
Right? And what we know about the base angles for isosceles triangle?
Equal.
So my question is, if this is 63 degrees, what do you think this is going to be?
63.
Because it's the base, right? This is the base. Okay, if you know that, you think you could figure out for Y?
Yes, sir.
How are you going to figure out for Y?
By
Adding 2 and minus from
63 and
180.
63 and minus it by 180.
Exactly, because the sum of angles in a triangle is
180.
180.
right. And guys, if you have two of the angles, it's really easy to figure out for the other one. So this is just going to be, it's going to be 180, right? Minus, open bracket, the 63 by 2. And what are you guys going to get when you do that? So you get like 44, I think. Wait, that'll be 126, no, 54. Are you all getting 54? Or something around
Yes.
that?
Yes, 54 degrees.
Okay. Did somebody else agree? Did you all get 54 degrees?
Yes,
Yes,
sir.
I get 54.
Was this question that hard or like, what do you think about this particular question?
This was a good question, too.
Okay, cool. So you see how the isosceles knowledge coming into play? Because if you didn't know what an isosceles triangle was, you cooked, right? You'd have see these lines and be like, they're just wasting ink. No, there for a reason. If these two are the equal sides, then this would have to be the base. And if that is the base, and we know that this is 63, this will be 63 as well, right? So 63 plus 63 is 126. You take that away from 180, and that will give you 54 for the missing angle. Is everybody okay with Y? Let me know.
Yes, sir.
Okay, what about the rest of you?
Yes, sir.
Yes, sir.
All right. And what is the theorem I use here? Well, guys, for me to be able to figure out what this is, what two angles did I need to know first?
The base angles.
Yeah, the base angles, right? Guys, and everybody could agree, right? If you didn't know what this was and that, would you have been able to figure out for this?
No, sir.
No. So the first thing you have to give them, right? You gotta explain to them, okay, how you get 63 over here? What was the theorem there? How you know that's 63? Remind me, what's the theorem there? How do you know that this is 63?
Because P was 63, sir.
Okay. And what's the theorem that would link these two together? Angles at the
Same segments and standing on the same chord is always equal.
right. And I way to add in the part that says angle at the circumference. It must be at the circumference. So we're gonna so our answer is right. The answer y is going to be equal to 54 degrees, right? And let me put on all the reasons, right? Number one, right? Angles, bro. I'm just gonna copy and paste what we have above because we stated this term already. Save some time. And you're also gonna see, you know that base angles in an isosceles triangle are equal. Base angles in an isosceles triangle. Is there anybody that did not understand this thing at all? Like you're real confused, like you don't know what going on at all. Tell me.
Now, so I understand.
Yeah, what about the rest
I
of you?
understand.
Do you all understand the reason and the reasons I put?
Yes, sir. Yeah.
Okay, good. And the reason I'm saying, okay, watch. I'll run it back one more time. We understand how we got 63 degrees over here, right? Interior opposite angles. Cool. So we know that this is 63. Since the angles are at the circumference, right? And both of them standing up on the same arc or chord, and they're in the same segment, this will be 63. Yeah? And what kind of triangle is this? Somebody tell me, what kind of triangle is that?
Isosceles.
Isosceles.
Right. And what angles are equal in an isosceles triangle?
Base angles.
Right, base angles. So if this is 63 and this is 63, yeah, you know what to do from there. Add it up, take it away from 180, bam, you get an answer. So I take it that we okay with it. Right? And that's it. That's it for the circle question. How will it feel? How was that?
That was good, sir.
Was it?
I was better, better than it was when I did it.
It really not that scary, right? Really not that scary. So yeah, let me look at January 2024 now. Do I have January 2024? Yes, I do. I do all of these questions already. Let me get rid of my answer. I'll leave you diagrams. I should have like a 50%, no more than a 50% chance. Chances are like when I open up paper, I do all the questions in the paper. It's crazy. So who wants to help me with this question? Who wants to help me with the question? Do I have any volunteers? Oh, they gonna break my heart, so boy. Yeah. Let's stay in quiet and sing.
Now, so we read it. Hold on.
Okay.
Go on.
Okay, who wanna help me with the question?
So I could help.
All right, let me go. First things first, let's try to identify what theorem we could use, right? Are you seeing a tangent in this diagram?
Yes, sir.
Okay.
Yes, sir. And I isosceles triangle.
Yes.
Okay. Then we okay, big up on yourself.
Yeah.
So I see a tangent, right? I just by looking at this, I see a tangent. It had two things you could do when you see a tangent, right? You should be thinking right angle, right? Because remember, a tangent and a radius is 90, right? And you should also be thinking interior opposite. Are you seeing what I'm talking about or no?
Yes,
Mm.
I see it.
Okay.
Yes, I see that.
All right. And the next thing, you should also be thinking to yourself, well, do we have a okay. If you look at the big shape over here, like I forget about the circle, right? Like imagine a step away. Forget about all the lines in the inside, right? What kind of shape we have?
Quadrilateral.
A quadrilateral.
But not just any quadrilateral, a what quadrilateral? All of its vertices are touching the circumference.
A cyclic
A
quadrilateral.
cyclic.
Yes, Perseus, get them heat, right? It's a cyclic quadrilateral. And where's the opposite angles in a cyclic quadrilateral equal to?
180, sir.
Yeah. Are you seeing any other theorems or anything we could use? I see in one, you know. I see in one. Oh, well, let's see it. Okay, well, I hint, right? This angle is at the what?
No.
At the center.
Okay. And this angle is at the?
Circumference.
Okay. I'll get what I'm talking about it. Or nah?
Semicircle.
Nah. Okay, again.
Double.
You have an angle at the what here?
Oh, the one where they saying I
Okay.
thought the angle at the center is twice the amount, twice the angle to the circumference.
Yeah.
Okay,
Yeah.
I see it.
What? Nice. So as soon as I open up paper, just write down to the side things you could possibly do, right? And we could use angle at center is 2 times at circumference. Right. So let me go now. Let me go. This should be cake. We already list out everything the question's gonna ask. So we should be fine. So the person that wanted to do the question with me, they want me to find the value of angle KOL. Now don't let us confuse here. When you see something like this, think of it like K to O to L, and you're looking to see you're looking to see the space in the middle. The space in the middle is the angle, and it will be by the O. Right? So let me go. So K to O to L. Right, so I'm gonna start at K. I'm gonna start at K. Then I'm gonna go to O. Then I'm gonna go to L. Did that confuse you?
No, sir.
Okay, so the person now, I remember a girl had wanted to do the question with me. I don't know the name.
Mm,
Are you
I
still there?
don't. Yeah.
What was your name?
Celine.
Celine.
Yeah.
Suraj Bali.
Yeah.
Okay, nice. So Celine, they want me to find KOL, right? So I'm gonna start at K. I'm gonna go to O and I'm going to go to L. Can you see that the angle they're talking about is O?
Yeah.
Okay, cool. This is what they want me to figure out.
Okay. So since the radius connecting to the tangent, right? It have a 90-degree forming here, right? This 90-degree,
Yes,
right?
I see what you're talking about.
And since that is a 90-degree, we just have to find this angle here since since you already know these two angles here, right? So you can add those two angles
Waiter,
and
1 minute. You said we need to find for this angle?
yeah.
Nah, think bigger than that.
Oh,
Think bigger than that. Let me ask that question. K to O is a radius, eh? Yeah?
right.
O to L is a?
Radius.
That makes us a what kind of triangle?
Isosceles.
Right. So you should be interested in finding any base angles. Not this.
Right, but you could always add it back to 12 and still
You could
find
also
that
add it
same.
back to 12. Yeah. But I feel like that's some extra work. But you could. It could. So tell me what you want to do. You want to say 90 minus 48 plus 12 and then add back the 12? Or you just want to say 90 minus 48 and get it one
Okay.
time?
Yeah. So it could just minus 90. I mean 48 from 90,
Right?
which is 42.
Mm-hmm.
So since you already find these two angles here, you already find for basically these two angles here for K and L angles. So those two are 42. And since it's a triangle, the sum of all the angles in a triangle is 180. So you add 42 and 42 and minus it from 180 and you should get angle O.
Yeah, that's correct. Is there anybody that did not understand what she did at all? Talk to me. Is there anybody here that doesn't understand what she did at all? Like at all, at all?
I'll say I understand.
Right. And just verify, I don't have a calculator. You get 96?
Yeah.
Okay.
Yeah.
Right. So for anybody that just does not understand what she's talking about, right? First things first, what would I call XY? XY is a what?
Tangent.
OK is a what? What is also key called?
A radius,
What is the angle between a tangent and a radius?
90
90
degrees.
degrees.
So that whole thing over there is 90, right? That whole thing is
Yeah.
90. Just putting that out there. If you look at this triangle over here, right? We know that OK is a what? What is O to K called? O to K is called the what?
The
That's
radius,
Radius.
right. O to K is a radius and O to L is a
radius.
radius. Right. So wait, let's finish this question. I can't do this now. Right. So in a circle, all of the radii are the Darius, you see my girlfriend had trouble into one. I think she forgot my camera on. Yeah. So guys. In a circle, the radii are the what? The what?
It's same length.
The same length, right? So guys, if this and this is the same length, what does that make this triangle?
Isosceles.
Exactly, right? And what angles in an isosceles triangle are the same?
The base angles.
Right. So now we just need to find the base angle. Remember earlier I said that this was 90? Yeah?
Yeah.
Guys, if I know that this is 48
Yes.
and this whole thing is 90, is it possible for me to figure out this little piece over here?
Yeah.
Yeah.
How would I do? How would I do that?
90 minus 48.
Exactly. And if this is 42, this had to be 42 as well. Are they with me so far?
Yeah.
Yeah, it making perfect sense, yeah? And
Yes,
if you
sir.
have two angles, how am I going to find the third angle?
It will be 42 plus 42, and then you'll minus that from 180.
And you'll get 96. So guys, you all understand this a lot better now?
Yes, sir.
Okay, good. Happy to hear that. Right, so this is the work in here. I'm just take a screenshot of this. Right. So Celine, we need to give reasons for each step of our working, right? So how did we know that angle OKL was equal to 42 degrees?
So, the tangent xy is connected to the radius OK. So that will be the 90 degrees. And
Right.
then we already know the angle from, is it KY and KL, that is 48 degrees. So you're minus 48 from 90 to get that interior angle of
Right.
OKL.
Right. So you would say
So
OKL, you would say angle OKL is
yeah,
equal to 90 minus 48.
yeah,
That would be
which is
equal to
42.
48. Excellent.
And since it's an isosceles triangle, the base angles will equal the same, so both of the base angles will equal to 42.
Right. Therefore, right? So you know that. So the answer for KOL, right, would just be equal to the 180 minus the 42 plus 42, right? And that'll give you 96. This is the full reasoning and all of that. Full reasoning. Is there anybody that's still very confused by this? Again, I went through it just now, but if you didn't understand it, still tell me. I don't mind going into it. If my girlfriend says she don't understand it, keep in mind, she finished CXC long time ago. She just trolling. She just rage baiting. She says that's her job to rage bait me. Anyways, guys,
As
do
it
we
should be.
say that again?
I say as it should be.
Yeah, so I understand everything over here. Everything. All they hit me with a little vibes and thing now, give me all energy. What is this? Are they moving dry, so boy? Or they need some blue water, so dry things moving. Wait. Nah, man. All right. Aaron, you understand this?
Yes, sir.
Yeah, sure.
Yes, sir.
Okay. Let's move on, right? So, here I was saying, right? If you find any pieces of information, put it down one time, don't stick. What did we just find angle O to be? And we just find that to be.
96?
Yeah, put that on one time. Don't stick. And we found out this was what?
42.
42.
So here what I'm saying, guys, if you find information, don't just have it hanging. Put it in the diagram. It'll make your life a lot more simpler. Right? And that whole angle in right there was 42 degrees. Okay. They want us to find for angle LMN. So L to M to N. So I'm going to start by L, right? Then I'm going to go to where?
M,
Then I'm going to go to?
N.
Right. So this is the angle that we to figure out, yeah? Right? This
Yeah.
angle in the middle. So let's see how we're going to figure that out. So you're still doing the question, Mama? Come on.
Sorry. Yeah.
It's a little tricky, but I think you can figure it out.
Use the cyclic quadratic rule where opposite angles equal to 180. So you see the angle where on the other side which is hold on, OKN. You could find that angle there and add it to the 42,
Mm-hmm.
right?
Yes.
So that'll be
Yes.
90
I like what you're
minus
thinking.
that'll be 90 minus 56, which is 34. And 34 plus 42 is 76.
I
And
said,
since you're using the cyclic quadratic rule, you could minus 76 from 180 to find angle F.
everything you said there was correct. That is 100% fine. Right? So you got it correct. You must share an easier way to do it now. A slightly easier way. You might be mind blown. You ready to see this?
Yeah.
Now, I would do it like you, but while I was explaining that to me, I see the other way to do it. Come on, answer that question, right? This is our what?
Tangent.
Talk a little louder. I'm not hearing you much.
Oh, sorry. There's a tangent.
Right? This is
That's a triangle.
the angle between the tangent and the triangle is equal to the
Is
anybody see where I'm going with this? Anybody in class? Think ahead and see where I'm going with
It's
this?
equal to the interior.
Oh!
Yes, sir.
Okay,
Watch, right?
so oh,
And think to yourself, what do you think this could be?
that's
You see same thing I just used, the same theorem, but just on the other side.
That'll be 56 too?
Now,
Oh no.
watch this, watch this, watch this. Let's think I can figure out what this angle gonna be.
48.
Yeah,
Oh,
48. And and I said that was what?
that'll be 56.
What is 56 plus 48?
That will be 104.
Selena, you are a little bit mind blown. Did you see that?
Yeah. I didn't realize that.
Ah, cool, eh? Right? But I doubt most students are gonna use that method. But I'll show both methods, right? In the event that a student does see it. But like Darius, you understand what I just did?
So that's why I figure it out. But yeah.
Hey, Darius, you're bad. Because I want to do like how Celine did it, right? But like I said, when she was talking to me, when she was calling it out, I realized I see it. Yeah. That is elite ball knowledge. Pick up yourself. All right. So I just want to go over that to anybody that might be confused. Iran, you there?
Yeah, sir.
So Aaron, I have two ways you can do this question, right? Two ways. The way like how Darius did it, or the way how Celine did it. Let me explain how Darius did it, right?
Mhm.
So Aaron, are you seeing a tangent in this diagram?
Yes, sir.
So
What's the
I don't know
tangent?
if it's just me, right? But like I see like markings on your screen. I don't know if you could like kind of clear it out.
Um,
The marker by the 48,
oh,
sir.
pause my laptop. Um, right. Yeah. Yeah. So wait, I want to try something I never tried before. Give me a second. I will tell me if it work. Mm. Where is it, bro? Yeah. I guess how to do that, boy. Take a mouse. Okay, yeah, forget how to do it. The option is pop up this now. All right, give me a second, guys. Give me a second. Yeah. Wait, I'm just yeah, guys. So yeah, Aaron, you there?
Yes, sir, I'm sorry.
Right, so Aaron, what line is he tangent over here? Which one is he tangent?
I'm sorry, X to Y, sir.
Right. And can you see that we have a triangle over here?
Yes, sir.
And can you see a tangent over here?
Yeah.
Can you see an angle between the tangent and the triangle?
Yes, sir. The 56 degrees.
And that'll be equal to the interior what?
The interior of M, sir, angle M.
Yeah. So this will be 56 degrees. And you can apply the same thing over here. What's the angle here for over here? What's the angle between the tangent and the triangle?
48, sir.
Right? And that will be equal to the what? So check it out again, right? Maybe confusing because it has so much things on the screen. Watch.
I didn't see that other triangle there.
Seeing that?
Yeah.
So this will be what?
This will be 48, sir.
Right. And if you know this is 56 and this is 48, we gotta do.
You have to add them and then minus by 180, sir.
No, 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 no. They're asking us for this angle over here.
Or the
Right?
whole angle.
Yeah. So if you know that this is 56 and this is 48,
Yeah, you have to add them, just add them.
yeah. That's really cool, right? Like you don't think about it like that?
So for when I circles always used to like intimidate me a lot when I was doing it. I used to feel scared when I'd see one until now, sir.
But don't worry, after today, you will be a lot more competent in it. I hope. I pray. Pray into the math gods, right? Yeah. So does everybody understand that method? Like the method where I'm saying like, the interior opposite angle? Yes or no? Does anybody not understand that? Tell me. Everybody real quiet, boy. What?
Yes, sir, I understand it. It's just I'm missing my partner in crime.
Oh yes, yes, you should tell them to join. Should I convince them? But
Yeah, so I'm missing Ria. Should I help me make it go bold, but she's not here.
oh boy. So for those who don't know, like per se, this is one of my actual students. I was teaching my Form 5 class, and I don't know what was her obsession with me and going bald. She wants me to go bald. I don't want to go bald.
Do it for the plot. Do it for the plot.
No, no, no. Forget that plot. Drop that plot. Drop that plot. Ha. I see me.
But
I
he's
want.
busy,
I
so that's why she couldn't.
say that
She's
again.
like,
It's a buzz season coming up.
No, 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 no. I have here what eh? If I like I one in maths, I will surely why I used to look like without hair on my head.
I actually saw it. So it looked like a I don't want to know.
If I like I one or two in maths, I will surely the picture. You know what? Even better, I'll post it on my status.
So, all right, so if I get a distinction, you gotta go buzz.
I'll do what? Oh, damn, damn. Oh, God. Well, that almost guaranteed, Darius. Gosh, man. I probably shouldn't make that bet because I know you're going to get a distinction. Hey, boy. All right. Let me go through the other method, right? So that was one way you could do it. Let me just put on the working over here. So one way you could, this is option one. This is what I would have do in hindsight, right? Guys, pay attention, right? X, Y is our what? We're gonna run through this fast. X, Y is our what?
Tangent.
Come on, fast.
Tangent.
Tangent,
A
right?
tangent.
Right? And what is the name of this shape?
Isosceles.
No,
Triangle.
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 Are you seeing an angle in between the tangent and triangle?
Yes, sir.
Right. So that would be equal to the interior opposite angle. Yeah. Right. So that means this. That is what? What's the angle? What's the angle?
56 degrees.
Right. And okay. Are they seeing any other angle? Are they seeing any other angles? Right. That's in between the tangent and a triangle. Yeah or no?
KML.
Not all. Yeah. Right. And that would correspond to this over here. Let's watch. It's a lot of drawings to do, but tell me if you're seeing this. Yes or no?
Yeah.
Right? And if you want to figure out this, how do you do that?
Add them together.
Yeah. And you get 104, yeah? So how much of you guys would have do this method? I think it's harder to see, but who would have done it? Like who in class here would have done this method?
I was on it because I actually saw it.
Well, that's good. That's good. Nice. Right? And if he's using this method, your reason would have to be, right? You would say angle between the tangent and side of triangle is equal to the what? Is equal to the what, guys? Somebody tell me. I don't like how everybody going so quiet. Is equal to the what angle?
The opposite interior
Yup.
angle.
Right, the interior opposite angle. Nice. If you do it like that, that's what you gotta say, right? If you do it like this now, so Celine, just to make sure I understand what you were saying, right? You're gonna find, you know that this is 90, yeah? You know that is 90.
Yeah.
If that is 90, what does go with? What that would be?
That would be 90 minus 56, which is 34.
Right? 90 minus 56, right? Putting it over here for everybody to see. Right? And 90 minus 56, that'll be 34, yeah?
Mm-hmm.
right? And if that is 34 degrees and this is 42 degrees, what would this entire thing be?
That will be 76. That entire angle.
Right? And if that is 76 degrees, tell me, what kind of shape we're dealing with over here?
A quadrilateral.
Not just any quadrilateral, or what kind of quadrilateral?
A cyclic.
A cyclic, yeah, a cyclic quadrilateral.
Right. So opposite angles equal to 180. So 180 minus 76 will be 104.
Right. Who would have done it like this?
Me.
Right? Who would have done it like this? Tell me, guys, who would have done it like this? Is there anybody that would have done it like this? Place went real quiet. I don't know what's going on. I don't know what's going on. Okay, but this is the other method, right? This is the other method. Right? And Celine, we need to, well, they said find the value of each. They didn't say give a reason, but I would still give a reason. Oh, it's 1 mark. Oh. If it's 1 marks, well, if it's 1 mark, you don't have to put a reason, right? So, Celine, you don't have to put a reason. And you're probably smiling because of that. Hence, Celine,
Yeah.
you don't have to do any writing, right? So either approach is correct. So the answer is 104 degrees. But if you had to put a reason in, what would you say? Tell me, Celine, what would you say if you had to put a reason in?
Well, I would say that since we'll have to find the angle OKN by minusing 90 from 56, which is 34, add 42 plus 34 to get 76 degrees. And we're using the cyclic quadrilateral rule, which is opposite angles equal to 180. So 180 minus 76, you'll find angle M to be 104.
Great. Right now, angle KLO. We first need to figure out where exactly KLO is. And to do that, I'm going to start from K, then I'm going to go to L, then I'm going to go to O. So KLO. Right? So KLO. We already find the angle already. What's the angle? Remind me, what was the angle?
42.
Right, so we found that previously. Could you just remind the class how we got that to be 42? Wait.
So,
Yeah, tell me.
right, so since that is an isosceles triangle, KLO, that's an isosceles triangle. So we have the radius OK and the tangent to XY, and that forms a 90-degree angle. And to find that angle K, you minus 48 from 90, and the base angles equal to each other, which is 42. So both angles will be 42.
Great. Right. Now, Celine, we want to move on to MLK. So we're going to start from L. We're going to start from M. Then we are going to go to L. Then we are going to go to K. Right? So MLK. So the angle we are trying to find for is angle L. I'm going to know if you're okay with that.
Yes, sir.
All right. Right. Do you have any suggestions?
Not as yet.
Not as yet. Let me just check something. What about the rest of you guys? Does anybody else have a suggestion? And by the way, Selena, I guess I could give you a little hint, right? I guess I could give you a little hint. This is the little hint I've given you. All right, let's move back on to the question. All right, so angle MLK. Let me see how you're going to figure that out. So this one a little harder, you know. It's a little harder, Celine.
I could see that.
Say that again.
I could see that.
So let me ask that question, right? Do we know what this angle is?
96.
right? This is 96. Where's the angle? The angle is at the what?
The center.
Right. That's at the center. Okay. This angle is at the
That one is at the circumference.
right. Is there any theorem we could use to figure out for this?
So those two angles will equal to each other, which means both are 96. No, wait.
No.
No,
Nah, you
wait.
make a mistake.
Okay, no, that will be half of 96.
Right.
Right.
Because this one is at the
Circumference. So that'll be 48.
right. Is there anybody that does not understand why I'm saying that this is 48? Darius, you understand why I said that was 48?
Yes, sir.
Okay, what about the rest of you guys? If this is 96, do you understand why I'm saying that this is 48?
Yes, sir.
Okay. All right, guys. And remind me, what did we find this big angle here to be equal to again? This big angle over here. What was our big angle over there?
42.
So, guys, if this is 42 degrees and this is 12, is it possible for me to figure out for this angle here?
Yes.
So, okay, guys, here what I'm saying, right? This entire thing is 42. This small thing over here is 12. How would I figure out for the missing angle?
42 minus 12.
Yeah, 42 minus 12. And what is 42 minus 12?
30.
So, guys, do we have enough information now to be able to figure out for this?
Yes.
How would I figure out for this?
So you could add 42 and 30 and minus it from 180 to find angle F.
Right. So we know that this is 48. Right? And we know that this is 30. Aaron, you understand what's going on?
Yes, sir.
Okay. Now this one was tricky, yeah? I wouldn't lie. Like, this one might give some students trouble. It would. If I was in all their shoes and I had to see it, I saw it for the first time, I would think a little bit. But do you understand that the angle here, we found that earlier to be 96, right? And this angle was at the what? Where was our angle?
The center.
Aaron, this angle was at the?
What you said, sir, I didn't hear.
The 96 degrees was at the what?
So,
So that's what C.
center
And this angle was at the?
at the chord.
Now, if you are along this line,
Oh, sorry, the circumference. The circumference.
right, and the angle at the center is how much the angle at the circumference?
Twice the angle at the circumference.
Right. So if this is 96, this would have to be 48, yeah?
Yes, sir.
Right? And remember, earlier we found that this entire thing was 42. So Aaron, if the whole thing is 42 and this small one is 12, what would I figure out for the missing one?
Well, yeah, I have to say 42 minus 12, sir.
Right. So we end up with this triangle over here. Right? The 30 over there and the 48 over here. How would I figure out for the missing angle now?
Well, you'd have to say 30 degrees plus 48 degrees minus 180.
What would you get?
$102, sir.
Okay. If you are confused completely by this, tell me, guys. Darius, are you confused at all?
I get it, sir.
All right.
No, sir.
What about the rest of you? I'm going to start calling some names. Dari,
Yes, sir. I get it. I get it.
it makes sense?
Yeah, it makes sense because I'm doing it in my book as well too, right here. So it's adding up.
Okay, nice.
Yeah.
Adika here? Adika, where's the plan?
So I was talking all the time.
That is why I was like, there's some voice sounding familiar, you know. I was like, this sounding familiar. All right. Okay, okay. Adika, everything making sense so far?
Yes, sir.
Austin, the cricketer. Austin, I wonder if you understand everything so far. Austin, if you hear him now.
Yeah, so we good.
We good. Are you sure? And okay. I see we have
Yeah.
Danelle, Perseus, Sapphire, Eric. Sapphire, you okay?
Yes.
All right. So let's move on now. Right? Last one. K and M. K and M. For me to figure out what angle they are talking about, I'm going to start from K, then I'm going to go to N, then I'm going to go to where, guys? K, then to N, then to where? Right, M. So K to N to M. So they want us to find for angle what?
N.
Yes, this angle over here. Is there anybody that's really confused as to how I know we want to find for this angle?
No.
Okay. Now, in the last question, guys, we found for L, yeah? We found that L, right, was 102. In the last question, we found out this was 102. I given you a huge hint over here. From that point, the answer should be obvious. What is this angle going to be? Tell me, guys. Think about what kind of shape we're dealing with.
So it will be 180 minus 102, which is 78.
Okay, how much of you all think the answer is 78? Darius, you agree that the answer is 78 or not?
Yes, sir.
All right. Adika, do you think the answer is 78?
Oh. So you can explain it.
You see
Please.
you see how I cut a call here to see that I was confused. I don't want that. If you're confused, tell me one time. Don't stick. All right, so let me ask you a question, Adika. What kind of shape is this?
Or a quadrilateral.
Not just any quadrilateral. What kind of quadrilateral?
Cy
Uh,
cyclic.
yeah. What do we know about opposite angles in a cyclic quadrilateral?
That they are equal to 180.
They add up to 180. See it,
Okay.
right?
I understand it now. Yeah.
Nice. Nice. So yeah, guys, this shape is a cyclic quadrilateral, right? And the angle opposite to 102 is N. So to find the answer, it's just going to be 180, right? Minus 102. And that'll be 78. Perseus, you understand?
Yes, sir. Yes, sir.
Here we good. Nice. Now this was a bit harder than the last question. I'll be honest, these set of questions is harder. But at least you didn't have to write the reason for every single one. Okay. Is there anybody that would like me to go over anything here, or like you ready to move on to the next circle theorem question? Salma.
The next question.
All right, Iran, Dari, you understand everything I did here?
Yes, sir.
Yeah.
All right. Um, I feel like I did every single question. Yes, it's crazy. I just All right. So there we go. Who wants to do this question with me? Do I have any volunteers? Any takers? Anybody? Adika, you there?
Yes, sir.
I think we did this question together, you know, and it was any circle theorem, right?
I don't remember this one.
Okay, well, never mind. We will do it from the start, right? So this is the diagram we're dealing with. Question: are you all seeing the cutters?
Yeah, Y and Z.
Yes,
Okay.
sir.
So Y and Z will be what? They will be what to each other?
The same.
They'll be the same, right? Are you seeing a tangent in this?
Yeah.
Yeah,
Anytime you see that tangent, you should be thinking 90 degrees on what else? Int, int, int.
Interior.
interior opposite angle.
Yeah, yeah. And I also see a diameter. Can you all spot the diameter?
Yeah.
What's the
Yeah,
diameter?
RP.
Right. The diameter cuts the circle in half, so it creates a semicircle. And the angle formed in a semicircle is? What's the
That's
angle in a semicircle?
Oh, 180.
180 degrees.
90 degrees.
90 degrees.
90
Oh.
degrees. 90 degrees. Yeah.
Oh, because it's half.
Right, watch. I'm not sure what we're talking about. This is the diameter, right? The angle you make. So this angle here I'm making is at 90 degrees. That's what I mean. That's why they say. That's why they say the angle formed in a semicircle is always 90. No matter where I form this angle, once it's in a semicircle, it'll give me a 90. No matter where I form it, I'll get a 90. All you understand?
Yes, sir.
Okay. Cool. Right, so we want to figure out what x is. Angle x. So Adika, we want to figure out what x is. When you see this, is this you? Is this your reaction? Come on, Adika, is this your reaction upon seeing that?
Low key, low key.
Low key. All right. So we see that x over here, you're seeing real x. Real x. So Adika, my hint is, are you seeing a tangent?
Yeah,
Come on, Adika, are you seeing a tangent?
yeah,
Are you seeing a radius?
yeah.
We see angle between a tangent and a radius.
90 degrees.
So what is angle here supposed to be?
That's supposed to be 90 degrees.
Right. So in other words, Adika, if I add up all the angles here, what is it supposed to be equal to?
90 degrees.
So tell me, right? If I add up 2x and 3x, what is it supposed to be equal to?
90 degrees.
Right. So in doing that, we can form an equation, yeah?
Yeah,
So 2x plus 3x, and that's supposed to be equal to 90. That's supposed to be equal to 90. Is there anybody that's really, really confused as to how I went from this line to this? Tell me no. Aaron, are you confused? Dari, tell me if you're confused.
No, not at all, I understand.
Nah,
Alright.
good.
So
Yeah.
guys, all you understand, right? The angle between a tangent and a radius, right? So you see the tangent over here, you see the radius over here, is 90. That's 90. We know that is 90, right? This is 2x and this is 3x. So in other words, if you add up all of this, it's supposed to be 90. So that's what forming my equation. And from here, I can solve for x. So Adika, imagine you had 2 x's, right? And you add 3 more x's. How much x's you have now?
it will be 5x. So it will be 90 divided by 5. And
Yeah.
then you'll get 18. And then you'll multiply 18 by 2 and 18 by 3.
Okay.
Or
Somebody really did say, let Adika cook. Damn. Okay. So guys, if you're confused, right? Okay, imagine you have 2 x's, right? I have 2 x's over there. And over here we have 3 x's. If I add everything together, how much x's I have?
5.
I have 5 x's, right?
5x, sir.
I have 5x. So 5x would be equal to 90, but I want to find for 1x. So if I want to find for 1x, what would I have to do on both sides to get 1?
Divide to get
You
1
have to
4.
divide by 5, so
Right. Why? Because I'm multiplying x by 5. So I do the inverse operation. So I divide by 5. 5 into 5 is 1. So that's 1x. And if you do something on one side, please do it on the other side. So x will be equal to 18. You're okay with that? I mean, if you guys okay with this.
Yes, sir.
For serious, I need you to tell me if you're confused. Huh?
Oh, no, sir.
All right. Dari, you good? Dari?
Yes, sir. And you know what I realized too is that they just give you the same questions like this, like in the earlier sections. So like one I was thinking it as to like it because I was going and say that now, right? But I was waiting until they find another way. But then how she see it, like dividing the 90 by 5 and you get 18 for 1, so you take the 18 by 2 and then by 3, so you get a whole section right there complete.
Mm-hmm.
You understand? So yeah, I understand.
And you will see another similar questions come. And like any like question 1, question 2. They might give you a
Yeah.
rectangle and they might say it's 2x, they might say it's 3x, they might say it's 4x, they might say it's 7x.
Exactly. So yeah.
And you know that
Correct.
some of the angles is 360.
Mm-hmm.
So you would form an equation for x, divide throughout, and you get your answer. So that's very reminiscent of those types of questions.
Yeah, correct.
So here what I'm going to do, right, guys? I have trust issues. I think I'll get that by now. Right? So if I know x is 18, what am I going to replace 2x for? So we know x is 18, eh? We know that x is 18 now. We know what the number is. So what is 2 by 18?
36.
All right.
36.
So that angle over there is actually 36, right? And this angle over here was 3 times 18.
54.
Right. And if we are correct, when you add up this and this, we're supposed to get
90 degrees.
90 degrees.
90.
what is 36 plus 54, guys?
90.
Explosion. Mathematician. Right? And over here, where's the angle?
18.
Somebody's 18, right? Because it's x degrees. And we know that x is 18. Is there anybody that's confused at all? Tell me now.
No, sir.
Some people, I feel like some people, they confused as to why we divided. We divided because we wanted to find for 1x. Think of it like this. You're multiplying 5 by x. So the opposite of multiplying by 5 is divide by 5. Right? And when you do this, 5 into 5 is 1. So we end up with 1x. And if you do something on one side, it's on the other side. So 18. And I feel like some people would be confused about where 36 come from. Guys, if it's 2x, right? And we just find x will be 18, right? So that'll be 2 by x. X is 18. So 2 by 18, 36. 3 by 18, 54. And over here is x degrees. You replace x with 18. So I think everybody understand that, right?
Yes, sir. Just remind me of functions in a way. That's the kind of vibes I get to.
Functions. Okay. Because you see next.
Yes, sir.
Right. So here what? The reason for this is going to be the angle between the tangent and radius is what?
90 degrees.
Right. Right. So I take it, are we okay with this question, right? So Adika, let's move on. So Adika, what I'm going to do is, right, if I'm going to replace the unknowns with what I know now. So you see that 2x, I'm going to replace that with what?
36.
So,
Yeah, somebody was saying something.
yeah. So like you see how like they provide so much lines. Would you lose marks for like not filling all the lines and like just giving like such a short answer like that since it's 2 marks? Like if you were supposed to give like a proper thing, like what would you say?
I would say this. If you want to be real specific, you will say the angle, right, between the radius OP and tangent AB is 90. But I don't know why you leave so much space. This is the answer. This is they're wasting they're wasting paper, they're cutting down trees for no reason. This
I
is
see.
you're getting 1 mark for this, and you're getting 1 mark for this. Right? Don't know why you're leaving so much space.
I see.
Right. So Adika, I'm gonna replace this with 36, yeah?
Yeah,
And this with 54.
yeah, and then 18.
Right. Cool. And they want me to figure out angle Y. Okay. Let me see if we can figure this one out. I see in 2 ways you can figure this one out. 2 ways.
54 plus, wait, yeah, 54 plus 18 is
Nah.
no
If you do that, you would be finding for this angle over here. Watch.
equal.
So Adika, we want to find for angle Y, yeah?
Yeah,
So I want you to in your head to try to visualize what triangle you're dealing with. Try to think about what triangle you're dealing with. Well, you'll be dealing with this triangle. Some of that confuse you.
nah, is a right angle. So if it's 90 plus 18, if it take away that from 180,
Yep. Right? So that's going to be 180 minus open bracket, right? 90 plus 18, yeah?
yeah, and you'll get 72.
So here what? If you have to find an angle, I would advise you all to kind of lock in on a specific region. So when they're asking for angle Y, I immediately lock in onto this angle, this triangle over here. And our reason for that is because I know RP is our what? Where's RP? Somebody tell me RP is our what?
Diameter.
Right. And that would make the angle here 90. I know 90 here. I know 18 here. Right? 90 plus 18 is 108. I could take that away from 180 to figure out for angle Y. So Adika, it makes sense?
Yes, sir.
Right? So angle Y is equal to 72 degrees. And the reason for that is because we already have the working here, 180 minus 90 plus 18, and you need to say the theorem we used. So Adika, any theorem we used was the angle in a semicircle is always 90 degrees.
Yes.
Yeah. The angle in a semicircle. Like, Dari, did you understand this? Aaron, did you understand? Did you all
Yeah.
understand this?
Yes, sir.
Okay.
Yes,
I
I
was a
get it.
little, I was a little confused on the way you get 90, but I now get it. I now get it.
Hey, from the start, right? Check this out. Check this out. You see how I see in this line passing through the center? You see how I see in that?
Mm-hmm. Yeah.
I tell myself one time, that is our what?
Mm-hmm.
What's that? What's that? If I pass through the center and they're going from one end to the other end, what's that?
90.
No, a
The
diameter.
diameter.
Diameter,
Then
yeah?
that's it as well.
A diameter. And a diameter cut a circle. Tell me, Dari, what is a diameter cut a circle in?
2 parts.
Right, 2 equal parts, yeah?
Mm-hmm.
So a semicircle, and the angle in a semicircle is 90, one time, bam. Yeah. So anytime you see a diameter, look out for that. Right. So here what, Dari, I want you to help me with this question. So I'll give you an easy one. They want you to find for angle Z, right? What was the
Mm-hmm.
angle we just find for?
Y.
What we find Y to be?
What we find Y to be
Yeah, what do we find Y to be?
72.
We think angle Z is.
Z.
Mm-hmm.
Um,
Are you seeing bunny ears or like cat ears?
yeah.
Okay, so think. You think this could
Yeah.
be?
72.
Yep.
72.
Yeah, 72. Do you know the reason why?
Because And Q basically.
So okay, both of them are the what? Both of them are the
Both of them have the.
wait, both of them are at the what? If you're over here, that's the circumference, right? So both of them are
Yeah.
both of them are the what? They
The
are the
radius.
no the circumference. From
Conference,
bottom.
right?
This is the circumference. Any point along this line is the circumference. So both of them are the circumference. What chord would you say this angle is standing up on? Imagine this is legs. What is it standing up on?
The radius.
Nah,
So the radius.
no, Dari, watch this, right?
Which one is it? All right, huh?
Imagine this is our leg and this is our leg. What is it standing up on?
Um, 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 Hold on, sir. Have it. Hold on. Have it. The diameter.
Nah,
That's no.
for the SP. Right, watch that again. So Dari, you gonna do a next question with me. Eh? You gonna do a full question with me. A full question with me. And don't worry, that's fine. You're gonna learn. Right. So Dari, again, imagine these two things as legs, right?
All right.
Can you see that it's standing up on this line over here? Watch. See. So watch. SP. This is S, this is P. Let me ask that question. Is SP going through the center?
Yeah.
Oh, no. Okay. Take your time, eh? This is the center. That's the center.
Right.
Are you seeing
No.
SP passing through the center?
No, sir.
No. Does it have anything to do with the center?
No, sir.
No.
No.
So you can't tell me it's a radius and you can't tell me it's a diameter. Right? This line over here connects point S to point P. So what's the name of that?
Chord.
Right. And this angle is standing up on that chord. All right, again, think of these things as legs. It's legs. Can you see that it's standing up on SP?
Yes, sir.
Okay. What do you think angle Z is standing up on?
So the chord.
Which chord?
S and P.
Right, SP.
Yeah.
Good. Are both of them standing up on the exact same chord?
Yeah.
Yeah, watch.
Yes, sir. I know see that. Yeah.
Right. Are both of them in the same segment? Remember, right? A segment is just a piece of a circle. So if you cut a pizza like that, first of all, your mother gonna get licks because why you cut a pizza like that?
Right.
Second of all, you're gonna end up with two different pieces, right? You're gonna end up with this piece and this piece. That's called a segment. So
right.
Can you see that this angle and this angle, both of them in this region over here?
Yes, sir.
Right. So, and can you see that both of them, they are along the what? What are they along? The what?
Circumference.
Right. So let's put everything together now, right? Angle R and angle Q are at the circumference, right? So
right.
Angles at the circumference standing on the same what? Standing on the same
chord,
right? In the same what? What do you call a piece of a circle, like a region? If you cut it.
Segment.
Right? And the same segment are equal. So let's write that down together. So you're gonna say angles at the circumference.
Same conference as
angles at the circumference standing on the
On the same chord.
Chord, chord. Yeah, don't say chord. That's chord, eh?
Yeah, I know.
But I understand why you would say that. I understand why you would say that. Right? Standing on the same arc or chord in the
Mhm.
what? In the what? In the same one.
Segments are always equal.
Right. So here, you give me the rest of the questions more. Adika, take a little break. I see that oh, that's it. The questions. Okay, okay. Adika, was there any questions here that I didn't understand?
No, sir.
This was easy, right?
Yeah. So normally, if I was doing this paper in the exam, I would have just leave out the whole question.
You would have just sleep.
No, just leave out the whole question because I didn't understand it.
But
Same.
But
but
now I understand it,
but guys,
and I
no,
could actually try it.
that's good because when you look at this, here what I see in a tangent, mark that on one time. I see that radius, mark that on one time. Angle 90. Maybe you could do something with that. Next thing, I see in bunny ears. You know what? You know what? If I see in bunny ears, this and this how
That
they
could
be.
add him one time.
Say that again?
As I said, that could if it did show one, it could add in one time, right away.
Yeah. If it was just x,
Mm-hmm.
90 is equal to x one time, right? I see in a diameter. Think semicircle one time, 90. Guys, it's not hard. I think after today, if you like real practice and you send me questions and whatnot, I think after today's circle theorem shouldn't be a bother. I think it should be cake. Well, I agree or like now?
Yeah. I feel like I just gonna do like around 5 or 7 questions on circle theorem on past papers and then move on. Cause yeah.
Yeah, if you do like that, tell you like you'll be good. You'll be good. Good to go. Right? I had to go beach later today, but like as soon as I come home, if all I do any questions on it, I'll check it. Right? And if all I want to have like a late night session or whatever, sure. Again, I come like I sell my soul for
Wait,
24. Come like I
do we
sell my
send
soul.
it on in chat or to you privately?
If all I want. I cool with anything.
Okay.
Right? Come like I sell my soul, yes, babe. All right. Let me move on to another paper. So Dari,
Yes, sir.
you're not getting away. You're not getting away.
No, because I hear now I have it, but like when they call up my name, there I get a little. I was thinking,
Well, I need you to get it under control. Because
yeah.
when you go to do the exam and you're in the exam chair,
Mm-hmm.
like you go and get more pressured. Like me just calling your name. So let me just fix that problem one time.
Yeah.
Right. So BC, right? Waiting guys. BC is our what? BC is our what?
You're referring as to like the shape or the angle?
Now, okay. B to C refers to a line. Watch. B
Yeah.
to C. That's our line.
Right. That's the line.
That's our line. What is the name for that line?
Radius.
Nah. A radius goes from the center of the circle to
Now sir, the
that
short.
point on the circumference.
Now sir, the short. My bad.
Right? Cool.
Mm-hmm.
Chord. Right? OE now. O to E. O to E. This starts from the center and it goes to a point along the what?
Um,
Samadari. What do I call this? If you're along this line here. Well, I can't really say line, this curve.
circumference.
Right. So you're going from the center to the circumference. What do you call that? Center to circumference. What's the name
Um,
of it?
um, um, so, The segment.
Nah, a segment is an
Hold on.
area or a piece of a circle, right? That'll be the radius.
Right.
Don't worry, let me just take a little detour and I'll run through back the properties of a circle with you because you're getting in real trouble with that. First things first, what would I call this blue line, this blue curve over there?
Circle.
Right, this is the circumference.
Right.
What would I call this dot in the middle?
Center.
Center.
Yeah.
If I go from the center to a point along the circumference, what would I call that?
The radius.
You see, look, I don't know what is working, you know. Look, you get to it here. You get to it here, but like when you see that question, it's like, oh my God.
Yeah, but
Okay, what is this?
that is the segment.
Now, again, a segment is an area, Like, there's our line. This is our line I draw here. I didn't shade anything. A segment would be shaded because it's an area.
God.
If you're having trouble remembering it, right? Well, it's that question.
Yeah.
Question, right? So, like, tell me, what is this red thing called?
So it's a chord.
And what does the chord do?
Is a chord. Basically, it does run to like a line.
It connecting.
It's connecting your phone to the wall.
Exactly.
Yeah.
So you know what this line doing here? It connecting this point along the circumference to this point.
Yeah.
Exactly. What? All right. What would I call this? Okay, so let me just specify something, right?
Now say that's a chord.
Yeah, that's our chord, right? Because it does not pass through the center. If it passes through the center,
If it passes through here, then is a segment.
nah, again, a segment is an
Not a
area.
segment.
A segment is an area. It's like this. Okay, if I shade this region, it called a segment, the major segment.
Right.
Segment is not a line. A line is not a segment. Yeah. Not a segment is not a line. If it passes through the center, it's a diameter.
All right. Cool.
So, like, watch this.
Diameter.
What I call that green line over there?
Chord.
Nah. What is it passing?
Wait. It passes the center, so
Right.
it is a tangent.
Nah. Diameter.
Diameter. My bad.
Don't feel shame, you're learning. The main thing is you're here and you're trying to learn. If you didn't come, or like if you just didn't try to improve yourself, then that'll be kind of bad. But like you're here, you want to learn, right? So I'm actually here. What would I call that pink line over there?
Tangent.
Yeah. So a tangent touches one point in a circle.
Yeah.
Okay, so just to make sure you have it locked in, right?
Mm-hmm.
And by the way, while I explaining things, or like it finish paper, you know, this is January 2020. You can finish your goal question in the meantime and just wait. Or do more papers while you're at it. Yeah, so Dari, what would I call this? Better?
Yeah, that's a tangent.
What would I call this?
That is a chord.
It's not chord.
A radius. My bad.
A radius.
My bad.
It's okay. What about that?
That is a diameter.
Yes. And what would I call this? Does it pass through the center?
Nope. So it's not a segment. So it
So
isn't it.
again, a segment is an area. Eh?
Yeah. Yeah, I know.
Don't forget about a segment. The only time it could be a segment is if I shade something. So
Yeah.
in a,
So that
it's
is
not pos- it's not a
it's a
it's
chord.
not a diameter. It is connecting. So it is connecting this point to this point.
Yeah, it's a chord.
That chord, right?
Yeah.
Right. So Dari, if at any point you're confused, you have to tell me, you know. You have to tell me.
No. I have it now. I have it.
All right. So what is CD called?
CD. That is
So it connecting C to D. It connecting
Yeah.
C to D.
That is chord.
Right? B to D, it passing through the center. And they're going from one end to the other end.
Diameter.
Right? A to O, it's starting from the center and they're going to the circumference.
Radius.
Right. Okay, let's move on.
So somebody sent something for in the chat.
What did it say?
They said that they need to leave because they have to go eat lunch.
Okay, sure, not a problem. Send the recording immediately after. Right? Yeah. So, Larry, let's do this question, right? They want me to figure out angle X, which is this angle over here.
Right.
Right. Now, let me ask that question. What is O to B called?
O to B.
Yeah.
That is the radius.
Right, and what is O to E called?
Same radius.
In a circle, the radius is E.
And A.
In a circle, the radius is E. Okay, so in a circle, the radius is the same everywhere. Everywhere the radius is the same. Same thing.
Right.
So that would make this side and this side equal. So what kind of triangle does that form?
Isosceles.
Right. So if these are the equal sides, what would I make AB? AB is what?
Diameter.
No.
Hold on.
Nobody.
A to B.
Yeah, that would be the type of B.
B.
So I help you out here, right? I help you out. The base.
Base, right. Yeah.
Right? And this wouldn't be a diameter. Remember the diameter
No.
has to pass through the center. Diameter has to pass through the center. If it's not passing through the center, it's not diameter. And this specific thing now, that's a secant. Yeah. All right. So if you're dealing with an isosceles triangle, right? The base angles are, what are the base angles?
What are they?
The base angles would be what to each other?
A to B.
When the base angles would be equal.
Yeah.
So this is the base. So the angles here have to be equal. So if this is 37 degrees, what do you think this could be?
37?
Yes.
Yeah.
And if I know that this is 37 and this is 37, how would I figure out for angle X?
You add up the two and you take it away from 180.
Right. So 180 minus 37 plus 37. What will I get? Should get 116, I think. For mental maths, correct. 336.
7, 6, 6.
Wait, no, like that'll be 104. Because that could be 37 plus 37 is 670. So I'll again 106. What again for the answer?
Yeah, 106.
Yes, so 106.
106, right? Cool. So the answer for this is 106. And what was the reason?
You reason, forget any answer
Right. So how do you
by
get our answer?
getting the base,
Right?
which as we're finding out for B. And when we get it, well, both sides are equal, and it's an isosceles. So I mean, both sides is equal eventually. So when we get that now to find out for the above, we add it up and take away 180 from it.
Right. So you would say reason base angles in an isosceles triangle equal right? And you could also say sum of angles in a triangle is 180.
Yeah.
Right? Okay, why now? Right, so Dari, we just found out x was what?
1x,
Yeah,
106. Yeah.
x was 106.
Yeah.
Right?
Wait, I have a question.
Sure.
We're supposed to write the answer next to, like, for example, when you wrote x is equal to 106, you're supposed to do that?
Once you put the answer,
Well, in the
yeah, x is equal to 106.
Okay.
That'll be fine. That'll be fine. They have to give it as correct.
Okay.
You could write it over there, or you could write it over here. The reason that
Yeah,
the
because I just
reason
write it in the reason.
I didn't write it over here because this is reason, but either one is fine. So you could say that x is equal to 106 because of that. Yeah.
Okay.
And over here, obviously, you're not going to draw back the diagram. So we would have over here in the exam, you would say that x is equal to 180. And you would have this, you'd have this in the exam. You'd say x is equal to 180 minus 37 plus 37. And then you would say x is equal to 106.
Yeah.
When you have when in the exam, you wouldn't have this. Well, you will have this over here. So you'll have the answer actually written out here, right? And you'll have your reason here. That's why I said you didn't really need to write this. Because when you're solving it, over here, you'll eventually come up with x is equal to 106. Understand?
Yeah.
And this is just a reason. They just want the reason over here.
Thank you.
No problem. Right? Yeah. So this is 37 as well. Right, so Dari, see if you could figure out what y is. Before we do anything, are you seeing?
Yeah. Beta y, beta d.
Wait, take your time, huh? Take your time.
Yeah.
You seeing Bonnie yet? Be careful here, be careful. Let me ask that question, right? And let me explain why they try to tie up all the over here. Guys, what does this stand up? What does that stand up on? The angle. What does it actually stand on? It doesn't stand on BC.
The diameter.
Yeah, it stands on the diameter. Right? And it specifically stands on the radius OB. So guys, answer my question. Does angle A stand on the same chord as angle D?
No, so.
No. You see what I tried to trick you? You can't
That's
use
crazy.
that theorem over here. Right? Be careful, guys. Be careful. But Dari, what would I call this?
So you had to watch B. So you had to watch B and C.
Yeah, watch. If you wanted to use that theorem,
right,
diagram would have had to look like this. It would have had to look like this. And the reason why I'm saying that is because for this theorem to work, the angles must be standing on the same arc or chord. Right now, angle Y is standing on BC.
Yeah.
But angle A is actually standing on the diameter. right? They're not standing up on the same thing, Dari. Are you seeing this and this standing up on the same thing? So these
Yes,
are
sir.
leg here, these are leg here.
Right.
They're not standing up on the same thing. So you can't
Nope.
use that theorem.
Mm-mm.
Dari,
Sorry.
what
Yeah,
is
watch it.
what's the name of this? What's the name of this line? It passes through the center and it goes from one end to the other end.
The center line, highlight.
Yeah.
The
What's the name of that?
diameter.
Diameter. The
Yeah.
diameter cuts a circle in.
Half.
Right. So this is really a what? What's the name of half of a circle?
Circumference.
No.
Wait, hold on. Sarah,
When you buy chocolate, right, and you see semi-sweet, what I mean?
semicircle.
Like if you see semi-sweet, what does that mean? Do you think it'll be 100% sweet? Maybe like 50% sweet.
50%.
Yeah, semi means half. So what's the name of half a circle?
Semicircle.
Right. And the angle forming a semicircle is always
180.
nah.
Repeat back the question.
The angle in a semicircle.
Angle in a semicircle. Angle. Semi is half. So half is
Right. So I'll help you out here, right? Anytime you form an angle in a semicircle, anytime the angle is going to be 90. It's always
right.
90.
Right.
So let's write it down one time. One time. The angle formed in a semicircle is
90.
right.
Mm-hmm.
Okay. So can you see that this diameter is creating a semicircle over here?
Yeah.
Okay. And can you see that this is 90 degrees as a result?
Right.
Okay.
Yeah.
So we want to figure out for y. If I know that this is 49 and this is 90, how am I going to find for y?
90 take away 49.
Nah.
Wait, hold on.
What is the sum of angles in a triangle? If you add up all the angles in a triangle, what would you get?
T.
180.
Mm-hmm.
So that'll be 180 minus what?
49
Plus?
plus 90.
Right.
Yeah.
You're going up with 129. Say answer is 41. Let's check that from a little.
Yeah.
So guys, is the answer 41? Are you all getting 41 in the
Yes,
calculator? Yeah. Right. So Dari, make sure you're getting 41.
I get.
Right. So, to the person who asked me if I'll put my answer over here. Right? Check this, right? Even if you don't put your answer over there, hence when you do the question, you'll have it working over here. So most likely you'll say y is equal to 180 minus 49 plus 90. So you'll have it working over here, and you'll have the answer in the working as well. Right? So guys, do we understand how y is 41 degrees? Let me know.
Yes, sir.
Okay.
Yeah.
Right? So what we use here, we said that the angle formed in a semicircle is 90 degrees. We use that, right? And we also use the fact that the sum of angles in a triangle is 180. Right. So that was it for that question. So guys, are you all feeling a little better about circles? A little better?
Yes, sir.
Yes, sir.
Okay. Right, Dari, I see that you're having some trouble with circles. I need you to do real practice, eh? Right? I
Yes,
here
sir.
to help
I know
you.
what to do. Yeah.
Here to help you, but you need to do practice because I see you're having
Mhm.
trouble with the the fundamentals of circles. Like, okay, which
Yeah.
one is our radius? Which one is our
Geometry.
diameter? Which one is our chord? Which one is our secant? These kind of things
Yeah.
it will affect you,
Mm-hmm.
right? So, guys, I'm gonna call that a wrap for circles. As it's already 5:30. I'm gonna give you all some time to relax for like 10 minutes. I'm gonna come back. I'm gonna start trigonometry. Is everybody okay with circles up to this point? Is there
Fine.
Yes, sir.
is there anything in circles you feel like you want me to clear up?
No, sir.
No, sir.
All right, cool. So I'll see you all back at 4:40. 4:40. Yeah. Good luck, guys. We're gonna make it. We're gonna make it. I'll let you get a 2 or a 1. Right? How much of you guys writing privately here? And how much of you all just doing it for the plot?
So me, I do it privately.
Adika, you doing it privately. So like,
Yes.
wow. So yeah, how to
This
do
one,
good at this exam?
yeah, this won't be the third time I
The two.
tried.
Gosh, but I the worst. I don't know. I glad that I kind of picking up on it because I pass physics, maths, and him no maths, physics, biology, and chemistry, and I can't pass maths or nothing.
Cool. And how much of you all are just doing this because you want to do the exam in January, but you're actually doing it in school and you're doing
Sorry,
June?
third time.
So me.
Well, guys, don't be shame, man. The main thing is that you're here and you're trying to understand.
The
And
third time is a charm. We'll pass. We will pass with flying colors. I believe.
right?
Fingers crossed.
Yes.
And I cross my fingers. Yeah, I don't manifest our negativity. I don't want to manifest our negativity. My fingers remaining uncrossed.
So I know he's sitting. I just doing it to see what's the highest mark I could get.
Darius, you're just doing this for the plot.
Yeah.
But yeah, right, hear this, right? Like I said, if all you're willing to work day and night to get this one, I'll be there with you, right? I'll be there supporting you. So those are rewriting. Do after today, don't sleep. Well, I mean, you gotta get some sleep, but just keep grinding. Do questions, send it to me. Otherwise, you're gonna forget everything you did today. And we don't want that to happen.
So if you're running it back later, like do that paper or not?
Paper one, all right.
So, and it was really awful thing I had to do paper 3.
Yeah.
I feel like this year,
Yeah.
I feel like linear programming and area and volume will come.
So because the thing is, my teacher was so biased, right? She had favorites, and she didn't used to help. She didn't used to want to help the rest of the class at all with the SBA. She don't need to help her favorites with it.
I feel like the
And
bad
it
thing
was
that's happened is that like in school, it teachers just focus on the students are doing really well. I forget about the students are struggling. But the students are struggling is the ones that need the most help. It's crazy. Five more minutes. I'm gonna start back. Ole, I have a question. Ole, I want to see me open a gift, like in front, like now, like now.
Yeah,
Okay.
why not?
Sure, sir.
Give it. Okay, friend said give her 1 second. Right. So in the meantime, let me just explain everything that we need to cover when we doing trigonometry, right? Right. Right. No, no, no. Nope. I don't like barbecue chips. I hate that. Trigonometry crash course. I really don't. Right. Yeah, I hate barbecue. Right. So when we're doing trigonometry, right? You need to be able to work with 90-degree angle triangles and non-90-degree angle triangles. A 90-degree angle. All right. 1 second. So guys, when we're dealing with 90-degree angle triangles, we're talking about triangles that have a 90 degrees in them. So I'm talking about triangles that look like this. Yeah?
Yeah.
Was there anybody here in class that did not know what a 90-degree angle triangle is? Selma. Dari.
Yeah.
Dari, do you know what a right angle triangle is? Don't be shame, eh? Don't be shame. Tell me. Say it in big.
I
If
know
you
what a
know.
triangle. Yeah, I know.
Okay, good. Don't feel shame, man. I just asking you to make sure you understand. It's for your
No,
good,
no,
it's for your
I
own
know,
good.
I know. Don't worry. If I
Right?
don't know anything, I'll just yeah.
All right. So when we doing this, right? You need to be able to work with Pythagoras theorem. Pythagoras' theorem, right? And Pythagoras' theorem is a squared is equal to b squared plus c squared, right? Now, when you're doing Pythagoras theorem, it's important that you know that this is the hypotenuse. The hypotenuse, for those of you guys that don't know, is the longest length in a triangle. The longest length. And you see B and C? B and C are just the other sides. Right? And to use Pythagoras theorem, this is the information you must have. To use Pythagoras theorem, you must have two sides. If you don't have two sides, you can't do anything. Right? So that brings me to the second thing, trig ratios. So guys, here what I was saying, right? To use Pythagoras theorem, let me give you an example. Like we just said that this length was 9 and this length was 8. How much lengths do I have here? Tell me guys, how much lengths do I have here?
Um, 2?
2. If you have 2 lengths and it's a right angle triangle, Pythagoras theorem is the only thing you should be using. Unless you want to complicate your life. Which you shouldn't. Which you shouldn't be thinking to do. Right? So yeah, guys. And do you all know which side will be the longest side here? Yes or no?
The longest side would be the opposite to the
Right
right
angle?
angle. Yeah.
Yes.
So
Right?
yeah.
So in this instance, we could use Pythagoras theorem, right? I'm just going to make a mini example, right? Mini example. I will go full circle and explain everything in detail shortly. But I just want to give you a little example, right? So guys, if we don't know what the longest side is, and we could assign a variable to it, give me a variable.
And is
X.
hypotenuse?
Yeah, is the hypotenuse, but
X.
we can call it X, right? It is the hypotenuse. If you wanted to say H, sure. If you call it X, sure. Right? We mainly use that notation when you're dealing with triangles, right? 90 degrees, but you have one side, right? And you have an angle. You typically use that naming convention when you're doing trig ratios. If you want to say H here, or you want to say hypotenuse, that's fine. The point is you're applying the concept correctly. Because you could call this whatever you want. You could call this theta. You probably shouldn't do that.
Nah,
Probably shouldn't do that because theta represents an angle, right? But I
Yeah.
just say it. You could call this lambda if you want. You could call this alpha. You could call this anything you want. You could call this Batman. Right? Just solve it as all they want. You need to apply. Right. So guys, if I say this, right? What is the longest length over here? What is the longest length?
X.
Right? So you'll say x squared, and that will be equal to the sum of the other sides squared. So Dari, this is the longest side here, right? So what are the other sides? Tell me, Dari, what are the other sides?
Like for 8 and 9.
8 and 9, right? They are the other sides.
Yeah.
I would say 9 squared plus 8 squared. Guys, does it matter if I say 9 squared plus 8 squared? Does it matter if I write it as 8 squared plus 9 squared? Does it matter?
No,
No.
because it's addition.
Right, because addition is commutative.
Yeah, commutative, yeah.
The order in which we add does not affect the final output. It does not. If you have real trust issues, watch this, right? Guys, where's 1 plus 2?
3.
3. Where's 2 plus 1?
3.
Exactly. The order doesn't matter. So if you said 8 squared plus 9 squared, if you said 9 squared plus 8 squared, that's fine. You're going to get the same result. Nah, I'll keep the mysterious for now. Right. So guys, so Dari, is it possible
That's
for you to simplify the right-hand side?
Yeah, you could. Yeah.
What is 9 squared?
81.
What is 8 squared?
64.
What is 81 plus 64?
5. Hold on.
All right. I think that should be
145. 145.
45.
Yeah.
Do you all agree? Or not?
Yes.
Because
I
6
think
plus,
wait.
6 plus 8 is 14, 1 plus 4 is 5. So 145. Yeah.
Yeah, 145.
Right. So Dari, this is what x squared is equal to. Do you know what the opposite of squaring something is?
Yeah, to find the square roots. So
Exactly. So you find the
Yeah.
square roots on both sides.
mm-hmm.
A square root function is the inverse operation of squaring something. Just the opposite now. So if you find the square root of a squared term, you get rid of the square. So x would just be equal to the square root of 145. So what's the square root of 145, guys? You may answer the 2 decimal places. Our real trust is used here, so like I'm gonna pull up my own calculator. Let me get my own calculator.
I got 72 point.
I'm a calculator here. Locked and loaded.
Okay.
Let me make sure we get the same thing.
12.2.
12 is incorrect because 12 by 12 is 144. So I expect your answer to be
12.04.
12.04 is correct. Gary, you said you got
No check box. I know, guys.
all right. So 12.04. And I didn't give you any units, so you could just say 12.04 units. All right. That's like the basis of Pythagoras theorem. To do Pythagoras theorem, how much sides you need? How much
3.
sides?
I mean 2, sorry.
Two sides, right?
Yeah.
Yeah. I will go into everything a little more detail. I just want to give you a broad, like a general idea of what we'll have to cover, right? What we'll have to cover. Right. In trig ratios now. Oh, it's kind of bothering me. Yeah. Oh, so like this thing. All right, cool. Right?
Sir, I think my calculator confusing me. I have to, I don't know what to do because I'm not getting the answer at all.
Which calculator you have?
I'll send you a picture.
The Sunway? The cost too?
I think so, yeah.
All right, so Perseus, we're gonna do, right? You following the exact, your calculator, what you have is the exact same thing what I have. Exact same thing as what I have here. So you are going to press the square root button. Square root button. I'm pressing it here. Seen it?
Yes, sir.
Press that. You press
I
it?
did. Yes, sir.
Press 145 now. Press equal now.
Yeah, it just showing up as that.
Press S to D. S to D.
S.
I'm pressing it over here constantly.
Oh, okay, sir. I now see it.
Nice.
That's how you get the answer.
Yeah.
Thank you, sir.
That's our problem. Now, like the Casio just give you the exact answer. So, like to get the S to get the decimal, you press S to D. Right. So let's run through trig ratios now, right? So, guys, how much trig ratios are there? Does anybody know?
3.
3 to
Right? And if you have a hard time remembering it,
SOH.
Socatoa.
yeah,
Yeah, Socatoa.
right? Socatoa. So this one represents sine. So sine theta, where theta is the angle, is just the ratio between the opposite and the hypotenuse,
Hypotenuse.
right? Cos now. Cos theta is going to just be the adjacent all over the hypotenuse, right? And we have tan here. Tan theta is going to be opposite over adjacent, right?
Mhm.
By the way, we have any ADMA students in class here with us? Yeah. We have any ADMA students by chance?
Me, sir.
What you said, Arias? I don't know if you know this, but tan is the same thing as sine over cos. Did you know that?
No, sir.
What you said? What you are getting at? Sine theta, right, is O over H, yeah? Yeah?
Right,
And
right,
cos theta is A over H, yeah?
right.
Guys, if I divide in a fraction, if you divide a fraction and you change it to multiply, what if we're going to put the fraction? When you go from division to multiplication, what happens with the fraction?
You sort of flip it.
Flips.
Is
Right, so I would flip this. I would flip that out into H over A. We're going to put the H's.
right. You would cancel
Cross
out.
They
multiply.
cancel.
And cross multiply cancel off. Right? And you're going to up it over A. Look at our magic. Look at our magic.
Okay.
Yeah, the more you know. That's why tan theta is. So the person that said cross multiply, right? We only do cross multiplication if you have a fraction on the other side, like an equal sign. Like if you had x over 9 is equal to 1 over 2, yeah, you can cross multiply because you have two fractions on either end of an equal sign. But over here, we're multiplying. There's no equal sign over here. So you're just going to cross multiply. I say cross. You're going to cancel it off, right? Watch. H into H is 1. H into H is 1. Right. Just over A. This was just to cater for these people that really like maths. Yeah, the more you know. Right. So sine theta is O over H, cos theta is A over H, tan theta is O over E. Now, who here has a hard time figuring out which one to use? Tell me, be honest with me. Who here has a hard time figuring out which one to pick? Don't feel shame, tell me.
Me too, sometimes.
All right, so Aaron, I want you to stay unmuted, right?
Mm-hmm.
Mahak, this is Mahak, right? First, you have to label your triangle. Label your triangle. That's the first thing I want you to do, label your triangle. The next thing I want you to do is, I want you to figure out what you have. What do you have? So I want you to underline that, what you have. So underline this for me. And then I want you to select what you are trying to find. What do we need to find for? This is it. This is it. Like this is gold. So this is gold. And this is gold on paper. Hear what I'm saying, right? You're going to underline where you have, right? If you have a length, underline that. Then you're going to underline what you're trying to find for. That will tell you which trig ratio to use. Promise. I promise. So Aaron, you probably want to see it in a question, right? So
Yeah,
let's
sir.
do a question. So, and you would use trig ratios when you have a non-90 degree angle, right? And you have one side or more. That's when you would use the trig ratios. Right? So essentially, guys, essentially, you'll use the trig ratio once you don't have two sides. If you have two sides, Pythagoras theorem is the dog. If not, trig ratios. And to use trig ratios, it must have an angle other than 90 degrees. Otherwise, it wouldn't work. So Aaron, let's look at a question quickly. So Aaron, let's just say I want you to find the length. Find the length OD. By the way, Ariana, you in class? Whenever Ariana, so okay. Ariana, you there? Ariana, let me know if you're here or not. And I think Ariana's sleeping. Yeah.
She might be.
That Boxing Day food is hit different, you know. After Boxing Day, people are just sleeping. Right? So Aaron, I'm gonna call this OCD. Right? I'm going to give you an angle over here. I'm gonna call this angle 37 degrees. So first things first, Aaron, do you know how to label your triangle?
Yeah, sir, I remember from your previous videos how you were saying to do that. So I think I know how to label it.
All right. So let me go it over, right? First things first. This length is opposite the right angle, so we call this the what?
Hypotenuse.
Right. This is definitely the hypotenuse, H. Right? This length is right next to the angle. If it's right next to the angle, what do you call it?
The adjacent.
Right? And lastly, this side is opposite the 37. So opposite. So I want you to tell me what length we need to find for here. Tell me what length do we need to find for here? Find the length of what?
OD.
Right. OD corresponds to what? OH or A?
Now what you said, sir?
A.
What does O to D correspond to?
The adjacent.
Adjacent, right? So here what we're going to do, right? Automatically, I'm going to underline E. Right? Then I'm going to underline the length that I have. What is the length that I have? Which length do I have?
O.
Aaron, can you see that we have the length for O?
Yeah.
So here it is. This is a hack. Which trig ratio has O and A in it?
Tan.
Exactly. You see, you will never guess in your life. You will never guess again. You have it now, right? So you're going to use tan theta immediately. So tan theta is going to be O over A. That's it. That's literally it. So, Aaron, what is the angle we're dealing with?
37.
So you're going to say tan 37 degrees, and that's going to be equal to the opposite. What is the opposite?
9.
9. What is the adjacent?
Well, A because OD.
I could call it OD, right?
Mm-hmm.
I want you to think of tan 37 as tan 37 over 1. And for those of you that may get confused by this, let me explain something. Guys, would you say that 5 is equal to 5 over 1?
Yes, sir.
Yeah. Larry, you there?
Yes, sir.
Larry, how much times 1 could go into 5?
5.
Okay, how much times, let me just say I have a number like 107. How much times 1 could go into 107?
107 times.
Yeah, so 107 times. 107.
Yeah.
Right? So the general rule is n over 1 is just equal to n. If you divide something by 1, you're just going to get back n, or whatever number it was in the numerator. So if I write tan to the 7 over 1, I'm not changing anything. I'm just setting it up for cross multiplication. Is anybody confused by this?
No, sir.
No, sir.
All right, so you see, I have two fractions on either side. So now I'm going to do cross multiplication. When we're doing cross multiplication, we're going to multiply diagonally. Now, guys, what is the unknown here?
OD.
OD, guys. Is tan to the 7 an unknown? Is that a constant or a variable? What would you all say? Let me hear. When I say constant, I'm talking about a number. If I say variable, I'm talking about something that we don't know. Or something that could change. So somebody in class, tell me, is tan to the 7 a number or is it a variable?
A variable.
A variable.
Okay, check this out. If I put tan to the 7 in my calculator, what am I going to get?
0.753.
So is that a variable or a
0.75.
number? Yeah, tan to the 7 is a number.
Okay.
A lot of students, don't let the letters confuse you, right? Tan, if you put trait in a calculator, it's exactly what Yvonne said. They take a trait into a calculator and get a number, right? Is a number. Yeah. If you calculate into a calculator, then chances are it's a variable. But if you have a Casio, you could, right? You could, because Casio is bad like that. Watch, alpha, close bracket, x. Yeah. But anywho, if you didn't know, now you know, right? Tan to the 7,
Yeah.
that is a number. That is a number. That is 0.7 something. Right?
Yes, sir, I get that.
Okay, cool.
Yeah.
So now we actually do the working, right? So we want to find for OD. So I'm going to do that multiplication first so that it works out to be on the left-hand side. So I'm going to multiply these first. So it's going to work out to be OD, right, multiplied by tan to the 7. Right? And that is going to be equal to 1 by 9. What is 1 by 9, guys?
9.
9. So, guys, what do we want to find for over here?
We want to find what OD is, sir.
OD. So right now, OD is being multiplied by what?
Tan to the 7.
What's the opposite of multiplying by tan to the 7?
Dividing by tan to the 7.
Right, exactly. Dividing by tan to the 7. And if you do something on one side, guys, you add it on the
Other side.
exactly. Right, Perseus, your mind is going to be blown. I'm going to show you how to use the calculator, don't worry. So the tan to the 7 into tan to the 7 is 1. 1 by OD is just OD, right? So OD is going to be equal to 9 over tan to the 7. So Perseus, you there? Perseus?
Yes, sir, sorry.
So Perseus, that's what you're going to do, right? You're going to press 9. You press 9,
Yeah.
and they're going to press the fraction button. That. It will, on your calculator, it will look like this.
Yes, sir.
Did the fraction pop up?
Yes, sir.
Now you're going to press tan. Press tan. It's right next to cos.
Yeah.
Then you're going to put 37, close bracket, press equal.
11.943, sir.
Right.
Yes, sir.
Perseus, imagine if you had a sharp.
Nah, sir.
You'd have to put 9 divided. Okay, that would not be hard. That would be easy, actually. It'd just be
Yes,
9
sir,
tan to the 7.
I
Right?
get
But if,
the sharp. Yeah.
that's good. If it was multiple terms, would that be a little upsetting? Right? But it was just one thing in the numerator and one thing in the denominator.
I
So yeah,
prefer this. Yes, sir. Thank you for the.
no problem. Saving lives. Casio saving lives. Right?
Sir, you have to be the brand ambassador for them or something.
I feel so.
I'm right true.
One day when I become an international educator, Sure. They will see now. They will finally see now. Right? So yeah, guys, you're supposed to get 11.94, right? I specified units here, so it's be centimeters. Is there anybody that's confused by this? Specifically the process. Was there anybody that was confused on how to label? Tell me.
No.
Guys, don't be scared. Tell me. Did he label it?
Answer.
No, sir. I remember you doing it in class and you showed me the facts. Say
Okay.
comment.
All right, Celine, you okay? Celine, let me know if you hear now.
Yes, sir.
Celine, this is easy stuff for you, a hard for you. Be
No,
honest.
no, it's easy, it's easy.
All right. So, guys, again, how do you know which two to pick? To know, you are going to look at what you have. In this case, we had 9. That corresponded to O. So I have O. And then you're going to select what you don't have. What you're trying to find for. We're trying to find for OD. That corresponded to A. So O and A, tan. That's it. Is there anybody that doesn't understand this for the life of them? At all, at all, at all?
No, sir.
No, sir.
I understand, sir.
The next thing you'll be required to do is find an angle. Right? So I'm being very vague here, right? I just showing all the general things you need to know. I'll go into it in more detail shortly. Right? So find the angle ABC. So I'm gonna be a little wicked here. Change up the look at things. Right? Ain't too wicked. Yeah, don't worry, guys. I'm not that wicked. No, no, no. Right. And let me just say I gave you this as 10 centimeters, and I gave you this as 7 centimeters. Okay. First things first, guys, we need to label, right? We need to label our diagram. So this is going to be a little different from this example, right? It's a little different because in this example, we found our length. In this example, we're going to find an angle. So, Dari, let's label accordingly, right? So, Dari,
Yes, sir.
you there?
Yes, sir.
First things first, they want me to find for which angle.
ABC.
Right.
Mm-hmm.
Let me show you how we'll
So,
figure out what angle that is, right? So you're going to start from A, you're going to go to B, then you're going to go to C. The
right.
angle look like it's where? Where does the angle look like it is at? It is at what? Try again, right? Where does it look like it's at?
C.
C? No. Again,
Mm-hmm.
an angle is formed between two lines.
So
Formed
B.
B, right? Watch.
Yeah.
Because I have line AB here and I have line
No.
C over here. It's formed in
Yeah.
the middle, right? And a way that a lot of students remember it, just look at the angle in the middle. Look at B, right? So
Mm-hmm.
B. So Gary, that's my first step. I'm going to put down the angle they want us to find. We need to figure this out. Right?
Hypotenuse is already 10 because it's far from. Mm-hmm.
Right? It's opposite the right angle, sure.
Yeah.
What would I call this side? If this is my angle over here, what would I call that side? What do you call the side that's right next to your angle?
Adjacent.
Yeah. Adjacent means right next to. And what would I call this side here?
Tan.
What I call it?
Tan.
No.
Cos, my bad. Cos.
No. You're using wrong terms. Yeah, wrong terms. You're talking about the trig functions. I'm talking about sides. So the three sides are adjacent, hypotenuse, and opposite.
That's it.
So I'll label E, I'll label H. Now I need to label O.
Oh, yeah.
Let me explain why. This side is what to the angle? Is what to the angle? This side is what to the angle?
Mm, cos.
Call it opposite for a reason. Think. That side is what to the angle.
Cos.
Say that again.
It's opposite the angle, sir.
Yeah. So Dari, this side is opposite the angle. So that's
Mm-hmm.
the opposites because it's opposite the angle.
Yeah.
So guys, this is going to be slightly different, but I would implore you to look at the information we have. That is going to tell us the answer. What lengths do we have for?
We have the hypotenuse and the adjacent, sir.
Right. We have the hypotenuse and the adjacent. Which trig ratio has E and H in it?
Ka, sir.
Right, Ka. So that's going to be cos theta is equal to,
7/10, sir.
right? Let's take the time. So A over H, right? So cos theta, right? And if you want to be very specific, you can say open bracket ABC, and that would be equal to E. Now A is 7, right? And H is 10. Guys, if you want to find for the angle, you'll need to apply the opposite function of cos. What is the opposite function of cos called?
Inverse.
Right, cos inverse. So angle ABC, right? Angle ABC is just going to be cos inverse of 7/10. So Perseus, if you want to get cos inverse, right, you are going to press second. You're going to press shift cos. Shift cos. Perseus, you get cos inverse?
Give me 1 second, sir.
I got it, sir.
It's like it do not want to come up like this calculator don't like me, sir.
Nah, don't say that, right? This is cos. I real click in it. You see
Okay,
it?
so I get it now. Yeah, I get it.
Right, press shift cos. You should see cos minus 1 pop up. Then
Yes,
you're
sir.
going to press the fraction button.
Then
Then you're going to press 7. You see what I see in Perseus?
yes, sir.
Then you're going to press the arrow to the right. That should send it to the bottom. Then you're going to press 10. Then you're going to press the arrow to your right again to come out, close the bracket, and you should get 45.57.
Yes, sir.
Are you all getting that?
Yes,
Yes,
I got
sir.
that.
Yeah.
Right. So the answer is 45.57 degrees, right? Degrees. So we're finding an angle. So guys, generally speaking, right? Generally speaking, under 90-degree angle triangles, you will need to know Pythagoras theorem. You will need to know that hypotenuse squared is equal to just the sum of the other sides squared. Sometimes you'll have to do some algebraic manipulation to make whatever you want subject of the formula. But just putting it out there. Not all the time, you're going to be finding for the hypotenuse. Not all the time. Not all the time. Sometimes you might want to find for B. Sometimes you might want to find for C. Under trig ratios, you will need to know sine, cos, and tangent. And you'll need to know which two to pick. So the hack is, you're going to select where you have. And then you're going to select where you need to find. That will tell you the two you need to pick. Right? So in this example, we had O, I select that. We wanted to find for A, I select that. So the one that has A and O in it is tan. So I selected tan. Everybody okay with what I'm saying so far?
Mm-hmm.
Yes, sir.
And for this particular case, we wanted to find the angle. Now, if you want to find the angle, you need to apply sine inverse, cos inverse, or tan inverse, right? And you need two lengths to figure out the angle. And you're going to select the two lengths and look at what they are. In this case, the two lengths were A and H. A and H. So that corresponds to cos. So cos theta is A over H. So we ended up with angle B is equal to cos inverse, right? The adjacent, which was 7, all over the hypotenuse, which was 10. And we got 55.57 degrees. Are you all okay with the example so far?
Yes, sir.
All right. And let me just give a little crash course on bearings. But before I do that, we should probably look at non-90-degree angle triangles first. Right. So under non-90-degree angle triangles, you need to be able to know two theorems.
Look, I took the last Punhara last night.
You need to be able to know cosine rule. Cosine rule is nice.
Yeah, 8
What?
hours.
Or somebody Mike,
Aaron Michael.
Aaron, you
I
might
feel sick. I was feeling hungry, but not now. Yeah.
yeah, I feel hungry for that one in maths.
My God.
I feel hungry for that one in maths.
Bearings is part of geometry or trigs.
Trigonometry. So, but you see, the thing is, right? When you're doing bearings, you need to know the cosine rule and the sine rule. So that's why I showed you guys that first. Then I'll give you all a crash course on bearings. Yeah.
Okay. Yeah.
All right. So the cosine rule. The cosine rule is just a fancy version of the Pythagoras theorem, a more generalized form. So you use the cosine rule anytime you have an included angle. Do you all know what an included angle is? Be honest with me. Do you know what's an included angle? I don't think so. So adjacent sides are given. So let me give you an example, right? Let's just say I had this angle over here, right? Call this 49. Guys, so I'm saying that an included angle is an angle whose adjacent sides are given. Now, adjacent just means right next to the angle, right? Right next to the angle. Are both of the lengths given for this angle? Yes or no? Come on,
Yes.
guys. Yes. So if I have this situation, I could use cosine rule to actually figure out for this side. So you're looking for included angle. So this is an included angle, right? What about if I had this situation over here? Right? I want you all to tell me if this would be considered an included angle. So I'm going to call this 46 degrees. I'm going to call this 6 centimeters. So I want you all to tell me, does this look like an included angle? Yes or no?
No.
No, sir.
No.
Because I don't know what this length is. I cannot use the cosine rule to figure out for the opposite side. I can't. Right? So this is unknown. This is unknown. This is unknown. One more example. I'm just gonna stay quiet and hear how much people say yes or no. Right, I will just call this angle here 60 degrees. A, B, C. I'm gonna call this length here 9 centimeters, and I'm gonna call this 8 centimeters. No, it had to be longer. Probably like 7 centimeters. Who here thinks angle B is an included angle?
Nah.
No.
How about the rest of you guys in class?
No, sir. No.
What angle do you think is the included angle in this diagram?
A.
A, yes. Angle B is not an included angle because you don't know what this length is,
Yeah.
right? So you would say angle B is not an included angle. Right, so angle B is not an included angle, so no. But guys, if I were to put an angle E, would we say that angle E is an included angle? Yes or no?
Yes.
Yes.
Yeah. But question, guys, I have a question, right? Let me real throw it into the ocean now. Let me just say I told you that this was an isosceles triangle, right? I gave you this length over here, but I didn't give you this length. Would angle B be an included angle now?
You could
Yeah.
repeat that?
So I'm saying, what if I said that this triangle is an isosceles triangle? Would that make this angle an included angle now?
Yeah,
Yes,
because
sir.
isosceles means all sides are equal.
All sides are equal, so yeah.
No, hold up, wait a
No,
minute.
two sides are equal.
Equal two sides.
Pause. No, two sides are equal because an isosceles triangle, right? Two sides.
Okay.
Yeah, not all three sides. But yeah, if I told you that this was an isosceles triangle, then you would know that this is 11. And you would be, what? 911? That's illegal.
What?
I not realize I do that. No, boy. Hey. Yeah, right. So guys, let me actually show you what the cosine rulers look like. And again, okay, does everybody understand what an included angle is?
Yes, sir.
Okay, right? You can only use the cosine rule if you have an included angle, right? And if you have two lengths. And you use it to figure out the side opposite the included angle. So let me give you all a question and cover it from start to finish. So let's just call this A, we'll call this B, and we'll call this C. So suppose we have an angle here, right? This angle, let me just say the angle is, guys, I attempted to say 6, but 6 something, but no, I'm not going to say that. I'm looking like 49 degrees. Let me just say I told you that this length here is 7 centimeters, and I told you that this was 5 centimeters, right? Tell me, guys, are we seeing an included angle?
Yes.
Yes, sir.
Which angle is included? Angle A, B, or C?
A.
A.
Do we have two lengths?
Yes.
Yeah.
Do we have, okay, we have two lengths. What's the only thing we're missing? Well, figure out what the angles are. What side are we missing?
BC
Right, and
BC.
that side is opposite the
angle.
included angle, yeah? First things first, when you move away from right angle triangles, you need to know the naming convention. So we use capital letters to represent angles, and we use common letters to represent lengths. So if this is angle A, the opposite side would be length common A. If this is angle B, opposite side is going to be what?
Common B.
Common B.
Right? If this is angle C, the opposite side is going to be
Common C.
common C. Now, I'm going to write a very general formula for the cosine rule. The cosine rule says the opposite side squared is equal to the, let's write down, A squared is equal to, right? B squared plus C squared minus 2BC cosine A. Right, so it's the opposite side squared equals to the others, is equal to the adjacent side. So adjacent side squared plus the other adjacent side squared, right? Minus 2. You're going to multiply the adjacent sides. Right? And then you're going to multiply that by the cosine of the included angle. Right. So guys, let's understand this long thing I wrote. I wrote it like this because I want you all to be able to come up with a specific formula for the question you're dealing with. So guys, in this particular question, which length do we want to find for? A, B, or C? Common A, common B, or common C?
Common A.
Common A. So my formula is going to be A squared, right? I wrote opposite side because I'm talking about the side that is directly opposite the included angle. And that's going to be equal to the adjacent side squared. Guys, when I say adjacent, I mean right next to the angle. So could you all give me an example of our adjacent side? Is it A, B, or C?
B and C.
Right, so I'm going to say A squared is equal to B squared plus what?
C squared.
Right? And then you're going to minus 2. You're going to multiply the adjacent sides. So my adjacent sides are B and C. So I'm going to say minus 2BC. Right? And I'm going to multiply that by the cosine of the included angle. What's the included angle in this question?
49.
Right? Angle A, right? Some of you understand this.
Oh, yeah.
Okay. Let me run it back one more time. Guys, were you able to successfully label the sides? Yes or no?
Yeah.
Yeah.
The next thing from here, the formula goes like this. It's the opposite side squared equal to the adjacent side squared plus the other adjacent side squared minus 2 by the adjacent side cosine of the included angle. Now you probably notice our pattern, right? Guys, watch this. We start off with common A and we end off with
Capital A.
right. Everything else in the middle is B and C. Right? And B and C, they are the what? The what sides? What are B and C?
Adjacent sides.
Right. They are the sides that are right next to the included angle.
Oh.
Right. That's why I say adjacent side, because the next to, adjacent means right next to. Okay. So guys, now we're going to substitute. So A squared is going to be equal to B. What's B? Somebody tell me, what is B?
5 centimeters.
So 5 squared plus 7 squared, right? Minus 2. What is B?
5.
Right? C is?
7.
Right? The included angle is?
49 degrees.
Right. So if you're very skillful with using a calculator, you could actually get your answer right here. All you would have to do is you'd have to find the square root of this entire thing. So I'll show you guys how to do that. So your answer is just going to be equal to the square root of this entire thing. Guys, why am I finding the square root? Can anybody tell me? Why am I finding the square root? Why would I do that?
Because you have to do the opposites, and the opposite of squared is the square root.
Exactly. I think everybody could see that we're squaring A. So to find for A, we would have square rooted both sides. Now, if I square root a squared term, we get rid of the square term. We get rid of the square root and the square. So we just end up with A. So A is equal to this entire thing. So those with a Casio, don't worry, sharp users. I will show you all how to get the answer shortly, right? If you have a Casio, right? So Priscilla, is it?
Yes, sir.
Right, so Priscilla, I want you to press the square root button. Right? Press it.
Yes, sir.
Then you're going to press 5. You see that x to the power 2 button? Press that. X squared. Press that. We're on the same page?
Yes, sir.
Then you're going to press plus 7. Press the x squared button again. Right? And you're going to press minus 2. Open bracket. 5. Close bracket. Open bracket. 7. Close bracket. So you see with me?
Yes, sir.
Then you're going to press cos. And in brackets, you're going to put 49, close bracket. Press equal and let me know what you get.
5.29.
Yes, imagine if you had a sharp now. Oh God, imagine that. Leave. You don't
So
catch it.
it was
Still
a
to the
matter
water.
of walk. So it was a lot of walking around to get this calculator, you know.
It's worth it, it's worth it.
Very much worth it.
Sharp users, don't worry. I'll show you how to find the full answer. And you can also work it in parts if you'd like. Right? But I like to find the full answer one time to avoid rounding off errors.
So do we have to round it off to the
Two
oh my God.
decimals. Two
So
decimals.
that's
What is the second decimal place here?
9.
What's the number after 9?
To be 1 or after 2. No, it will be 1.
It'd be 8. 8.
8? Or after
2, 9,
7
8.
before. Sorry, sir.
Right? So after 9 is 8. Right? So you get, since 8 is 5 or more, you're going to add 1 to 9. That's going to turn to 10. Then you're going to add that 1 to 2. So 5 points?
5.30.
Right. People with a Casio or people who know how to use it sharp, did you all get 5.30? Yes or no?
Yeah, I did.
All right. Now, if you have a sharp, let me show you how you would handle this, right? There are multiple ways you can handle this, but let me show you what you're going to do. If you have a sharp, you have to plug it in like this. So press the square button, then open bracket, 5 squared plus 7 squared minus 2, open bracket, 5, close bracket, open bracket, 7, close bracket, cos 49 degrees. And you're going to close our bracket off. So everything here in red is what you're actually putting into the square root function. And I'm putting those two brackets on either side to make sure my calculator finds the square root of the entire thing. So somebody with a sharp, I want you to plug this in and verify that you're getting 5.30. Somebody with a sharp, just verify this for me.
Yes, sir, I get our answer.
Okay, nice. All right. So guys, I think I would like to do another example for the cosine rule. Did you all understand this particular example?
Yes, sir.
If you didn't, that's okay. I'm going to run it back again.
Still I got you, right?
You got through?
I'll get you, yeah.
You will get through, you got through.
No, I got you.
All right. So guys, number 1 rule. For you to use the cosine rule, you must have a what?
Included angle.
Right. Next step, you're going to label the sides. Now, in this situation, by the way, I want to show you something. People are like maths. Isn't the Pythagoras theorem a squared is equal to b squared plus c squared? Yeah?
Yes, sir.
Watch this, right? The cosine rule is the Pythagoras theorem, but generalized for any triangle. If you wanted, you could have used this for a right angle triangle if you wanted to get the correct answer. This is just a general form of Pythagoras theorem. Okay. So yeah, guys. Once you label your sides, you remember, if you use any cosine rule, you are finding for the side opposite the included angle. So you're going to start off by putting that side squared. Then it's going to be equal to the sum of the adjacent sides squared minus 2 by the product of the adjacent sides cosine of the included angle. And that's the general format. So guys, make sure you have this copy down, take a screenshot or something, and I'm going to do another question. And then I'm going to show you all sine rule. And then I'm going to look at bearings. All right. As soon as you are ready to move on to another example, tell me. Tell me, guys, as soon as you're ready to move on, tell me.
You can move on.
On?
Yes, sir.
So you. All right. I'm going to draw a crazy looking triangle. Call this C, call this D, call this E. Right? Let me just say that this angle here is 79. Guys, would I be able to use cosine rule for this question? Yes or no? Somebody tell me, would I be able to use the cosine rule for this question? And if so, tell me the included angle. If not, tell me why is not included angle.
Yeah, I think you won't be able to use it.
All right. How much more people agree with her? Darius.
I think you could use it.
Now, guys, remember, an included angle is an angle with two known sides. So right next to the angle, you're supposed to know the lengths. Can I say that angle C is an included angle?
No, sir.
No, sir.
No, because watch. Do we have this length over here?
No,
No,
sir.
sir.
No, so it's not included angle. If this was the case, you'd have had to use sine rule, right? I'm gonna just shift it over here now. Is it an included angle now?
Yeah, sir.
Yeah. So guys, let's label our triangle accordingly, right? If this is angle C, what would this side be called?
Comma, length C, sir.
Right? If this is angle E, what would I call this side?
Length E, sir.
If this is angle D, what am I going to call this side?
Length D.
Great. Now, guys, what is the side here opposite to the included angle?
C, sir.
C. So which side are we trying to find for in this question?
C, sir.
Right, so I'm going to start all the way off, right? So it's going to be C squared is equal to what?
E squared plus D
D
squared
plus D squared.
minus 2 ED 79, sir.
Okay, guys, was it that hard to figure out the formula?
No, sir.
Or let's say the pattern, right? Watch. It's always the opposite side, and you're gonna end off with the included angle, and everything in the middle is just the adjacent sides. Right? So from here, you're just gonna substitute, right? You're just gonna substitute. So tell me, guys, what is E? What is E? What is E?
E is 8 centimeters.
Right? Or what is D?
3 centimeters, sir.
Right? What is E?
8, sir.
What is D?
3, sir.
Right? And the angle. What is the included angle?
79, sir.
All right. We have C squared. What we want to find for C, what will we have to apply on both sides?
The square root, sir.
If I find the square root of C squared, what will I be left with?
Just regular C, sir.
Right. And on the other side, I will have the square root of this entire thing. So guys, plug it into your calculator and let me know what you get. Somebody answer the two decimal places. Hey guys, so Priscilla, I want to hear your answer, right?
Okay, so I got 7.99.
What about the rest of you guys? Did you all get that?
Yes, sir.
Yeah, sir.
Okay, let me verify that.
Yes, sir.
But you know the truth 6 uses round deep. 8 squared plus 3 squared minus 2 by 8 by 3 cos 79. Yeah. Hey, big up on yourself. All right. Big up on yourself, boy. Big up on yourself. Huh? Hmm? No, yeah. 6. 6:13. Okay. All right, guys. I might come back home 10 o'clock. 10 o'clock. All right. I'll grinding, right? Let me just get something straight, right? If you're in this class, chances are you want to grind and get a 2 or a 1 end. Yeah?
Yeah,
Yes or no?
sir.
Right.
Of course. Nice distinction on my answer.
Right. So I need a little to know that if I want to achieve great things, yeah, well, it's not gonna be easy. Just put it out there. So if you want to accomplish great things, you need to be willing to sacrifice and do as much as you could do. So I come in a little late, right? If I still need help, let me know, right? Let me know. I just saying you will be willing to need. I'm saying you must be willing to do endless amounts of work. Obviously, you need some rest, right? But from now until the exam, you can't be slacking. So if I come home a little late and anybody wants help, let me know, right? We'll try to figure this thing out together.
I can help you too.
Okay, since you could help me out, right? I want you to round up 7.99 to two decimal places, man. What's your second decimal place there?
99.
Okay, look, she get 9. What's your number after 9?
Like 9?
I mean, like, after 9, like, in this direction. Yes, in this direction.
Oh, 0.
0. So 0 is less than 5. So you round down.
Yeah.
So everything after the 9 is just going to drop.
Yeah.
Yeah. So 7.99, right? And what are my units? What are my units, guys?
Centimeters.
Centimeters.
Okay, so does everybody understand the cosine rule?
Yes, sir.
Yes, sir.
Okay, good. Good. So the only thing you need to know now is the sine rule, and we pretty much covered everything in trigonometry. The only thing we have to look at is bearings, which I will try to briefly summarize. But guys, once you understand the concept of bearings, is you just have to apply sine rule or cosine rule or Pythagoras theorem or trig ratios, right? Okay, let's look at the sine rule now. So guys, if I said you use the cosine rule when you have an included angle, when do you think you're going to use the sine rule?
When you do have an included angle.
I like you. Yes, yes. When you don't have an included angle, right? That's the number one reason. When you don't have an included angle. By the way, let me show you how cool maths is, yeah? And check this. Wait, that was this. I actually used the cosine rule. So my girlfriend sent me this picture, and she was like, "Hey, I dare to find the angle between this." Well, you know what? I did. using C-sec maths. This is not a hard maths, and it's C-sec maths. Yeah. Right? 26.19. Maths is very cool. But anyways, when you don't have an included angle, so let me give a little example, right? Let me just say we have this triangle. They call this E, call this B, call this C. Let's just say the angle over here is probably 59. And I tell you that this length is 9 centimeters. And I tell you that this length is like 7 centimeters. Right? Guys, in this triangle, are you seeing an included angle? Yes or no? Yes or no?
Mhm.
Tell me, guys, are you all seeing an included angle? Remember, an
No.
included angle is an angle that has two known sides, right? For 59 degrees to be an included angle, you will need this length over here, and you just simply don't have it. So you'll have to use the sine rule, right? So let me show you how the sine rules work. First, let's label our sides. If this is angle A, what would this side be?
Come on, A.
Right? If this is angle B, where do you think this side will be?
Come on, B.
If this is angle C, where do you think this side going to be?
Come on, C.
Right, come on, see. So the sine rule looks like this. It's A all over sine A. So I think you see why we just call it the sine rule, because it's just sine. So A over sine A is equal to B over sine B, right? Is equal to C all over sine C. Guys, what was the hack I showed you all to figure out which two to select from trig ratios? What was the hack again? Aaron, remind me. How did you know which two to select when doing Pythagoras theorem? Is the same hack over here? Selma, Aaron.
So you have to label your triangle,
Mhm.
look at what you have, and then look what you need to find.
Right. So let me show you how we can apply that over here. So the hack here is look for a pair of information. Look for a pair of information. When I say a pair, I'm talking about an angle and its corresponding side. So look for a pair of information. That's one thing you need to look at. The other thing you need to look at is look at what you are finding for. Finding for. So guys, let's just say I wanted to figure out what angle B is. Let's just say I wanted to figure out what angle B is. So guys, according to my hints, out of the three, which two am I going to select? You need to pick two out of the three. Guys, are you all seeing
Yeah.
information? A pair of information. So an angle and its corresponding length. Are you all seeing a pair of information?
Yeah. A.
E. Guys, and everybody can see that we have angle E and we have length A. Are you seeing that?
Yeah.
Yeah. So I'm going to select A over sine A one time. We're not going to stick. What am I trying to find in this question? Where do I have the question mark by?
By B.
Right. So
By
which one?
sine B, sir.
So which one do I need to select? B over sine B or C over sine C?
B over
B
sine
over
B.
sine B, sir.
Right. So Aaron, you see what I tell you, right? It's the exact same kind of concept as with Pythagoras. So you're looking for where you have, in this case, we have A, and then you're looking for where you want to find. So Aaron, you understand the hint?
Yeah, sir.
All right. Nice. So I probably do this on another page. Yeah, guys. So let's actually apply this hint now. So if you apply the hint, tell me, Aaron, what's the formula you're gonna end up with?
It'll be 7.
Wait, maybe A over sine A is equal to B over sine B, and you go forget about the C.
Yeah. So
Right, so now you substitute.
it'll be 7 over 59 degrees, or sine 59, sorry, is equal to 9 over sine B.
So I have a question. Since you see in sine B, to find for angle B, more than likely you'll have to find sine what? What's the opposite of sine?
Sine
Cosine?
inverse.
Not cosine, sine inverse.
Oh,
The opposite function for sine is sine inverse. Right? So yeah, guys, tell me, do we have a fraction on either side?
Yeah.
Yeah. So they're gonna cross multiply. Now, guys, our unknown term is sine B. We want our unknown to be on what side? The left-hand side or the right-hand side?
the left-hand side, so
Right. So that being said, I am going to multiply this out over here first, right? So that it will be on the left-hand side. How much of you all think is going to be 7 sine B? And how much of you all think is going to be sine 7B?
I think it's gonna be 7 sine B. So
Yeah, I vote on this too. This will be wrong. Remember what I told you guys. Sine something is a term by itself, is a number. Right? So you can't go and mess with the inside. That's a whole term by itself. Sine B is a term by itself. So you're going to end up with 7 by sine B. And that's going to be equal to what? So then you're going to multiply this.
9 sine 59, so
Right, guys, remind me. Sine 59, do you think sine 59 is an unknown or a number?
A number.
a number.
Guys, because, and if you put sine 59 into your calculator, you get a number.
Yes.
And if you don't trust me, watch. 0.85 is a number.
You know, trust him, trust the calculator.
Exactly. If you don't trust me, trust the Casio, not the sharp. The sharp will lie to you in your face.
I don't know, sir. I don't know, sir. I've been using our shop for most of my life, and it has been helping me real good, sir.
Well, hear what. Since hear what, eh? Watch it.
I don't agree with Sharp at all.
Watch this. See this? See this, right? Let's see this, right?
Sir.
I make it through my whole secondary school life with this sharp, right? I borrow my sister Casio for the day at the unit 1, paper 1, pure math exam. And boy, ever since that, I figure out 90% of our people just using a calculator. Yeah, if you're doing higher level maths, try with the sharp on that. If you're doing engineering, you really don't want to use a sharp. You really don't. But for like regular maths, I suppose a sharp is fine, but getting a Casio or some other calculator like a Casio is ideal. Right? If you're shopping for a calculator, just look for the textbook display option, like the textbook display. Because guys, and when you're putting in a fraction in a sharp, you're gonna see this madness. Like if you want to put 9 over 8, and in the sharp, you're gonna see 9 or 8.
Yeah, so that's how I had to do it.
Yeah, but on a Casio, it actually showing up as 9 over 8. So yeah, the Casio is a lot more convenient. Makes your life a lot more simple. So yeah, guys, we need to find for sine B first, right? That's the first thing we need to do. So guys, if we want to find for B, right, you need to clear up the sine B. But if you look at the left-hand side and seeing sine B is being multiplied by 7.
Yeah, sir.
So you need to do the opposite and multiplying by 7 on both sides. In other words,
you need to divide by 7.
Right. You need to divide by 7 on both sides. So it's going to cancel off here. And that's going to leave me with sine B. Everybody with me so far?
Yeah, sir.
If you're not, tell me.
Don't be scared, we do bites.
Savannah's bite.
Yeah, expose me, but
I don't bite. That's a lie. That's a lie. As bite. Yeah, but anyways, guys, if you follow on mute and say vibes or something now. I don't like the vibes right now. It's sour.
Vibes.
Dry. Right. Okay. So guys, we at this juncture, right? Where we have sine B is equal to this. Now, those with a Casio, I would tell you to just find the answer one time. So to find for B, it's going to just be B is equal to sine inverse of this entire thing. Now, if you don't have a Casio, don't worry. It's not the end of the world. Right? I'll show you how to approach the question as well. So guys, people with a sharp, do you know how to store answers into a calculator?
No, sir.
No. Oh. Okay. Okay, here we can do right. Here what to do, right? I want people with a sharp. You're gonna press second function. Press second function sine. So let me know when you get sine in this. People with a sharp. Press.
Yeah.
All right. Then you're gonna open up a bracket, right? You're gonna open the bracket. Then you're gonna open up another bracket. And inside that open bracket, you're gonna put 9 sine open bracket 59 close bracket. And then you're gonna close the bracket again. Right? And then you're gonna press divided by open bracket 7, close bracket 7. You don't need to put this, eh? You don't need to put the brackets by the 7. It's just a safety precaution. And then you close the brackets. So let me explain what's happening over here, guys. The numerator is one separate thing by itself. So to show that, I'm putting 9 sine 59 in brackets to show that that is one term by itself. Then I'm dividing that by 7, which is another term by itself. So I put it in brackets. So people with a sharp, let me know what you get. And again, you don't have to put brackets by the 7. That's optional.
Again, error 2.
Yeah, again, I error too, sir. Well, my Casio.
Is that? People with a sharp, just try this. Try this on them on the way over there. Try this. People with a sharp, try this. Again, I don't use a sharp calculator. Trying to help what? Like try putting this into your sharp. And let me know where you get.
Still error.
No, I get answer.
Let me plug it into my
I
Casio.
got
Let me see why I
I
get it.
got 0. When
I will tell you. I get that. Oh, it would
Yeah,
seem
sir, tell me same thing
0.
for my Casio too.
it would seem that I came up with an invalid question, guys. My bad.
1 9.
Yeah, I come
I
up with
used
an
in sharp and I got
oh, see,
Yeah.
that was the end.
Yeah, I made this question in my head, but apparently I didn't do the maths properly in my head. So sorry about that. But the process is the same, right? The process is the same. Let me just change up the numbers to see if I could get something that makes sense. What if I change 59 to my second, right, guys? 60. So get error. What about 45? Okay, here we go do, right? Here we go do, right? Instead of using 59 in a calculation, use 45. It's illegal because it's invalid parameters. Like let me explain, right? How can I explain this? Basically, you know about dependent and dependent and independent variables. So let me explain this, right? This side over here is dependent on 45 degrees. Depending on how wide this angle opens up, that's going to control this length, right? And this angle is dependent on 9 centimeters. Now, depending on the parameters, you can't just put an angle over here, right? Because this angle affects this, and this angle will affect this. So you can't just put any angle over here, because if you do a construction, right, you will see the actual length. It's a bit hard to explain, but it has to do with the parameters. You can't just, when you're coming up with these questions, you can't just come up with any random thing, as you just would have seen. But change the angle to 45 degrees and let me know if you get 65.
Yeah, so I got 65.386.
Same, sir.
Okay, cool. People with a sharp? People with a sharp, let me know if you guys got a correct answer. Hey guys, let me know.
Yes, I get the correct answer.
Yeah.
Okay, weird. So B would be 65.39. 65.39, right? And that would be in degrees, right? Because we just found an angle. Let me know how you feel about the sine rule.
Illegal, illegal.
Yeah, how
Yeah, so I think I'm okay with it.
it looking illegal, or they understand what we had to do?
I mean, it looking hard, but I think now I know what to do with it.
So let me run through the general procedure, right? If you don't have an included angle, we have to do one time. So
Sine rule.
Exactly, sine rule. Sine rule is just the length all over the sine of the angle, right? For all 3 sides. The next step, you need to figure out which two you're going to select. You're looking for a pair of information. The pair here was A. We had angle A and we had length A. So do you all understand why I selected A over sine
Yes, sir.
A? All right, the next thing you're looking for is which one contains the variable you're after. We are after variable B. We need to find for angle B. Which one has B in it? C over sine C or B over sine B?
B over sine B.
Right, so that's how I'm going to know which two to select. Right? Is everybody okay with that part?
Yes, sir.
Okay.
Yes, sir.
Next thing, you substitute. So A is 7, right? Angle A, I'm supposed to change that over here. It's 45. Right? A is 45, B is 9, and I don't know what the angle is, so I leave that as capital B. Is everybody okay up to this point? Yeah or no?
Yeah.
Yes,
Yeah?
sir.
Okay.
Yeah.
Then we are going to cross multiply. We have a fraction on this side and we have a fraction on this side. When you are multiplying trigs, you take the number or what you're multiplying by and you put it in front, not on the inside. That would be very illegal. Right? So as you would have seen, we multiply diagonally. So 7 by sine B. 7 sine B. Did you all understand how I got this? Yes or no? Let me know, guys. Do you all understand?
Yeah. Yes.
And then the next one was sine 45 by 9. Again, I am not going to say sine 45 by 9. If you do that, that's very illegal. Don't do that. You're going to multiply sine 45, which is a number, by 9. 9 sine 45. To find for B, you first need to figure out what sine B is. So you would have to clear up the 7. Get rid of that. Sine B is being multiplied by 7. What is the opposite of multiply, guys? Opposite of multiply.
Divide.
Right, so we divide by 7 on both sides. The 7 and the 7 cancel off. So that leaves us with sine. Now from this point, if you want to find for B, you need to apply the inverse of sine. Confused already, or like I'm gonna follow you understand?
Understand?
Right? And that will give you the answer. Yeah.
I think my point is like say algebra. I don't think last time that we can sign me multiple. So I yeah, same. So you just write and same. You will fraction.
I'm gonna blow your mind.
It's simple.
Yeah, yeah.
It's simple.
Guys, so watch. So if I was saying you're saying to divide by sine, right? Okay, watch this, right, guys? Watch this. So like anybody here who had maths? Darius, he's who had maths, right? And even if it did, even if you're not doing hard maths, sometimes they bring indices questions in regular maths, right? That require you to know what I'm about to show you. So let me just say you had 1/5. Could all of us agree that that means you're dividing 1 by 5? Yes or no?
Yeah.
Yeah, and we can see that we divided 1 by 5. Seeing that. What if I told you that 5 is the same thing as 5 to the power 1 because it's just 5 by itself, right? I didn't do anything illegal. 1 all over 5 to the power 1, right? It's just 1/5. Now, if I take this base and I bring it up to the top, it's going to be 1 multiplied by 5 to the power -1. If you take something and you bring it up to the top, the sign for the power changes. So you'll get 5 to the power -1. Watch. And if you don't believe me, watch 5 to the power -1. It's the same thing as 1/5. Now, Tivon, if you go to divide, if you go to divide by sine, right? That's the same thing as 1/sine, yeah? Right. And this is the same thing as sine to the power 1. If you bring it up, what happens to the sign for the 1? It changes to -1. So yeah, everything connects in maths. Everything is connected. Everything is very, very connected. Mm.
So I like same or something.
Okay, you need to show that weekend. You need to show sign on this. You need to show that weekend. This weekend to get full marks. So
I would have see that and just put the style fraction like sign fraction.
don't tell me how to do this. This is not legal, you know. Wait. Stefan, this is not legal, you know. That's not legal, you know.
No, it's like sign. And I put like 9 sign code. So like that. Telling you how I would have think.
Well, probably some other people thinking like that. Guys, who thinking that they should divide by sine on both sides like this? Like I'm mad. Who thinking to do that? Be honest with me. It's a common mistake students just make. Yeah. Divide by sine and thing.
So if you do that, and you will have to remove the sign from by 9 and sine 45, or no?
I mean, no. Still, that would be very illegal. That would be very, very illegal. Let me ask that question, right? Sine 45 is what? Is that what? What is sine 45?
A number.
Exactly. Sine 45 is actually what? Sine 45 is actually 0.7. So I can replace this with 0.7. What are you gonna do now?
Or down.
You see what I mean, right? Sine 45 is a number. So like you can't just say sine cancel. No. That doesn't make any sense. Right? So no. You understand? Why did you?
Yeah.
Okay, cool. So I have to go now. We covered the essentials for trigonometry. So we looked at what you would do if you have a 90-degree angle triangle. You would use Pythagoras theorem if you have two sides. If you don't have two sides, you're going to use trig ratios, right? You have three types of trig ratios: sine, cos, and tangent. I showed you all how to find the length, how to find the angle. We looked at non-90-degree angle triangles. So I said, if you have an included angle, you use cosine rule. If you don't have an included angle, use sine rule. And to figure out which two you're going to select, look for a pair of information. Number one, look for a pair of information. And number two, I need you to look at what you're trying to find for. So yeah, guys, do you all feel a little better with circles and trigonometry now?
Yeah.
Yeah. Okay.
Definitely. I think
what
I'll be dreaming about it again tonight.
I would hope so. I would hope so.
So practically, that is what I do before I bought the calculator. I literally said, hey, let me find the cosine rule and see if it work. And test it out before I buy it.
But just imagine how much brackets you'd have. Well, truth be told, you wouldn't have much brackets, if you didn't have a sharp, but like it's much easier to look at on a Casio.
Because everywhere I go is just Casio. I mean, not Casio, sharp calculator they have. And I was like,
Boy, I'm not even kidding, right? I went into the bookstore and I asked him what calculator he have. He said he have a sharp. I say, oh, I need to close the bookstore down.
No lie, sir. It's because of you that I ended up asking my parents to get me a Casio because I see how good it was when I was watching your live stream.
Well, here this, here this. Like, I'm gonna show you how goated. Let me show you how crazy this Casio thing is, right? Let me just say you in a pinch, right? Watch this, right? Alpha, close bracket, squared, right? Equals to 5 squared plus 7 squared minus 2 open bracket 5, open bracket 5, close bracket, what's in open bracket 7, close bracket, right? Cos 49. You ready to be mind blown?
Yeah, sir.
I'm going to press shift, solve, right? Right, press equal. You see what I just now see, right? You see what I just now see.
Yeah.
The calculator just solved the entire thing for us. The entire thing.
yes, I feel like to solve my whole math paper for me too. So.
It could. Most
Where
things it
did
could
you
solve.
guys get yours?
Say that again?
Where did you guys get yours?
I had to walk around the whole of Arima to get mine in
I
like
Well, I'm
forgot
quite
the
upset.
store my parents got mine and I forgot the name of the store.
So I was driving around Tobago to all the bookstores, and none of them have the
My
Casio.
God.
All have sharp.
Wait, you from Tobago?
Like Trinidad and Tobago, I just live like back and forth.
Okay. I see.
so it must have another option that I get to the Casio. So
Yeah. You can get Sunway and Quast too. Those are the other options. Yeah, those are the other options. And they are cheaper as well. A Casio is like $300. Those calculators I'm telling you about is like $150. And it does the exact same thing. When I say exact same thing, I mean it's like a blatant knockoff. It does the like when you press the buttons, it does the same thing. Nothing different.
I get mine for 110 actually.
What?
Yeah, 110. The other place had it for like 130. And when I go to another place, it had it for 110. The same thing.
Boy, that's cheaper than a shop. Way, boy. Damn. Remember this joke? Damn, man. Yep. But yeah, guys. Hear what? If I was still awake, what time will ladies go to sleep? Like, on average. I don't sleep, eh? But what time will ladies go to
6
sleep?
a.m.
6
So I
a.m.
just go to bed 11 o'clock now.
All right, well, hear what? If I was still awake when I come
I
home,
went to sunrise again, so I not too long wake up.
that, well, you want me fall asleep on my glass or what?
No.
Man say
I
you
was
fall-
awake.
Oh. I want to know where me by not too long ago. But yeah, guys.
Like when class started, I had no wake up.
Okay, well, hear what? Let me hear what you all would prefer, right? Would you prefer we continue grinding when I come home? Or like I don't want to go anywhere tomorrow. So like I could go how long tomorrow? Like let me know. when I come home today, or just grind tomorrow?
Tomorrow.
Both.
Tomorrow.
Okay.
All right, so here what I want to do, right? Let's get a general consensus. You already have a base understanding of trigonometry, right? The only thing we need to do now is bearings and past paper questions. That's it. After this topic, let me get like a survey. What does make all the head loose? Like, what does kill all them?
Algebra.
Whole paper.
Algebra.
Vectors.
Statistics.
Somebody say vectors.
Wait, no.
Vectors and statistics.
Vectors and algebra.
Statistics, matrices, and construction.
The whole paper.
Yes, sir. Vectors and construction. Construction.
Okay, well, tomorrow, right? Tomorrow I could, when we finish, all I want to do vectors and construction.
And to talk more in geometry, how to do though? A measurement.
You talking about at the start of the paper. If you're talking about the end of the paper, wait,
No,
Michelle,
I know. Circle theorem is the last one for the end of the paper, and not that. But don't we have stuff to do with measurement and stuff like that?
yeah, that's the other part of geometry. But the specific section I was talking about was this section over here. But don't worry, we'll cover that. That's something that give you trouble.
Yeah. Bro,
Okay. And they bring it in paper 3, yeah? They love to bring that in paper 3.
paper 3.
Yeah. Let me show you what we're talking about. We did paper 3 the other day. I tell you all, if all here, all should have been in live, all I love all yourself. You want to work
And
with
we
it?
do how to do paper 3 if we do SP already.
Well, let me ask that question. You're writing for the first time or
Second time.
second time? So you have
Yeah.
it here already.
Yeah, I have my SP.
Oh, well, never mind. You don't have to do paper 3. But,
What is this paper 3?
I don't want to see.
Alright, bad.
watch. When we did paper 3, you had to do some construction questions.
What is that?
Well,
I being
I
real
mean-
with all you. I being real with all you. Like when I did this question for the first time, right? It took me a little, like, cause like it looked like gibberish, like all of this.
It is gibberish.
But we were able to figure it out. At the end of the day, we were able to figure it out.
so I think, let's see if I remember, I think it was in 2023, they brought one with pi, with circumference. I get so lost in that.
Hmm.
So
Okay.
paper
Well, here what? If I let down tomorrow, I just go in there. I'll try to cover as much work as I could, but I will not be rushing anything because if I rush anything, like again, most likely I'll here because I'll having trouble with maths.
Yeah.
I don't think it makes sense. I don't think it makes like I could have finished this long time as well as circles. But let's be real. I think I'll learn anything.
No.
No.
Exactly, right? I'm not bashing any teachers, but like I see some people having 2-hour maths crash courses for $300. Like what?
So it have $5,000 too.
Like what? What? That don't make any sense. That don't make
Exactly.
sense at all. Like if it was up to me, I'd do this for free. Like if I had my engineering job and I was making money, like mainly through that, I would just do this for free. I would just be awake 24/7 just teaching maths for free.
Yeah, be on doing this.
Yes, I could, Tivon.
Wait.
I could be awake
So you
24/7.
would be a good educational prime minister.
Fantastic.
Ready to go?
Good educational minister. I ain't gonna lie.
Say that again?
You'll be a good education minister.
Education minister. I don't know about that. I don't like dealing with corrupt people. And I'm not very corrupt. I'm a very genuine person. I doubt I could be in
No,
politics.
not the corrupt part, sir. Not the corrupt part.
I doubt I could be in politics. I doubt. I really, really doubt.
So you could stay back either tomorrow or the day after tomorrow and teach my consumer arithmetic.
Sure, no problem.
Okay, great.
Can I do anything tomorrow?
Yeah.
All right, well, I guess I'm not doing anything tomorrow. Again, once I awake, right? So
Nice.
yeah, guys. So you too. Okay, your friend said she too apparently. But yeah, guys.
Sleeping.
Like he gonna be asleep, or they should have seen him, right? Are they not about from me life?
Class,
I know, sir.
I
Okay,
remember
fine.
seeing him as co-host in the other classes.
Watch him. But anyways, guys, I hope this session was beneficial. I will see you all tomorrow. All right. Again, we're not taking any time. If we don't finish the syllabus, don't worry. I'll pay all the money. And well, I would do it for free anyways. We will continue until we finish the whole syllabus. Right. But I'll try to finish it in the allotted time. Yeah, guys. Have a blessed night. See you all later. It was a pleasure meeting some of you guys for the first time. Later, guys.
Wait, so sir, there's a possibility you might still do something later.
Yeah, a possibility. I crazy.
All right, say no more.
Yeah, later, guys. Bye.
Later, sir.
Bye.